Good morning and welcome to day one of the Crypto and Privacy Village at DEF CON 29. Thank you so much for joining us again remotely this year as we explore a theme, Alice and Bob in Wonderland. We look forward to sharing this year's talks with you, and we would love to welcome you also to come through the looking glass as we revisit some of our more notable talks from years past. Please don't forget to check out the CPV channels in the DEF CON Discord, and of course the Goldbug puzzle at cryptovillage.org. Wherever you're joining us from this weekend, whether you are in Vegas or whether you're at home, we hope that you are hanging in there. Thanks for the support, and we hope you enjoy. Next up, we have our first talk of the day, New Face, Who Dis? Protecting Privacy in an Era of Surveillance. Speaker Mike Kaiser is a Senior Identity Strategist at SailPoint Technologies, creator of Spartacus as a Service, which is a tool used for privacy through obfuscation, presented previously at Black Hat and DEF CON, and he's an aficionado of some very stylish hats. We hope you enjoy his talk presenting his latest tool developed to take on expanding use of facial recognition. Welcome, Mike.
This is what naval warfare used to look like. Two enemy fleets would line up opposite each other and fire away almost at point blank range until one of them would give up, retreat, accept defeat. All of that changed, though, in October of 1805. You see, Lord Admiral Nelson came up with a new innovative strategy for naval warfare at the Battle of Trafalgar. He decided that instead of opposite lines, he would just go straight at the enemy. You know what happens when you go straight at the enemy? Chaos ensues, right? Friend and foe mixed together, gets super confusing, super dangerous. And so for his technique to work, Nelson knew this would happen. And so he came up with a new innovative strategy for authenticating his own ships. It was called the Nelson Checker. And what it was they painted all his ships, legend has it, in this particular style that you see here. And it was innovative. And it did two things, right? It was accurate and it was easy to use. It was accurate because only his ships were painted like this. It was easy to use because a single glance told you all that you needed to know, right? A single glance, every ship, every crew, every sailor would know friend or foe and be able to take action. But soon enough, after that first battle, challenges arose for this innovative new technique, right? Challenges in the same vein as its advantages. Accuracy suffered because other navies started impersonating his ships, and it wasn't just the British ships that were painted like this any longer. And it was too easy to use. Even if there weren't issues with accuracy, he meant for only his ships and his sailors to be able to use it. But once the system was known, any sailor from any navy was able to use this technique. So it was too easy to use, too subject to misuse. And facial recognition is facing a similar point of departure, if you will. When it's used well, like on-device, secure enclave kind of techniques, just like the Nelson Checker, it's innovative authentication because it's accurate and it's easy to use, right? When it's done on the device, it's accurate and it's easy to use because you're just looking at your device. It's something you would do anyway. And when it gets it right, it can be a powerful tool for unlocking benefits to those that would otherwise not have it. Like, for example, in West Africa, with a mobile phone and some photo technology on the device, you can get access to loans or health insurance or other products that you may not have been able to get access to because of a lack of permanent home address or other infrastructure. But just like the Nelson Checker, challenges arose over time, right? With facial recognition, both in accuracy and in ease of use. There's been some bias issues, and it's kind of too easy to actually use these things. Let's talk in more detail one at a time here. On the accuracy front, we've seen over the last year and a half, report after report from people like Joy Bulawimi and Dr. Bulawini and her team from MIT have published various reports showing how facial recognition has issues when it comes to people who aren't white and male. The Algorithmic Justice League is all over this. The NIST followed suit, did their own studies. And that's even before you get to things like deepfake impersonation attempts. Accuracy is flawed in these use cases and some of this technology. Couple that with use by law enforcement and governments, people from governments from China to Russia to UK to Australia, all using facial recognition technology, which, if it's flawed and used for things like law enforcement, become a severe problem because now you are misidentifying suspects and claiming they've committed crimes when it's not necessarily true. And this is compounded by the ease of use, the abuse of this easy to use, everyone having access to these photos that are out on the internet. Also in the past year, we've seen organizations like Clearview AI who have gone out and they've scraped photos off of Facebook and other social media, put those into a database and sold them to law enforcement. Even if it's not proactively abusing the system, there are databases, such as what's in the Customs and Border Patrol database that has a database of facial biometric information, and that's at target, as we've seen over the last couple of years as well. Now, governments are realizing this, right? That the rights of their citizens need to be protected. Illinois has a biometric law. Canada and Sweden have outlawed predatory organizations in their countries, but let's face it, legislation is going to take a while to develop. And so that's where adversarial research comes into play. Now, historically, adversarial research was working on the accuracy problem, showing bias, detecting it, figuring out where it is. And the goal of that research was to remedy that bias, to make the technology work for everyone equally well. Flaws in data sets, flaws in algorithms and models, combating all of those that perpetuate systemic bias. But recently, in the past year to half year, there's been a shift in a new field of adversarial research opening up to address the ease of use, the ability that these facial images are out there and these photos are out there and everyone has access and it's subject to abuse and reuse in ways that people did not anticipate. If you put your photos up on a social media site, you want your friends and family to recognize you and you want them to be able to use and enjoy those photos, right? You don't want companies taking those and making a database so they can surveil you or they can wrongly accuse you of a crime. And so adversarial research is looking to address that second issue of everyone having access. What it's trying to do is to give people agency to still use these sites, but to protect their photos even as they do. How can we help them play a role in their own privacy? And the open source tool that I've developed seeks to further that effort. We'll talk about that here in just a bit. Like I said, there's been a wave of recent adversarial approaches, and so it's helpful to talk about some of them so that you can see the context of the app where this information came from. First one was around 2001 with gradients and pixel modification. What this did was it used geometric patterns and used something called fast sign gradient to go and figure out where the gradients were in an image, and it would modify pixels or sets of pixels in an effort to throw off some of these commercially available facial recognition systems. This worked decently well, surprisingly well, in fact, but because it's systematic, facial recognition systems can easily account for it and can work their way around it. Another example of this more recently are these generative adversarial networks. You may have seen samples of this from thispersondoesnotexist.com. What it's doing is it's using two machine learning systems in tandem, one that's a discriminator and one that's a generator, and basically repeating a loop, a feedback loop, until they get realistic looking samples that the discriminator can't tell aren't real faces. Now, these are great, but these are avatars, effectively, if you were to try to use this to protect your own photos, which is kind of not quite the point. You can do some of this, like tunifying yourself, that type of thing. But what you get is kind of a static representation of you. Now you're not your face, but you're this one other face. It's not dynamic. It doesn't protect per image. And also, to get something like photorealistic images, it takes a lot of process and compute power, which isn't always available to people. Another technique, this came about in July of 2020, it's called camera adversaria. And what it does is it injects procedural or Perlin noise into an image. This is dynamic. It's presented on every particular image. And what it does is it injects systematic noise, the same kind of noise that looks organic and is used in computer-generated terrain or landscape. And what this does is it messes with the classification of the object. There's an object, facial recognition is actually two parts, right? Detecting faces and then classifying or matching up those. And this messes with the detecting faces portion because instead of a face, it sees something else. A demo will help in this area. The Camera Adversaria app is an Android app, obviously, that uses the on-device camera. Taking a photo, or as in this case, selecting a pre-existing photo from the dedicated collection, results in the image being displayed in the main view. A classifier runs on the device itself, MobileNet-based, and gives the top classification of the image. Simplex noise is applied in a filter via the GPU image library, and then the object is reclassified after the image is redrawn. Here you can see that by moving the slider to a higher setting, the noise begins to reveal itself from the image, and distortion results. A leatherback turtle, chainmail, and other options are identified as the noise affects the classifier and the top result changes due to the perturbations. Now, around about the same time, maybe a little bit later in 2020, researchers announced from the University of Chicago an open source tool called Fox. And what this does is it takes your photos and then takes a set of someone else's photos and tries to combine or cloak your photos with some of the features from the other photo. And once it generates this new photo that's released into the wild, it gets fed into the training models for some of these facial recognition systems and pollutes the model, if you will. And then when your real photo comes out from a surveillance camera or elsewhere, it doesn't recognize exactly who you are. Now, obviously, with a lot of these, and especially in these next two, Fox and Loki, which I'll talk about in a moment, what they're doing is they're optimizing machine learning over something called some measure, of how perceptible the disturbance to the original photo is. In Fox's case, they use a structural dissimilarity index. And the idea is you want it to be recognizable and usable as you, but not useful for machine learning. Now, they announced this. It's open source, written in Python. And like I said, what it tries to do, it tries to move the set of features that the system recognizes as you to a different target, a secondary person, so that when it filters you or tries to figure out who you are, it says, oh, that's Frank instead of Mike in this case. You can see some examples with the Queen and Barack Obama on here. Keep in mind that this is a Python-based tool, which means you have to download that, you have to install Python, you have to download your photos, you have to run this program, which goes out and collects photos from a repository that it has of sample photos. It takes quite a while. All told, doing this on different levels takes from anywhere from a minute to like 8 to 10 minutes to 30 minutes on my MacBook Pro from 2019. So there's a process requirement and an overhead that's a steep learning curve with Fox. Now I'm going to go ahead and run the tool on the minimum level just to give you a sense of what it looks like and how it goes. And so when we run it, well, you see it load up, and then what it will first do is it will go and find the images that it wants to protect, which is in a default directory. So the way you would do this is you would run it on images that are already on your hard drive, and then apply the cloak protection, and then upload those, which is kind of inconvenient, and it's just why we made a mobile app for the other. You can see it find the target that it wants to use to shift the feature set. You can see it here setting up the mass generation function to set up the TensorFlow information and the functions it's going to use. And now it starts to go through each of the images, and it's training. It's developing a cloak, and I'm applying that cloak for one image at a time. And we'll go ahead and speed this up so we don't have to watch the whole thing. So you can see it took about 83 seconds to do those 4 images, and this gets a lot longer depending on the quality of cloaking or how much, what level you want to defend your images. Looking at what those images actually look like, we see the original image that's unmodified, and then we can cycle through, and you can see that, the minimum image has a little bit of modification, especially around some of the features. But it's, especially in small format, it's not that noticeable. This one took 88 seconds or so, about a minute and a half. When we flip up to low protection, you see the artifacts start to get stronger. And this was almost a 3-minute runtime. When we go up to the mid-level of protection, now you're talking in the order of 10 minutes for 4 images in this case. But it still kind of gets prohibitive. And then, of course, the high level modifies it greatly. I kind of resemble a cartoon villain from the old days. And for 4 images, it took 22 minutes. So like 5 minutes per image on the top level. Usability then is a key problem here, because that's going to, not only do you have to download the tool and run it, but it's a time-consuming process. If you look at the performance numbers that they published in the original paper, you see that Azure, Microsoft's Azure Face API is the main one they did well against. In January of 2021, they announced that Azure seemed to have caught up to them somehow. They were unclear how. And so they re-released a new version of this in April, and testing is ongoing. After Fox, beginning of this year, 2021, Loki was formally introduced via a paper. And Loki tries to do something similar to what Fox does. It tries to perturb images with other images and then optimize to minimize that loss, or that shift in perturbation. It uses a slightly different algorithm. And instead of just dealing with the classification or identifying who the person is, it also disturbs or tries to perturb the detection of faces in the first place. So it's kind of more of an end-to-end approach. Note that this, instead of downloading and running Python, this is a hosted web service, which means you have to upload your photos to a third-party web service and wait for them to be returned via email. It's all right, but ease of use could be better. We'll talk about that. Loki claims to be more effective than Fox across the board. And you'll note also that Loki reports its findings against a top N of lists of probable matches. And that's because when people actually use facial recognition, especially like in a law enforcement case, you don't say, here's my photo, match it against this one photo, there's my match, no matter what you saw on CSI or anything else. What you get is, here's my target photo, and you get a list of N, 1 to 50 to whatever you choose, top matches that are most likely to match. And law enforcement gets into trouble when they use this list as not just suspects, but perpetrators and these types. In summary, looking at all of these, adversarial approaches on the left, whether or not it has a mobile application, et cetera, in making this open source app called Ruse, I'm trying to take the best of all of these worlds. First off, just like facial recognition is useful when it's in the flow of things. Pick your phone up, look at it. For this to give agency to people trying to protect their photos, it has to be in the line of using a phone camera, right? You can't have to download your photos or, for heaven's sake, install and learn Python or even send your photos off to a third party site. It has to be in the moment, in the flow, before you actually save them to your camera roll. Also, protection needs to be per image. If it's not per image, facial recognition systems can account for it quickly and compensate. It needs to retain usefulness. In other words, it can't look like I've been severely injured in my own selfie, right? You want people to be pleased with it and not quite know that you've modified it to protect it. Then it needs to be cheap. Number of these techniques, low-key, Fox, these techniques are expensive. You need high levels of processor memory or functionality that TensorFlow, which is one of the machine learning systems languages, supports. And so if we're talking about keeping it on mobile, that eliminates quite a bit of these because mobile doesn't have the processing or the compute power often to deal with these things. And then ideally it would protect against both detection and classification. And that's what Ruse tries to do. As a general flow, what it's going to do is kind of have three phases. You'll take, it's a camera-based app, so you'll take a picture or take one from the camera roll. And then in phase one, you'll apply a style transfer, a very common method. If you've seen machine learning examples, you'll recognize this in just a minute. Once it modifies the image, you'll have a stylized image. In phase two, it'll automatically put in some procedural noise without the user doing anything, which will give you a final image. And then in phase three, you can evaluate it. On board right now, there is facial detection. In other words, can you detect a face in this image using Google ML Kit? And then it's kind of a feedback loop. You can alter these settings and then check for your protection, alter these settings, check for protection. Maybe it's too much, maybe it's too little. Once you're happy with it, you can save it to a dedicated album on the camera roll on the device or upload it to whatever social media site you prefer. Phase one, let's go through each of these. Fast style transfer. This is fairly well known. Lots of examples out there. Basically, what you have is a content image or original image and a style image. And the style image is some artistic style you want the end photo in. That style image is fed into a style prediction model, which creates this bottleneck, basically the top layer off of the MobileNet model. And that is then applied via a second model that applies that style to the content image, and you get a stylized image as a result. That's great, but we could do a step better. If we feed both the style image and the content image into that style prediction model, we can get two bottlenecks, right? Once we have two bottlenecks, we can decide how much style and how much original we want in the end photo. It gives us more control over how affected or how effective the style is in transforming image. We're going to use a Jupyter Notebook to show you the algorithmic flow that takes place as we go through the core of the open source app that I've developed. And so really here what you can already see is we're just importing the table stakes, right? Python 3.8 and TensorFlow 2.4. In the actual iOS app, of course, we'll be using TensorFlow Lite, and we'll use a nightly build with the metal parameter to make sure we can get the GPU acceleration on the iOS app itself that we're building in Xcode. Next step is to include a couple of libraries that will be helpful to do some math, some time calculations, so forth and so on. Some of these are available in Xcode, not all of them, so some of it we'll have to do some hand rolling of functions ourselves. What we'll also do is we'll go out and grab a couple of things for the demonstration. The first is the face, the picture of the person that we want to manipulate, to seek to protect in an adversarial fashion, and the other is the style that we want to transfer onto that person's face. And then finally, we will go and get both the prediction model as well as the transfer model. Both of these have been trained, and we'll use these. Since we have a GPU available to us on iOS, we'll use a Float 16 version of these, and that will give us a faster transfer. Note that The style and the models are all resident in the app. There are a couple of sample faces on the iOS app, but also you can use anything from the camera roll, and you can also just take a picture live as you normally would. So the next step is to pre-process the images that we want to use, both content and style, to prepare them for the model. They need to be RGB images with pixel values being float 32 numbers between 0 to 1, and a particular size. The style image has to be 256 by 256, and the content image must be 384 by 384. Luckily, TensorFlow gives us a lot of these methods already. Like, for example, the decode image you see there, and converting images between data types. Some of these will be available, but a lot of these will have to use with Swift's own UI handling and graphics processing. Finally, we print out the shape of the images just to make sure we're ready to go and they're ready to be used with the model. And you can see the appropriate shape there that models expect. The next step here is just to print out or visually display in the notebook the content and the style image that's been pre-processed. Just make sure it's a sanity check, make sure it looks like we think before we actually run them through the model. The next step is pretty straightforward. What we do is we take our pre-processed style image and place it on the input tensor for our style prediction model. We run it through the model, we run inference on it, and that reduces that style image down to a bottleneck that we can use in our transfer model to apply that style to our content image. Now that we have our style bottleneck and we already have our pre-processed content image, we can now feed these into the input tensors for our style transfer or transform model, and we actually get a stylized content image. It's 384 by 384 as a result, and it was relatively fast, which is what we're looking for. And that's good, but we can do better. Because if we run the content image that's been pre-processed through that style predict model, we can also get the bottleneck for the content image. And then if we have the bottlenecks for the content image and for the style image, now we can play with the ratio between those two and decide how much style input we want and how much content input we want. And we can have a whole range of stylized images, from very, very dislike the original to very, very close to the original, albeit slightly modified. And this is what's going to give us the dynamic filter effect, that every time you take an image and you stylize it, not only are you changing the style that you're applying, but you're also changing the impact of that style, which means you have different and a wider variety of resulting images. And you can also adjust the strength of that filter until it provides the protection that you're looking for the image that you have just taken or are concerned with. You can see samples here, right? The content image is on the far left, the original, and then the style image is on the far right. These are just 4 samples, but you can step all the way through from hardly much change at all the way to so modified that a human wouldn't recognize you. Your own mother might not recognize your photo. That just gives us a range that we can control in terms of level of protection, kind of like cloaking we saw. Now, note that this is designed for the mobile experience, right? And if you require network access, you kind of already lost. And so on board in the app, there are 32 default styles that come when you install the app. And so you can do that without the network being required. And keep in mind, the way the style prediction model was taught, it doesn't need a specific style. It can take any image in. Now, if you are on the network and you want to use that, so much the better. There are 80,000 additional images you could choose from. And what this does is it keeps that dynamic aspect in play. If you use the same image every time, the same style image, well, people are going to catch on, right? And machine learning will catch up to you and say, well, it's always this Van Gogh style transfers. We'll just take that out. Voila, we can get back to the original photo. But if you have 80,000 samples to choose from, well, now you've really enhanced that dynamic aspect. Once we're done with that style transfer, we move on to phase 2, procedural noise generation. And this is fairly cheap to do and fairly straightforward. We're going to use something called simplex noise because it's been demonstrated to impact classification. It's pretty fast for the size image we're going to use. It's uniquely generated on an image by image basis, which gives us that dynamic aspect. If you keep the amplitude low, it's less perceptible for the end user. It might look like a little bit of, fuzziness, but not too much. And it's an open source, already available function. So much the better. The less we have to do to keep, the better. Where our goal is to put technology and agency in the hands of normal people, not to make them jump through hoops. The faster we can do that. And then phase 3, like I said, is evaluation, right? You have the original photo. You can see the facial detection in the middle. Basically, it's Google ML Kit, and you click the detect faces button, link, whatever there in the bottom, and you get whether or not it's found it and the features. Now, you can see on the far right, style transfer has been applied fairly strongly, and so it can't detect face at all in the image. So you get some kind of instant feedback as to whether or not you're actually protecting your image. Let's take a look at the action. And now for a quick demo of the current open source app. Currently, the app is installed on the iPhone through Apple's Xcode application, but long term, my hope is that it will be available for free from the official App Store. Now, just to orient you to the app interface a little bit here, the top row allows you to cycle through a sampling of faces to modify with the next image link there. The option of selecting an existing photo from your camera roll, or to take a new photo with the built-in camera facility. The video icon you see there is for future use, but it's not supported at this time. The center view shows you the current image you're working with and its current status, and the middle tabs just beneath that allow you to cycle between the original photo, the style that you're applying to that original photo, and the images that result from the style transfer and the resulting simplex noise perturbation that's injected in, which you shouldn't be able to see in most cases. The style, I will note, is also displayed at the square at the bottom right with a change button you'll see here in action in a little bit that will let you select styles. Now, there's also a sliding scale right next to that style image that allows the user to adjust the impact between the original content image and the style image as it is applied. More like the style image, more like the original content image. You can slide back and forth, and once you apply the style, you'll see that impact. There's also a toggle switch to use or not use GPU acceleration. This is a relatively recent addition to TensorFlow Lite, and for performance reasons, obviously, it's best just leave that on, but it's there just for comparison's sake. Finally, at the bottom, there are buttons to left to right obfuscate the image, by which I mean apply the style, the option to detect faces or attempt to detect faces with Google's ML Kit, to clear any facial detection markings that you may have caused to appear on the image, and finally to save the current image as it's viewed to a dedicated album in the photo roll for the device. Let's run through a sample use case with a phone in the local park set to airplane mode, disconnected from the internet. The user starts up the app and then selects to take a new photo. Keep in mind, by the way, that the same process after image capture would apply to a photo selected from the device's photo roll. It's a rather handsome devil, if I may say so myself. Now, after he's captured the image, you should already notice that the app has center cropped the image in preparation for pre-processing. It's going to be adjusted down to 384 by 384 format eventually, so it's less jarring for the user to go ahead and convert it now to the square format at capture time. At this point, the user can opt to change the style that they wish to apply. It's good to switch this up regularly to make sure each image has a unique protection. At any point in the process, the user can opt to detect faces with the onboard detection feature. Not surprisingly, the unmodified face from the photo is easily identified. The user clears the face detection markings and moves the slider up to be highly stylized by the style image. This protects the image at the potential cost of human intelligibility. It is clearly modified. Running face detection again, however, shows that the face in the image has now avoided detection by Google's algorithm. The user can then adjust the slider, judging for the best combination of protection and usability for their particular use case. Shifting the slider closer to the content image results in the face being detected once more. Note that the app only provides an evaluation of face detection evasion. Later versions hope to include an estimation of how well a face can avoid classification after successful detection. Finally, users can opt to save any of the images appearing in the center view, particularly the ones that have been stylized, to the system's photo roll. The images are placed into a dedicated photo album, thus ensuring that the end user can trust that the photos that they choose to upload to social media or other online services have some measure of protection. So let's talk about how well this works. It's not rigorous testing as of yet. It was more a process that I went through to try and see if there was some impact effect. And so I took 50 individuals from a PubFig database as samples, and you can see that facial detection, the is there a face there or not, actually is affected. The combination of injecting that Perlin noise automatically, simplex noise automatically, and injecting a change in style in the photo has an impact. At the lower levels, not so much, but definitely by the higher levels, it actually hides people's faces. Now, it also modifies those faces fairly severely. But still, even if you're protecting 40, 50% of the time, that's a significant protection that might be worth it. Similarly, if we're looking at classification, matching up of face to face, we can see that even if it doesn't detect the face, it still has an impact on that as well. And so the upshot here is that it does impact both detection and classification, both of those components within facial recognition. And so it's worth investigating and finding further. Speaking of future work and further, first off, not on this slide, but obviously if this were to be used by normal people other than me, I would really want to rework the GUI interface into something like a social media app that already exists. And ease of use obviously is a key here that would need to be done. Formal testing against the big three, Azure, Amazon, and Face++. Maybe with the Face Scrub data set would be good. I also want to put on board facial classification evaluations, because right now I can detect whether or not I can find a face, but I also want to have it be trained against you yourself. And then you could take a photo and say, can you recognize this as me, at least at some base level, without using network access, without using a proprietary algorithm. So that's in the works. I'd also like to be able to scale the impact of that procedural or simplex noise to dial it up or dial it down in the same way as we're dialing style transfer. You also note that all the images were reduced in size, and part of that is scale and speed. And so doing higher res capability, there are techniques we could do that with, which require a bit more development. And then WebAssembly gives us the ability to offload some of this if we wanted to, and to do some of the higher order thing. As components and underlying infrastructure like TensorFlow start to adopt machine learning on the device itself and training of models on the device itself, then techniques like Loki and Fox begin to come into play. And we just have to weigh that against what the power of the particular. Might be asking yourself, is this practical? I would say yes and no, right? Given the results I have right now, I don't think a lot of people would use this and modify their photos so much that they're completely protected. It's always going to be a balance. They're limited by the power of the device. They're impacted by a number of factors. As the technology advances, like I said, I think it will get better and better and become much more plausible. At the same time, this does achieve the goal of giving people some kind of agency, and it It should serve as a signal to enterprise that some of these techniques could be used in the enterprise as well, in terms of protecting data at rest and photos in databases or an employee directory, applying some kind of protections, almost like hashing data at rest to protect it. Upshot, obviously, is that enterprise and individuals, like always, have roles to play, and protection of privacy and defending of individuals is always a team sport. If you're interested in helping out with this project, contact me on GitHub. The link is in the description here, and I'd love to have your contributions as well. A final note I wanted to add about facial recognition after recording the talk at large. It is true that if you've already placed photographs of yourself online, you're definitely facing a difficult challenge to poison the data enough that these machine learning algorithms will not identify an uncloaked, unperturbed photo of you, or say an image from a video surveillance system. The improvement that the Azure facial recognition system acquired against the Fox tool shows this quite well. Not only can these systems learn to defeat new techniques, they can also draw from a wealth of pre-existing data. Some may be correct in arguing that this cat and mouse game is not a cat and mouse game at all, that these adversarial approaches are doomed to failure. There does remain some value, however, in making things even slightly more difficult for these systems. First, it brings some level of protection for new photos. There are always going to be use cases, say, such as abuse or people stalking other people come to mind, where making it even slightly more difficult for systems to identify new photos and potentially their associated locations of vulnerable individuals can be useful in particular situations. Second, it raises awareness of the problem. The advances in technology and facial recognition and these surveillance systems are not fully known to the public at large, and making applications in easy-to-use formats can be helpful in capturing the public's attention and heightening awareness of the situation. Finally, that awareness can contribute to the public clamoring for legal protections against invasive technology. Almost everyone I talk to about this idea instantly reacts and says, yes, I want that. And as a consequence, what they really want is their governments and their social contracts that they've entered into to help protect them in these kind of situations, to protect their photos and their privacy, especially in an online environment. And in doing all of this, we're trying to send a message similar to one that Lord Admiral Nelson sent as he directed his ships at the enemy in the Battle of Trafalgar. He sent his last flag signal hoist and said something, and I'm paraphrasing, like, "It is expected that every person will do their duty." As I stated earlier, this is a team sport, and that approach is essential. We need agency for the individual, public awareness, governments creating appropriate legislation. All of these acting in tandem are necessary if we are to use technology ethically and in ways that benefit us all.
All right. Thank you so much for this wonderful talk. I know that as somebody who works on trying to test and fool these kinds of systems, it was really exciting for me to get to see somebody else sort of not only go through the process of developing different tools for it, but all the way to execution. So Mike, I was wondering actually when I was watching, was there like a particular user story or person that you were like thinking about while you were building it?
Not per se. I had already done a project called Spartacus as a Service, which kind of tried to give some kind of privacy against advertisement. And one of the offshoots of that tool, actually presented at the Crypto and Privacy Village in 2019, was biometric privacy. It was really obvious when I as part of that project, I created a fake persona to track how advertisers track this person. And I made this person unlike me. So it was someone who identified as female, graphics designer. Using a photo for this person was difficult. And so when I got one off of the stock photo repositories, I had a friend call me up and say, you can't use that picture. I said, why not? He said, well, it's already been used. And in my talk in 2019, I pointed out that that's actually the third rail of ensuring your own photographic privacy is to open source yourself, because she was used 25 billion times. So I knew that was a use case sitting out there to be had, but I also knew that that was a much longer road to think about where the research actually was, because I'm not a data scientist by profession, where it actually was to catch up and try and contribute something. So.
Yeah, I loved also that you kind of, I was wondering if you could talk a little bit more about your choice to use your particular recognition system that you did to sort of test your results, and like why you might have picked one over the other. I think often people there are like, okay, of course there are like a million of these, but what sort of led you to use that as your tester case?
Right. Well, the real testing that's done, I mentioned this in the talk, by the academic researchers in this area are, a couple of standard data sets. To be honest, what I used was whatever was low hanging fruit. So as often, a lot of people, you and I talked about this, a little while ago, a lot of people get held back by, well, I don't know what I'm doing. Neither do I. But I find that I understand things a lot more once I've written the code and played with it and see where it breaks and see where it doesn't break. So the object detection or the facial detection software really didn't matter to me, because a lot of those are very, 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 very similar in terms of, oh, that is a face or that's not a face. That's not as varied as the actual classification of faces. And so I was using just off the shelf. I went to Google, I went to Apple just to see what was already available. And so I used their frameworks and their open source stuff and then corrupted them endlessly, as I want to do. And in the process, learned a ton. So, yeah.
If you could have a dream system that's like actually deployed in the world that is not open source at this moment to access and test with, what would you want to be able to test it on?
Oh, wow. So a data set that I get to choose, or?
I mean,
I would,
it's like interesting. Yeah. Oh, sorry, I didn't.
no, go ahead. Go ahead.
I was just going to say, like, it's because often we're like working with these wonderful open source systems, and we know that they're statistically very close to closed source, like surveillance systems. So I'd love to know, like, if one was available to you, which one would you want to test it on?
I would love to do something that deals, I think, one of two areas, either like the Clearview AI system, just because they're reselling that to law enforcement, and that is a real tangible threat, I think, to particular people groups. Secondarily, something, I travel internationally a lot, and so I'd be fascinated to see border controls for the US and other places, just to see what governments have. And to be clear, I'm just one person doing proof of concept demo code that could be improved later on. I've got people saying, hey, are you gonna turn around and sell this? And I'm like, no, are you crazy? Because A, that's not really my jam. And B, if you're relying on this to, invade China or do something else against a nation state, you're kind of crazy, because the resources and data that they have collected are pretty significant, I think. So.
Yeah, that's really, really interesting, especially as you bring up sort of like resources that are available. Often one of the resources that's like really limiting for a lot of researchers is to have the ability to sort of test and generate samples that don't require you to be like an expert. I love that you took the next step and created this sort of proof of concept app that could be available for folks to actually use and play with it on your own. Often it's really hard to get folks to like actually build an implementation. So congrats on that first. But secondly, I was wondering, sort of, can you talk a little bit about that decision and some of the challenges that like you helped sort of, like, basically I would like to encourage more folks to try that, and any advice you have for them would be amazing.
Yeah, I would say a couple of things. One is pick something that you don't have to explain. When I talk about this, no one goes, could you say more about that? everyone says, yeah, the photos I put on anywhere, I want my own privacy, right? So that's really motivating. And then I think it's that I was physics back in university. And so I'm all about hard science and truth and knowledge and that kind of thing, which I respect, the academic researchers, and and they're doing really fascinating things. But like I said in the talk, there's this gap between that and the real world, right? And so writing an app, again, what I did was I took a sample app from Apple, and I didn't know how to write an app before, a month or 2 or 3 of coding. And so Apple actually makes it really easy, but using it and demonstrating the real world, it's a process of learning, right? The first time I showed it to people, I got different reactions. Some people were like, oh, that's kind of cool. Other people justifiably were like, yeah, that's kind of nightmare fuel, the photos that you're generating with this, which sure. So it's a varied audience. And I think that you can't let people kind of rain on your parade before the parade even gets started, so to speak. Because what you'll find, or at least what I've found, is even if my idea is half baked, I'll have a series of conversations with people who will either point me in the right direction or give me tips or be excited to come along and contribute and have a discussion with me. And if nothing else that it does is to raise awareness, then I'm all about that. You'll find use cases you never knew existed. After I talked about the Spartacus tool back in 2019, I had a couple of people come up to me and talk about stalk-aware and abused women and how they might be able to use something like that to buy time, not for ultimate protection, because that's a fool's errand probably, but to obfuscate their identity or their location. And so I think those use cases just kind of came out of the woodwork, to be honest. And then, people want to help. Like I've got a designer who heard about it, called me up and said, look, your UI is terrible. I said, I know. But she gave me some ideas of how to improve it, right? And how to, borrow known pathways, like what you're used to with Instagram and everything else. And what I think the name of the game at the end of the day is me wanting to make things more accessible, right? If you're not doing things in the normal flow of people's behavior, they're not going to use it. And so whatever security or other tool we generate, I use my partner kind of as my gold standard, because I know I have about 20 seconds to introduce, to pitch, and to demonstrate before, my partner's like, yeah, forget it. We're not doing this. So if it's not that easy to use, then it's not going to work for normal people. And that's what you want.
All right. I think my last question for you is, you said folks can reach out on your GitHub. Is there any particular skill set you'd love to have join you on working on this tool, or multiple skill sets, I should say?
Sure. I'd love really anybody is my first reaction. Second off, I think I've had some talk with graphics designers, but someone who's implemented some of it before would be great. And then I have some full-time data scientists, not on this project, but friends that are real data scientists. I'd love to have people to come along to help with the rigor of some of this testing, because to actually do formalized testing I'm out of my depth quickly. Not that it's impossible, it's just a long way to go. And then third, someone completely different. Like I love having people who are not normally in tech or not normally in data science or anything else, to just come along and give their opinion and to help out with really anything and everything. It's a team sport, like I said in my talk. So I think everyone has something to contribute. And a lot of times people are held back by, I don't know what I'm doing. Well, no, you do. Everyone has some area of expertise and something they can contribute. So.
Fantastic. Well, that is amazing. Thank you so much for presenting this tool today. I know we really all enjoyed getting, especially to see so many demos. I think it's just wonderful to see the stuff in the wild and show folks that, you can either join existing efforts or try it on your own. Thank you so much for being with us. And I think we look forward to kind of seeing you where this goes.
All right. Well, thank you very much, Kate.
Absolutely. All right, everyone. I think we're going to move to our next, our Gold Bug live Q&A, our discussion with our Gold Bug creators. So hang in there and we'll be on in just a second.
someone will tell us when we're live.
Okay, we are live. So let's talk about the gold bug. That's what we're here to talk about.
All right, awesome. So welcome everybody. This is our intro talk to the gold bug contest this year. Obviously, we are kind of in a weird world still, so we are running the contest virtually yet again. But we have a really cool bunch of puzzles for you. So let's just get right into it. So quick introduction. So my name's Kevin Hewlin. I'm CryptTalk on Discord. I'm one of the co-creators of the puzzle this year, and my job title is creator of problems. So Maya, can you introduce yourself?
Sure. I'm Maya Kaczorowski. I'm a product manager. I work in security, though I'm currently at this very moment unemployed. And yeah, I've just really liked puzzles. I've been doing puzzles for like 4 or 5 years. So we've been writing this hunt for, I think, 4 years, 5 years.
Something like that, yeah.
Let's talk about the theme for this year. So this year's Crypto Privacy Village theme is Alice and Bob in Wonderland, and that is great fodder for puzzles. So obviously Lewis Carroll, the author of Alice in Wonderland, liked puzzles and word games and all that kind of stuff, but there's just so many weird situations and weird characters and wordplay in Alice in Wonderland that we had a lot of things to go on. Anything you want to highlight in particular from Alice in Wonderland, Kevin?
No, well, I think it'll become apparent once they get into the puzzles that the themes are pretty much scattered throughout. So let's jump into talking about what is the format and how do you actually access the thing. So if you're in the Discord or monitoring Twitter, you should have seen a link to the gold bug puzzle contest. So as we've used in past years, we are yet again using our BBS server through the Goldbug webpage. I'm confident that you will enjoy the struggles of working with 1980s technology as you navigate the system and submit puzzle answers. And I look forward to all of the compliments of how awesome that process was. We do also have all of the puzzles accessible from our puzzle archive page. So if you are having some difficulty using the BBS or you just want a quick and easy way to get access to the puzzles, you can reach them from there. But you won't be able to submit the puzzle answers that way. You will have to use the BBS to submit puzzle answers. So apologies, sorry, not sorry. But that's it. So let's talk a little bit about the puzzle format. So as in past years, the puzzle contest is formatted as a puzzle hunt style contest. So we have a series of puzzles and meta puzzles. So this year we have 10 puzzles and only 1 meta puzzle. So all of the 10 puzzles feed in some kind of information into the meta puzzle that you'll have to figure out how they all fit together and how to pull out an answer from the meta. But the successful winning team will have to solve all of those 10 puzzles in the meta to lock it in, I guess. One advantage of a puzzle hunt format is that the puzzles themselves typically don't have interdependencies. So if you're working on a team or if you get stuck on one of the puzzles, you can just move on to a different puzzle. And it's also pretty easy to parallelize if you're have 2 or 3 people working at the same time.
Yeah, and it's not a rally style format, so there's no order in which you need to complete the puzzles. So if you like Kevin was just saying, if you find something hard, just drop it, go to something else, and hopefully you'll find something that you enjoy. So I think another thing for us to talk about a little bit is the difficulty system. So we did this a couple years ago. It was pretty popular because we used to also write kids puzzles, and then we found a lot of adults wanting to do the kids puzzles, which is totally fair. So try to have a mix of difficulty of puzzles in here. The difficulty system in the upper right This year we're using diamonds to denote that, because there's obviously a lot of like card themes in Alice in Wonderland. But if you are looking for something easier, look for something that's a 1 diamond or a 2 diamond. And if you're feeling up for a challenge, look for something that's a 5 diamond. Obviously, it's not a hard and fast rule. Like if you're super familiar with some crazy crypto systems and you know nothing about some kind of traditional ciphers, you might actually find something that's 4 or 5 diamonds easier for you because that's what you're familiar with. But just kind of like where we suggest you get started in terms of difficulty, or what you might even be able to do with your kids if that's what you want to do.
Yeah, I'll just add a quick comment. So the puzzles will range in difficulty from classic cryptography. If you're familiar with some of the maybe Mile hint at some of the ciphers that we've used, but classic cryptography all the way up to random algorithm that I made up when I was having a bad day. So I wish you the best of luck.
If it's not literally random, that would be a problem.
not quite random. There's a rhyme to the reason, but you have to figure that out.
Yeah. Teams? How teams work?
So we encourage you to form teams. So like we said, we have a Discord open. Encourage everyone to check out the Discord, bounce ideas off of each other, find other folks who are working on the puzzle, form up teams. We found that in the past, the more successful players are people who have worked on teams together. So that is probably a good option for you to work together. Plus, I mean, part of this contest is really forming a community and getting to know some people, maybe meeting some new people too. So we encourage you to form teams.
Is there like an optimal team size that you'd recommend or anything like that?
I would say that you probably want at least 2 or 3 people on your team. Higher numbers of teams, I mean, can be functional, but it becomes more difficult for everyone, number one, to feel like they're contributing, and number two, you run into kind of the too many chefs in the kitchen. It becomes more difficult to organize. That's not as big of a challenge for puzzle hunt style events because everything's pretty easily parallelizable, so it's not like anyone's gonna like mess things up. But I would aim for 2 or 3 team size.
And I would say you can still solve on your own. Like there's nothing stopping you from doing that, and you'll have a great time, I hope, as well.
That's right.
If you want to join a team or find a team, drop into the Discord and see if anyone's looking. That's a great place to go meet folks if you don't have some folks you want to work with already. Hints. Let's talk about hints. So throughout the weekend, we'll be dropping hints both on Discord and on Twitter. We're going to try to drop them in the same place at the same time, but one of those things has scheduling and one of them doesn't. So we'll see how that goes. We react to hints, and we react to what we give hints on based on what people are solving. So if we find that nobody's solving certain puzzles, especially towards the end of the weekend, we'll be dropping more hints for those puzzles to help you get there. So we do look at the scores to do that. If you follow the Crypto Privacy Village on Twitter, we'll use the same hashtag of Goldbug for all of the hints. And if you're in the Discord for CPV Goldbug text, you'll see all the hints coming from Kevin or myself in there. And we'll be very clear that it's a hint. There's not going to be like any hidden hints or anything like that. We'll be very explicit that there's a hint.
That's right. And I guess I'll add, we probably won't drop a whole lot of hints at the beginning of the contest. We want people to work on the puzzle, see how far we can get without hints. Probably starting tonight, early tomorrow, we'll start dropping hints more regularly. We might even towards the end of the contest just hop in the Discord channel and try to push teams towards the solutions if need be.
Yeah, and I would say if you're getting stuck somewhere, especially if you're not in the lead, and you're, like not in the top couple of teams, but you're just trying to have fun, feel free to message us and say like, hey, what do I do next? Like, I'm really confused. I'm just trying to have fun. And we'll try our best to help you out or push you in the right direction.
Yeah. We might not always be able to answer those questions, but it'll at least give us some insight into like what people are having challenges with, so that we can kind of mold our hints appropriately.
Yep.
And maybe one last thing to add there, we will also be having a Q&A tomorrow. So that'll be another good opportunity to ask questions, ask about the puzzles, and maybe even ask for some more hints on the particularly challenging ones.
Any recommended starting points or puzzles you'd get started on if you're just getting started?
So my recommendation would be to definitely look at the star system. I think some of the puzzles are more easily approachable, let's say. It's more obvious what the starting point is than in others. If you've looked at the puzzles, you might notice that some of them are quite cryptic in their in how they are written. Maybe you're given a poem and not a lot else, so just figuring out what you're supposed to do is going to be the challenge. So probably don't start with one of those. Start with one of the ones that it's maybe there's some you have some immediate ideas. So start with the low star ones. Let's see, Maya, did you want to talk about any puzzles in particular?
All I was gonna say was I think Pig and Pepper is probably the easiest puzzle in the hunt. Or I hope it is the easiest puzzle in the hunt. So if you don't know where to get started or are doing something with your kids, that's a great puzzle to go check out.
That's great. I will say, last I checked, so right before the stream, we actually had our first blood. So one team has already solved the Knave of Hearts puzzle. Yeah. So that might also be a good puzzle to start with.
Cool. Let's talk about our prize.
Yeah.
So it was very popular last year. So we got the same prize, obviously with the new, I have the box right here, with the new plaque. Apologies because I packed this really well and then I'm unpacking it. This is probably not very entertaining. It's like I feel like I'm in like a YouTube unboxing video or something.
Those are very entertaining.
I'm not like a 5-year-old, but I can hear that's what the kids are into these days.
What's in the box?
little box in a box.
It's another box.
And so this is the main prize. We will throw some other goodies in there, but this is the main thing you'd be getting if you won the hunt this weekend. It is a beautiful, it's going to be in focus, a beautiful steampunk beetle. Nice. Let me just change my settings. One sec. There you go. We'll see it now. Beautiful steampunk beetle. Crypto Privacy Village winner. You put it on your desk. You can mount it if you prefer to do that. Lots of options. So I'll just keep that up there because it's super cool. A couple of things about this. I have some info from the producer. All the beetles, this is a Xylotropes Gideon beetle. All the beetles are actually from preservation farms. So they're not like getting beetles in the wild and like killing them or anything like that. They're all beetles that are being bred to go back into the wild and like resuscitate populations. And these are the ones that die before they can go back to the wild. They're using things that would have died anyways and aren't actually harming the environment anyway. So that's super cool that somebody creates art out of this and it's steampunky and very fun and very cool.
That is awesome. I guess we can also comment in the past, at least one time, this contest was a black badge contest. So that is a possibility, not a guarantee, of course, but I know that is.
Yeah, if you're not familiar how black badge contests work, other than the main capture the flag, the contests are decided, black badges are decided based on like how hard people worked for it during the course of that weekend. So last year there was no black badges other than the capture the flag based on virtual contests. I don't think we have information this year yet, so we would love to be honored, and I'm sure you would love to win a black badge. So the point is participate in something because you like it, and then if you happen to get something out of it, that's even better.
That's right. That's right.
Any other like stories from past years you want to regale us with, or anything that we're hoping to see this year?
Yeah, so I will share that some of my inspiration for puzzles this year absolutely came from my experiences in past years. So you will probably see some puzzles that might look familiar, but maybe have a new twist on them. And you might see some other puzzles that make no sense, and I'll probably drop more hints about those. But you might look at my Twitter feed, and that might give you some hints of some past challenges that I went through solving puzzles. So I'll say no more.
Cool. Any parting words before we see everyone tomorrow for our Q&A?
Looking forward to an exciting contest. We will be, posting like screenshots of the scoreboard and things like that throughout the day. I think if you're watching us on Twitch, we have a scoreboard, maybe a ticker tape, and a live scoreboard that will be featured periodically. So yeah, looking forward to an exciting contest, and good luck to all the teams.
Yeah, good luck, everyone.
I am very pleased to introduce our next speaker, Craig Gidney, who joins us as a self-taught quantum researcher and software engineer. Today he brings his background in cryptography to development of software for quantum computing. Craig is somebody who has actually contributed a lot to my own understanding of how quantum computers work, what is the hype versus what is the reality, and especially what we in privacy and cryptography really need to know to understand how these computers impact the technology we work with. So I hope you really enjoy his talk. How expensive is quantum factoring really? Take it away, Craig.
Hello, my name is Craig. I am a software engineer / research scientist on Google's quantum computing team, and I'm here to talk to you about how expensive it is to factor with a quantum computer. Now, before we get into it, I should make it clear that I'm not here representing my employer, and I'm also not here representing the quantum computing community. In fact, a bunch of the things that I'm going to say in the presentation, I know people in the community who would pretty strongly disagree with them. And this kind of comes down to the fact that predicting the future is very difficult. We're going to be talking about 10, 20-year timescales here, and that's so much time that it's very difficult to say with any certainty what's actually going to happen. But with that in mind, let's move on. So the basic structure of the talk is, first I'm going to do something a little bit fun, which is not really about the cost of factoring. It's more just quantum mechanics being weird. I think for a talk on this topic, that's maybe one of the things that people are looking for, and I just wanted to provide that. Once we do that, we're going to get sort of into the meat of the talk, where we talk about what is it that's expensive about factoring on a quantum computer. Then we'll talk about the computers themselves and trying to meet those costs. So we'll talk about current quantum computers, noisy quantum computers, and why they would struggle to do factoring. And then we'll talk about error-corrected quantum computers, which are sort of far future machines, and the overheads that are involved in factoring on those machines. And then we'll contrast those bits of information with public roadmaps from companies in order to come to some conclusion about when we think factoring will happen. So let's go to that fun part, which is about something called the kickback effect. So here I have a logic circuit on the left-hand side. It has a single XOR gate. So you have two inputs, two outputs, and one of the outputs is produced by taking the difference of the two inputs. And the other output is just forwarded directly. And the puzzle is, can you put single input, single output processes around this XOR construction in order to flip the direction that it moves, so that instead of XORing the bottom into the top, it XORs the top into the bottom. Now, if you're familiar with logical circuits at all, then it doesn't take you too long to figure out that this is obviously impossible. The only things that you could possibly put in these blanks are a NOT gate or nothing, like a wire. And neither of those is going to work. Neither of those is going to fix the fact that on the left-hand side here, the data dependency is that the bottom depends on the top, but the top doesn't depend on the bottom. And on the right-hand side, it's the opposite. It's just not going to work. But quantumly, there actually is a way to do this. There's a quantum gate called the Hadamard gate. And the Hadamard gate, in fact, solves this problem. If you take a XOR gate going from one wire to another like this, and you surround that process with Hadamard gates, it flips the direction. Now, remember, this is completely impossible classically, and it's basically trivial quantumly. Like, this is, if you take a quantum computing course, this is one of the first things that they will teach you as part of a more general effect called phase kickback. And I really think that this speaks to what makes quantum mechanics different from classical mechanics, or why you can't think about quantum mechanical systems the same way you think about classical systems. Because the states that you have and the rules for how the operations are applied are different enough that what's possible and not possible kind of changes. Now, I'm actually not going to explain how this works. I'm not going to tell you how you figure out that these two things are equal, because I kind of purposefully wanted to pique your curiosity in order to have you go looking on your own for it. I will say it's potentially a little bit misleading to use this particular notation for the XOR gate as part of a quantum circuit, because if you have a quantum process like this, it's sort of important that it's implemented in a way that doesn't leak information. So you can't like buy an integrated chip that has a XOR gate on it and then go to a hypothetical quantum computing retailer and buy some Hadamard gates and wire them together and have this work. Because the XOR gate that's on the integrated chip is not protected enough. It like leaks heat and other stuff that would tell you what was flowing through it. And in order for this to actually work, it needs to not do that. Anyway, so there are little caveats like that, but basically, here is something that would never possibly work classically, but does work quantumly. So with the kind of little surprising, mind-blowing thing out of the way, let's move on to the meat of the presentation, which is what is the cost of factoring. So here on this slide, I am showing the steps that you use in order to perform factoring on a quantum computer. And as you can see, basically, only one of the steps is big. Like I've picked the font sizes so that the more expensive steps are bigger, sort of proportional to their cost, not exactly to scale. And from looking at this, you can maybe see that, yeah, there's some other stuff that happens, but it doesn't really matter. If you want to understand why the algorithm works, that stuff matters. But we only care about knowing how expensive the algorithm is. And if we only care about that, we don't need to pay any attention to the other steps. We just have to focus on this step, which performs a modular exponentiation. So let's talk a little bit more about what's actually going on in this modular exponentiation. So there are three numbers in this equation. There is this number on the right, which is n. This is the input into the problem. This is the number that you want to factor. Also on the left, there's this number g. This number is sort of arbitrary. It doesn't really matter what you pick, so we just kind of pick it randomly. And then there's the catch, which is this number x, the exponent. This number is a quantum number. It is a superposition of a bunch of different values. And that means that you can't store it using bits. You have to store it using qubits. You need to store it in a quantum computer. And if you can compute a function of it, you can't store the output of the function using bits. You have to store the output of the function also using qubits. This is why you need a quantum computer, is the fact that this number has to be quantum for this process to work. Now, how expensive is it actually to compute a modular exponentiation? Here I'm doing it on a classical computer for scale. So I opened up a Python instance. I generated a random 2048-bit number. I picked a random value of g. I didn't pick a quantum value of x. I just picked a random value of x. And then I computed the modular exponentiation of those three using this POW function that's built into Python. And I timed how long it took, and it took about 60 milliseconds. Now, based on this, you might expect that if we factored, since this is the most expensive step of factoring, and this takes 60 milliseconds on a classical machine, maybe the quantum factoring algorithm will also take roughly 60 milliseconds. And as we'll see later, that's not true at all. This is a totally misleading comparison to make. There's actually a lot of overhead that prevents it from being this good. Another way that we could sort of approach how expensive is it to do a modular exponentiation is to just break it down into simple pieces in a very oversimplified way. So one of the ways that you can do exponentiation is via this technique called repeated squaring, which basically breaks down the exponentiation into repeated multiplication. So the exponentiation turns into n multiplications. And then each of those multiplications can be broken down into n additions. And each of those additions can be broken down in turn into n carry ripples, so like from a ripple carry adder. Now, it's pretty simple for us to just say, okay, just multiply by n 3 times in order to get the number of basic gates you need. But for the purposes of this talk, this is actually good enough. Is it actually the case that the quantum factoring algorithm uses n cubed gates? No, not exactly. Technically, it's not even the right asymptotics, but actually, it's a pretty good estimate for the sizes of numbers that we're talking about here, with like 2,000 bits. And even though it's not quite right, it's simple, so I'm going to use it. And just using that simplified estimate, you can see why it's so compelling to factor on a quantum computer. If it's actually the case that the modular exponentiation is the most expensive step, then what you do on a quantum computer to factor takes n cubed operations, whereas if you wanted to factor with a classical machine using the general number field sieve, it needs way, way more than that. So here, I'm also massively oversimplifying the cost of the general number field sieve. This is a lower bound on it, past 128 bits. The main thing that you should be recognizing about these two equations is that in this one, n is in the exponent, whereas in this one, n is the base. And if you feed 2048 into this and into this, here you get a number that's like a million, 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 million operations. Whereas over here, you just get 10 billion-ish. So there's a massive difference in scale. Now we have a sense of how many operations we need, which is n cubed. So let's contrast that with what we're capable of doing with quantum computers today to get a sense of the numbers that we could factor now. So what we're currently in or entering is what's known as like the NISQ regime, which stands for noisy intermediate scale quantum. And basically what you should be picturing when I say that is like machines that have 50 to 1,000 qubits and then have gate error rates, so per operation error rates of 1 to 100 to 1 in 1,000. And to really give you a sense of what I mean when I say 1 in 100 error rates, let's do an experiment. Let's try to count on a quantum computer. So here is an increment circuit, a 3-bit incrementer, or I guess a 3-qubit incrementer. What happens if we go to a quantum computer and we try to repeatedly run this in order to count, starting from 0? Here's what that looks like. So I went to 2 different quantum computers from 2 different companies, and I ran this experiment on both of them. And here are the results. So along the horizontal axis of these plots is the number of times that I applied the incrementer. And along the vertical axis is the result that the quantum computer returned. If these were perfect machines, then what you'd expect to see is a very strong diagonal line going all the way from the bottom left to the top right, and black everywhere else. And you can see that that's not the case. Instead, the diagonal line kind of fades away relatively quickly. And in fact, by the time you've counted to 4, the chance that the machine is returning the right answer has dropped below 50%. It's more likely to be wrong than right. Now, probably I picked these machines on a slightly bad day. Every day they calibrate them, and so the performance will change a little bit from day to day. I probably picked a slightly bad day. And this circuit that I'm drawing is a little bit oversimplified. Actually this 3-qubit gate isn't native to the machine, so it has to be broken down into like 10 or 15 operations. But basically, this is about right if you incur a 1% failure rate per operation. This is roughly the decay that you would expect to see. And given that 1% failure rate, you can say, okay, then I expect to be able to do about 100 operations before I experience a failure. And if I can do 100 operations, then to figure out the number that I can factor with that many operations, I just take the cube root, because the number of operations it takes to factor is n cubed. So the cube root of 100 is between 4 and 5. So based on this very simple estimation, you'd say, okay, I should be able to factor 4-bit numbers and maybe 5-bit numbers. So that would be numbers like 15 and 21. And actually people have said that they have factored 15 and 21 with quantum computers. Although there's a little bit of a caveat there. So here's a paper from back in 2012 by some of my current coworkers. And in it, they claim that they factored 15 with a quantum computer. And the main thing that I want to point out is if you go into the paper and you look at the figure that shows the circuits that they ran, the circuits don't have enough stuff in them. So like this middle section is supposed to be the modular exponentiation, but there's only 2 gates in here, not 64. So what's going on? What's happening is that they've applied an optimization where the only thing that really matters about the operation you're applying is the period. So you're multiplying by g. How many times do you have to multiply by g mod n to get back to 1? What is the period? How long does it take it to cycle around? If that period is 2, in principle, you can replace it with something else that has period 2, and Shor's algorithm will run basically the same. And multiplication by g is kind of complicated. It would be much nicer to use something like a NOT gate, which also has period 2. And that's basically what's happening here, is that they've replaced the multiplication with something simpler that has the same period. Now, of course, this is kind of completely backwards, because the whole point of running the quantum part of Shor's algorithm is to do a task called period finding. You're trying to find the period. So it's a catch-22 to use the period to optimize the circuit that you're going to run in order to find the period. Still, at the time, in 2012, this was like completely state-of-the-art performance to run 10 gates and get a result out that wasn't completely garbage. So there's actually a lot of meat to this paper. And since this time, there's been a lot of improvements in quantum factoring. Sorry, I should be clear. There's been a lot of improvements in claiming that you've factored a number with a quantum computer. There's been a lot of techniques that have been come up with to improve the claims. So here's the most recent example that I'm aware of. 2 years ago, it was claimed that a 40-bit number was factored with a quantum computer. If you actually go and look into the details of what they did is first, they very carefully constructed a 40-bit number whose factoring problem was reducible to something much, much simpler. They reduced it to a 3-bit optimization problem. And once you've made the problem that small, it basically doesn't matter what you do beyond that point. But what they did is they put it onto a quantum computer and used something I think called QAOA in order to solve that optimization problem. And then they said based on that they factored this 40-bit number with a quantum computer. But of course, what actually factored it was this initial 40-bit to 3-bit step. And this kind of bugged me. This made me kind of angry that they claimed that they factored this number. Like, if these are the standards that we're holding ourselves to as a field in order to claim that a number is factored, then, let's hold ourselves to that standard. Let's really go for it. So I figured the only thing that I could do is one-up them. Because a coworker had told me about this result from 2013, where John Smolin and 2 others pointed out, for every number you might want to factor, there's a g, there's a base that makes it really easy to do. There's a value of g, which as you multiply by it, it has a period that's really, really small, like period 2. And since it's only the period that matters, and since the period is 2, you can replace it with something else, like a NOT gate. So it's sort of like no matter what you're trying to factor, if you have this special value of g, you just run the same period 2 quantum circuit, and that factors it with a quantum computer. So I did that. I generated 2 large prime numbers, multiplied them together, used this procedure from the paper in order to compute the value of g that would make it work, apply the optimization to reduce it to a single NOT gate, and And then I ran it on a quantum computer, like I submitted it to a quantum computer. Now, like basically the only thing that's interesting about running this circuit on a quantum computer is there's a 50-50 chance that it fails. Like small detail about Shor's algorithm. If it can return various results, and one of the results that it can return is 0. And if you get a 0, you failed. You can't get any information out from that normally. Now, this particular case is so oversimplified that instead of the 0 case being rare, it's almost the most common. Like it's a 50-50 shot. And I actually only ran it once. And I got lucky. The first time that I ran it, I got a 1 instead of a 0. So I forwarded that value of 1 and the value of g into the post-processing steps of Shor's algorithm, and it spit out the factors. And so I'm the one who has the record for the largest number factor of the quantum computer. And you know, I really am glad that there's absolutely no way that someone could take this away from me. Because the people at DEF CON wouldn't know how to generate 2 large prime numbers. And they wouldn't be able to follow a pretty straightforward explanation in that paper on Wikipedia for finding this value of g and doing the post-processing step in Shor's algorithm. And they definitely wouldn't know about IBM's quantum computing service, where they have a drag and drop interface where you can just make this circuit, submit it, and run it on a real quantum computer in like no time. So yeah, it really makes me feel good to know that, you know, tomorrow I'll still have this record, and it's no one can take it from me. Anyways, so that sort of concludes the part of the talk where I'm basically saying, like, there's no way you're going to run a big quantum factoring algorithm on these small machines. They're just too noisy. You know, you just take the cube root of 1 over the noise rate, and you basically figure the maximum number that it can factor within, you know, close enough, and it's just not going to work. So we need some way of getting the error rates down. And the way that we get the error rates down is using error correction. So there are a lot of ways of doing error correction on a quantum computer, but a particularly promising one is called the surface code. And what happens in the surface code is that you take your physical qubits and you arrange them into a grid, like a D by D grid. And then locally, what you're doing as fast as you possibly can is a bunch of like cross checks. So every one of the squares in the grid is like one cross check that you're doing. And the idea is, like, if there's a qubit at the intersections, like here, if there's a failure on this qubit, it'll set off the cross checks that are next to it. And that'll allow you to figure out that something went wrong and fix it. And now, the only way for something bad to happen and for you to not realize it is if the error that occurred is actually a string of errors going all the way from one side of the grid to the other. And this effectively makes this structure pretty reliable. You know, the structure forms a qubit, a logical qubit, made out of many physical qubits. And the structure as a whole has a reliability that's much higher than the individual physical qubits, as long as those physical qubits are some base level of reliable, like better than 1 in 100 failure rates. So if we're talking about physical error rates of 1 in 1,000, then the diameter of grid you would want in order to get like 1 in a trillion error rates or better, which are kind of what you need for factoring, then the diameter would need to be 25 to 30. So we're talking about 1,000 or 2,000 physical qubits to make each of these structures, which are our logical qubits. So that's quite a lot of overhead. Like, that's a factor of 1,000 overhead in space. There's also an overhead in time. You know, doing something with this logical structure is slower than doing things with the physical qubits. So here I have an example of that. So in the top left, I have one XOR gate. And we convert that into a surface code construction, which we draw with these little cartoons, which I know no one here understands. Although I will point out, you know, up here, there's a 3-way junction, which is black. And down here, there's a 3-way junction, which is black. And up here, there's another 3-way junction, which is sort of white. And down here, there's also a 3-way junction, which is white. So there's sort of an analogy between the structure of these two things, and that's not a coincidence. But anyways, The point of converting it into this form is that you can then inflate it into the actual stuff that you're going to do your physical qubits in a pretty automated way, like a very, very mechanistic way. But once you do that expansion with a code distance or diameter of 25 to 30, you find that you end up with this huge structure. You end up with a schedule or a plan for performing the XOR operation that has somehow become 100,000 microwave pulses. Like, you have your little loops of metal, which are your qubits, and you have your microwave pulses that you're bouncing off them in order to do operations. And somehow you've ended up having to do 100,000 distinct microwave pulses in order to do one XOR gate because of the overhead of quantum error correction. And actually, the XOR gate isn't even the worst one. The worst one is the AND gate. It's like 10 times worse, roughly, for technical reasons that I won't go into. But like classically, an AND gate is nothing. It's less than 1 transistor nanosecond in terms of the amount of hardware time that it requires. Quantumly, an AND gate that is protected is not nothing. It's 10 billion qubit nanoseconds. So what this is telling you is if you take a computation that you're going to run on a classical computer and you instead run it on a quantum computer, you are paying a penalty factor of 10 billion up front to run the computation on the quantum computer instead of the classical computer. So the only reason that you would ever do this is if actually there's going to be fewer operations on the quantum computer. And in fact, there has to be more than 10 billion times fewer, at least. And in the case of factoring, this actually happens. So if you remember, classically, factoring was a million operations, like 10 to the 24 level operations. Whereas quantumly, it was more like 10 billion, like 10 to the 10 level. And you divide those two and you get a factor that's still positive. One of the nice things about having this concrete number of 10 qubit seconds for doing an AND gate, and the AND gate being so expensive, is you can actually get a pretty good idea of how expensive it's going to be to run a quantum algorithm just by counting the AND gates. So when I said there are n cubed gates in factoring on a quantum computer, I really meant AND gates. So we can take 10 qubit seconds and we can multiply it by 2048 cubed. And then we multiply it by a twiddle factor, which is sort of arbitrary in order to account for other overheads, like the fact that qubits spend a lot of their time sitting still in storage, or that there are routing overheads. Sort of an arbitrary 5. Anyways, you multiply by it, and you get out here 120 million qubit hours, which I can then break down into 20 million qubits times 6 hours, sort of arbitrarily. And the only reason I broke it down this way is because actually a few years ago I put out a paper with Martin Akera, who is a Swedish cryptographer, where we first we improved the cost of factoring on a quantum computer pretty substantially by like a factor of 100, but also we did a pretty refined estimate of how expensive it would be to factor on a quantum computer. And the result of that much more involved estimate, where we were thinking about, where are we putting the computation area? Where are we putting the data? How are things moving around? The result of that was also 20 million qubits for not quite 6 hours, 8 hours. So the AND gate thing is giving a pretty good estimate compared to this much more involved process. Anyways, so on a quantum computer, you need 20 million physical qubits, you need 8 hours. And the question is that cheap or is that expensive? If you analogize this with doing a modular exponentiation classically, because the factoring computation is just a modular exponentiation and a little bit extra, then this seems awful. The time scale has gone up hugely, and actually the quantum computer has a lot of CPUs around it processing the measurement results that are coming off of the qubits at a pretty high rate and running like minimum weight perfect matching algorithms to solve where the errors are. So here there's only one CPU, but it's kind of hard to say how many CPUs there would be on the quantum computer, or whether they be even CPUs as opposed to more specialized hardware. But suppose that there are 10,000 of them. That's not helping this seeming really bad. But then you contrast with how expensive it is to factor classically. So 2 years ago, roughly, it was announced that RSA 250 had been factored, which is an 829-bit number. And they said in the announcement that it took around 2,700 CPU core years. Now, if you take 8 hours and you multiply by 10,000 CPUs, ignoring the qubits for now, that's way less than 2,700 CPU core years. So on this one slide, you can kind of see the paradox of quantum computing, where it's both way slower and way faster than a classical computer. I think it really drives home the fact that quantum computers don't beat classical computers by doing more. They beat classical computers by doing less. I should also give a caveat, which is the numbers that I'm giving here, like 160 million qubit hours, are assuming superconducting qubits. There are other types of qubits which have different strengths and different weaknesses. And if you do the estimates for those qubits, you'll get different numbers. I haven't actually done the estimates for those qubits generally. It's kind of difficult because the assumptions that go into the estimates will actually change a little bit. Like trapped ions, the time scale is slower, so that's pretty easy to account for just by multiplying by the slowdown. But also they have fewer connectivity constraints, and that might change how you go about routing the computation. Or photons have this really interesting trick where they could potentially use fiber optic lines as delay line memory, which would give them a pretty cheap way of storing things, which isn't the case for a superconducting qubit, where storage and compute qubits have basically the same cost. And again, this would completely change how you construct the computation. So it can take a lot of work to take this estimate and convert it to the other things. And I haven't done that. I'm purely talking about this one type of qubit. Okay, that sort of concludes the part of the talk where I discuss numbers on how expensive factoring is. Now I kind of want to contextualize those numbers into the real world in terms of how many years things are going to take based on company roadmaps, which is a very debatable methodology, but it's the best that I could think of doing. So here we go. Here is a roadmap published by Google recently at the Quantum Summer Symposium. And the key things that I want you to pick out of the slide are, first of all, before the midpoint, before 2025, say, they're saying that they'll have a logical qubit. They'll have 1,000 physical qubits making one really good logical qubit. And by the end, which is 2030, they're still not saying 10 million qubits. They're saying 1 million qubits. So logical qubit by 2025, but not quite at factoring by 2030. Now let's look at another roadmap. This one is from IBM's blog. This one doesn't extend all the way out to 2030. But again, we can see that before 2025, they're saying they'll have 1,000 physical qubits, which should allow them to make a really good logical qubit. So again, logical qubit by 2025. Here's another roadmap. This time it's from IonQ, from their investor presentation. So what this one claims is that by 2025, they'll have, well, you probably can't read this in the video, but this little superscript is saying to multiply to 64 by 16 to get 1,000. So again, we're talking about 1,000 physical qubits, which should allow them to make a really good logical qubit by 2025. And again, by 2030, they're still not saying that they'll have enough to run factoring. So all three of these roadmaps sort of agree on logical qubit by 2025, not quite factoring by 2030. And this is roughly in line with kind of what I expect. So again, disclaimer, I'm not here representing Google. I'm not here representing other members of the quantum community. And predicting the future is really hard, particularly over these 10 and 20-year timescales. But basically what I expect is that the first 2048-bit number will be factored between 2030 and 2040. The reason I think it'll take at least until 2030 is, these company roadmaps that I was showing, they have incentives to be over optimistic. And even with that into account, they're still not saying they're going to do it by 2030. In order for it to happen before 2030, I think basically there has to be some unexpected huge breakthrough in how quantum error correction is done or how physical qubits are made. And otherwise, it's hard to picture how it could happen. On the other end, in terms of 2040, if you just multiply by 2, you take the current physical qubit counts that we have, and you multiply by 2 every year, you get to 20 million by roughly 2040. So if you just project sort of Moore's law type growth, then we get there by 2040. No, of course, there could be some sort of financial crisis along the way where companies or governments become a lot more conservative and they kind of cut into far future tech like quantum computers and decide they don't want that. That's one way that the time it takes could go much longer. Or there could be some unexpected engineering obstacle, or a known engineering obstacle could be much harder to solve than expected that just kind of drags things out. Deadlines tend to move forward, not backwards. But basically, 2030 to 2040, what I expect. I should say I'm giving confidence intervals here, but you should know, first of all, I am not calibrated. What I mean by that is I haven't done calibration training where I make a lot of predictions, see how well I do, and adjust what I say my confidences are based on that. So when I say 80%, I don't actually know that that's really 80%. And secondly, I haven't gone to prediction markets and made bets about these things. I haven't put money on the line. I don't have skin in the game. So those are two big reasons for you to maybe have a grain of salt about these predictions. Anyways, to summarize what we've gone over in the talk. First, we went over a sort of weird quantum effect that you can't do classically, called the kickback effect. Then we talked about the fact that the most expensive step in factoring is a modular exponentiation, and that we would be using that to sort of decide how to think about how expensive factoring is. Third, we talked about current quantum computers and how noisy they are and how this is a rather large obstacle when you want to run a big quantum computation like factoring. And so then we moved on to what would you have to do in order to get noise low enough that you could run factoring. And we found that the overheads were quite large, but not large enough that they overcame the huge advantage you get from using a quantum algorithm instead of a classical algorithm on this problem. Then we used company roadmaps in order to try to contextualize timescales, which is definitely the squishiest part of this estimate, the most debatable for sure, and then made conclusions about how it would work. And that's the whole talk. Thank you for listening. I hope you enjoyed it. I know that I've wanted to give a talk at DEF CON for a long time. I'm glad that I finally got the opportunity to do so. And I guess we move into the Q&A now. I mean, I'm waiting for questions. Am I supposed to say something?
All right. Thanks so much, Craig. This is really great. I really appreciated hearing from you on this really complicated topic that I think a lot of folks in this space have a lot of questions about. We often hear a lot of hype, but I think it's really helpful for us to be able to hear directly from an expert who works with these machines basically every day. So I think when you're talking about factoring, it was really great to get that sort of nuts and bolts sort of introduction to what that means. What kind of crypto systems might use factoring? For example, I know large prime numbers are sometimes involved. And are there crypto systems that are potentially resistant to this sort of factoring?
Yeah, so I guess I'll mention one of the reasons that the other author on that paper where I reduced the cost of factoring was a cryptographer is because I'm not an expert in cryptography, but I know the RSA crypto system uses or reduces to the cost of factoring, and that if you can factor, you can break that. I don't know how widespread it is, to be honest. I know that there's standardization efforts in order to make post-quantum crypto systems, which are classical crypto systems that are secure against quantum computers. I haven't exactly tracked how far along they are. I know they've had submissions. I know people have broken some of them. Yeah, that's all I know.
Super interesting. So you mentioned actually, I thought it was really cool to see the slide in particular that had this sort of error rate. We're trying to count to 4 and how prominent that kind of issue is right now. You mentioned that these computers actually do need calibrating and that this affects the error rate. Can you give us sort of an insight after working with them directly and especially seeing what they look like in person, what that process of calibration looks like? How many people are involved? Is it done every day or just for experiments?
Yeah. So this is another question that I'm really not an expert on because I'm not a hardware engineer. But the calibration process is very complicated, and I know that they automate it as much as they can. Like when people from the team give talks about it, they show this slide, which is just this graph with like 100 nodes on it, and a little arrow pointing at one of the nodes that says like Jimmy Chen's thesis. So it's a very complicated procedure. It sort of comes down to the fact that these are analog physical systems, and you have to like find the frequency that they want to run at. You have to solve optimization problems for how you're going to try to put things in frequency space so they don't collide with each other. There are these things that come and go called TLSs, which is short for two-level system, which is short for, or long for qubit. Like there's qubits inside our qubits that we don't want, and they have to be avoided in particular ways. For the rate that calibrations happen, I think it's more daily than per experiment. You do have the option of trying to do special calibration for a specific experiment, like you're going to use particular operations, so you put more effort into those. Yeah, if there's anything more you wanted to know about it, I could talk more about it, but like I said, I'm really not an expert. I'm kind of talking outside of my comfort zone for sure.
Probably more expertise than almost everybody watching would have, which is why we really just appreciate it as well. So I think I have a talk here from the chat where somebody says, would you support moving to larger ECC keys between now and wide adoption of QC to be prepared for the possibility of breakthrough in quantum tech or computing? So let me also paste that. Mm-hmm.
So the cost of breaking ECC keys is roughly the same as the cost of factoring when it comes to a quantum computer, at least in terms of the sizes that they use. Like it turns out that right now it looks like the quantum security and the classical security are kind of similar, which is maybe a little surprising. So it seems pretty far out to have to worry about it right now. On the other hand, I know people encrypt stuff and they want it to stay secret for like 20 years and not 5 years. Definitely you could increase the sizes to protect against it. But on the other hand, if people have a breakthrough and all of a sudden they can make really big quantum computers, if you need to make the quantum computer twice as big to solve an ECC key that's twice as big, that's not such a big deal. So you're not buying yourself a lot of time. Like you might buy yourself a year by making it twice as big. So I don't know if I would support that as an effective strategy. It would be potentially helpful. I don't know if it's worth the cost or not. I haven't thought about it too much.
Yeah, I think it's kind of interesting to also think about these alternatives and sort of like how the size of the problem relates to each other. I know that there are questions also around like elliptic curve DLPs versus factoring, and kind of was curious about your thoughts there.
I mean, I addressed that in the last one. I think it turns out that right now it looks like the quantum costs are pretty similar. In terms of the number of operations, in terms of the amount of space, like the number of qubits that you need, the elliptic curves, because they're smaller problems, like 256-bit problems instead of 2048-bit problems, you don't need as much space to store them, but you need roughly as many operations to run them, and a pretty decent proportion of the space that you use is actually dedicated to just running the AND gates, to supporting these things we call just magic state factories. So it's actually probably the case that the elliptic curve stuff has an easier time trading space for time. So like maybe they could use 10 times as much time to cut the space in half, for example. Whereas with the factoring, it's much harder to do that.
Very interesting. I think one of the things that comes up for me, especially when we're talking about sort of like these different ideas of like what could happen and what might happen. I really appreciate that you mentioned that companies may make claims around, quantum factoring. And I think it's often really not visible to the rest of us who aren't like involved in the industry. What are some of the other factors either in the marketplace? Like I didn't know the wide variety of companies that are trying to get involved in quantum computing. So is there sort of like a canary factor in like the news or anything else that we should be looking at if some company makes a claim of successfully quantum factoring that we can use to kind of evaluate that claim?
Yeah, I would focus more on claims of error rates and qubit counts. So if they're saying that they have a qubit that has an error rate of 1 in a trillion, then that's good enough that if they had many of those, then they could do factoring. And obviously just having enough of them to store the problem, to store the accumulator registers and so forth that you need. I would basically ignore any claim that someone says they factored a number unless they have an accompanying error rate claim, because otherwise it's too easy to cheat, like way too easy.
This is super helpful, especially for folks who are trying to learn more about this, just to ensure that like we're doing our jobs right and understanding sort of these, when people talk very big about, quantum computing and RSA encryption. I appreciate actually that there's another comment in the chat that says, can you comment about when you think homomorphic crypto will be viable, including ASIC related hardware? Very interesting. Not something I'm familiar with personally.
I'm also not familiar with that, unfortunately. I mean, I know the term homomorphic encryption, but I didn't know the specific sequence of letters that you said after that, unfortunately. Sorry.
That's okay. If our question asker would like to maybe clarify a bit in chat, we'll still come back to that. But likewise, I think one of the other things that I really liked about your talk was kind of giving us a sort of timeline and understanding. Like I really appreciated, for example, that you had a slide up that said, 8 hours, but we're talking about like 20 million physical qubits. And that just is a very huge number, especially compared to the slides that show different companies assessing where they might be. So I think just getting even from these like thousands numbers to the millions, can you talk a little bit about some of the challenges that would be present for companies, like looking ahead past even to that, from like that 2030 to 2040 stuff they'd have to overcome? I know there's like materials challenges and things like that.
Oh, there's a ton of engineering challenges that have to be dealt with along the way. And like, there's so many that I'm not even sure that I'd pick out the hardest one. Like, for example, superconducting qubits, we run them by having like control wires that go to them. And if you have a 20 million qubit machine, that means you have 20 million wires coming out of the machine. Or your control process, like your CPUs running this minimally perfect matching algorithm, spewing off heat, have to go inside the dilution refrigerator closer to the chip. So there's that challenge of how do you get all the information out of the quantum computer to the classical computer without necessarily running 20 million wires. And if you do have to run 20 million wires, how do you fit them all into space? So like I've seen drawings that are publicly available of just like a person sitting next to what basically looks like a giant arc with like the fridge going down the middle and then just beams coming off of it with wires running along them just to spread things out enough that you can actually fit computers to do the control.
This sounds expensive and very physically constraining, especially with the temperature that might have to be maintained.
Yeah, you need a big fridge, or you need some way of talking between the fridges, which is actually very difficult. It's surprisingly difficult to get quantum information out of the fridge and into the like warm, noisy, terrifying world that we live in and to another fridge without destroying it along the way.
Yeah, and I think this kind of comes together with this notion. So like, let's say we've magically gotten in a time machine and we've transported ourselves to 2040 and we have the ability to decrypt 2048-bit RSA encrypted packet in my 8 hours. I would probably still have to be really good at picking the packet, wouldn't I? Like to get that to work for me at all, especially if my system is that large and that expensive.
Yeah. If we're assuming it takes 8 hours and that you only have one machine, then you'd have to have some idea of what you wanted to decrypt. And these protocols that do like ratcheting and keep recreating the keys. Basically, every time they ratcheted, you'd have to spend another 8 hours. So like, just two people sending a message back and forth, like a bunch of dots, could just cost the person trying to decrypt it like a week, potentially. Yeah. I haven't considered that part of the problem. Honestly, I'm not that interested in the like real attacks. I mostly wanted to know the cost of it so that we're kind of prepared, and that it didn't get to the case where we had a big enough machine and then someone's like, oh, it turns out you could just do this more cheaply than we thought, and we could actually do it last year, and they've been doing it this whole time. Yeah.
That's certainly something for us to always think about, sort of like that, the information that's absent, especially because of the competitive environment that all of this exists in right now. We have the kind of clarification to our question, which says that commenting on homomorphic cryptography that would be viable, including application-specific integrated circuit or dedicated hardware. I'm not sure if there's any more familiarity we have with those things, but.
Yeah, it's still not really specific enough. I know that there are like quantum protocols where you do processing on data that you don't know how to decrypt it. So there can be advantages to doing homomorphic stuff with a quantum computer. I think the overheads of it are going to be much larger than the classical equivalents for a while, and those are already pretty big, I think.
Very interesting.
I think it'd be more cool than financially practical.
Yeah, I would say that's kind of a weird undercurrent too. I think this entire discussion is that the relative cost, I think, of construction of some of these devices is sort of just very unknown to us generally, or like unknown to a layperson generally. And especially since we have this timeline that we might imagine we have, which is, to 2048. And to 2040, and I wanted to like phone up, especially as a privacy professional or somebody who's interested maybe in getting to work on these devices or experiment with them directly. If I do cryptography, and that would be super interesting to me. What are some of the resources that you use to self-teach, and like where can others sort of start looking themselves?
I mean, a lot of what I did was just writing computer programs that simulated these things that were described on like some blog post or in a textbook, and then having the program basically show me the consequences of the rule. And normally I wouldn't really bring that up as a thing that you could do, but I guess I assume the DEF CON audience is a lot of programmers in it where this is actually be a viable way of doing it. Like, of course, programming something, you tend to learn it as part of programming it, but additionally, for these counterintuitive sort of systems like quantum mechanics, the fact that it can show you the consequences can be very helpful, so that you can see that something doesn't work or that it works, and having that ground truth to come back to is very handy. There are lots of online lectures that are available, like on YouTube, where you can just watch university courses on it. There are textbooks. Mostly the background that you need is linear algebra. I would say don't go to a quantum physics course if you want to learn quantum computing, because you will need so much more calculus than is necessary. Like the physics is mostly about solving differential equations, and the computing has none of that.
I actually did not know that. That's duly noted. I think this, because it's an area I know where I'm trying to expand my own kind of basis of knowledge. I think we have another similar question in the chat on that sort of basic understanding those basic relationships, which I know you had gone through a little bit in your talk, some of the cost of classical computers per number of qubits. I think you had done it in sort of a different way of comparing like the same operation. But I think if there's any other information that you could give to help folks understand sort of like what hybrid models might be in use right now, and like how we might like sort of think about balancing those operations of like number of classical cores we need versus quantum computing operations.
Yeah, so I'm not too familiar with these hybrid schemes like QAOA or VQE. I don't remember what VQE stands for. I can see Jared in the background, by the way, who like invented it, and so I feel kind of bad. But generally what they tend to do is you have some quantum circuit that you're trying to run on the machine, and it's quite short, and you run it and you get some score, and you try to like tweak the parameters of the circuit to make the score go up. So you use some standard optimization algorithm like gradient descent or something in order to try to make the score go up. And you kind of use the circuit as like an oracle that tells you something that the classical computer can't tell you easily. I actually don't know what the like relative costs are. I assume that the model is mostly like data starved, and so that adding a bunch of classical computers might not be so useful, but I'm pretty far outside my element, honestly, on that. I know that there's recently been a paper where they showed that it's if you have this setup where you have the quantum oracle, you can learn some functions efficiently that you can't learn without it, which is like the first time that there's been sort of a concrete result shown that there's actually a speed up, instead of just people saying, well, it seems like it could work, so let's try it and let's hope that it does. So there's been progress in that area. But yeah, I'm sorry, I can't really tell you how many CPUs you need per qubit for that problem.
And thanks. I think actually it's really even helpful just to understand that there's so many different spaces within the set of problems that like you can be somebody who works directly with these systems all the time, and that the kind of different areas of usage or the kinds of different factors that we're all trying to look at in the world to make sure that we can sort of predict or try to ready ourselves for what's ahead. So thank you for stretching so much in your comfort zone for all the variety of questions we've had. I know that Craig is somebody who has really helped me better understand quantum computers and sort of like how to think about our threat model when we're like working in the space. So Craig, is there any other like space we can come find more of your work, or anything else you'd like to let us know before we sign out today?
There's not really anything else that I wanted to know. You can ask questions on the Quantum Computing Stack Exchange. I watch that. I'm on Twitter if you really want to talk to me. Yeah, standard mechanisms.
Well, thank you so much for all of your time today and for this great talk. I know I'm looking forward to referring to it later, but that's it for us. I think next we are moving into a lunch break. So everybody feel free to go grab a snack and hang in there for this afternoon's continuation of our programming. Thanks so much.
So I'm David Wong, but I'm going to skip the boring part and start right away. So I'll start with the timeline, and I have a date here, it's 2007, but that's an arbitrary date. And the point here is that back then, nobody really used SSL or used correctly SSL, especially before SSL was created. But even after it was created in the 90s, people would still use it incorrectly. And one of the first cases I could find of public display of that point was in 2007, when Steele Graham gave a talk at Black Hat and showed how SSL was misused in websites. So most of the time, websites use SSL to protect the login page, and after they revert back to unsecure HTTP. And that's bad because you can practically steal the session ID after. And I have a very short video of what happened on stage. So basically, man in the middle, everyone in the room, and then he used one of the cookies stole to connect on the Gmail of that person. And if we don't have... So I just thought that was funny. It's a very short video. It doesn't really have a point. But basically, it's one of the first time it was shown to hackers or tech people that you could do that kind of thing, and that SSL was important. And 2 years after, there's this Moxie guy who is playing with SSL and trying to break it. And he releases his tool SSL Strip at Black Hat. And what SSL Strip does is that basically, even if you use SSL correctly, the very first connection you make to a website is usually unsecure. So for example, if you connect on facebook.com, what you do is that you type facebook.com in your browser, and you never type HTTPS before that, right? So the first connection is made unsecurely, and then facebook.com in the example will reply with, hey man, can you actually use my HTTPS website? And that would be cool. And so your browser redirects you to the secure version of Facebook, and then you're good. And if you're man in the middling a victim, someone, you can basically remove that message, that redirection, and successfully man in the middle the entire website. And so that was pretty bad for SSL, right? It kind of breaks SSL. And so Firefox came up with the solution a year after, and it's called HSTS. And what HSTS basically is, it's a header. And so imagine you're connecting to facebook.com, same thing. You have this unsecure connection. And this time facebook.com will tell you, hey man, can you remember to connect to the HTTPS version of the website next time? And your browser will remember that, and it will add facebook.com to a list. And next time it will directly go in the secure version of the website. It's also the year of Fireship. If you don't know Fireship, it was a plugin for Firefox that you could use. You could just install it. It was very simple. And you could go to the nearest Starbucks and steal credentials. And it was so efficient that I think it's one of the first moments where the layman, the normal people started understanding the importance of SSL and HTTPS. And this thing made the news, and everybody started freaking out. Only 3 years after, Facebook goes full HTTPS. I chose Facebook because everybody knows, or back then it was one of the biggest websites. So kind of blows my mind that only 3 years ago, one of the biggest websites went full HTTPS. And it's also the year of Snowden. So we learn about Prism, and we learn about the NSA spying on us, and everybody started freaking out. And everybody started understanding this HTTPS and what does it mean. This last point doesn't really have, it's not really important, but I still want to talk about it. Whenever you use HSTS to counter this SSL strip attack, there is still one point of failure, and that's the very first connection you make. So the very first connection you make to Facebook, when Facebook will tell you, hey, remember me next time, go directly to the HTTPS version. Well, that very first connection is unsecure, right? And if you can break that, then you break HSTS as well. And so the solution came in 2010 from Chrome, and it's called preloaded HSTS, and you can basically guess what it is, right? It's a list that comes in your browser, and your browser knows that if you ever connect to these websites, you have to use HTTPS. In 2010, you had to manually email Adam Langley, and it was kind of not perfect. 2 years ago, they released a form that you can use online, and you can upload you can submit your websites, and the next version of Chrome will ship with your website as the preloaded HSTS. So the point of that timeline, or the point I'm trying to make, is that back then it was very easy to spy on people. You could just man in the middle people or be a node on the internet, and you could just read what was happening. And nowadays it's becoming harder and harder, especially because of Snowden, etc. And I'm not even talking about mail encryption or end-to-end messaging, end-to-end encryption, which is also becoming more and more secure. 2 more slides to prove my point that it's becoming harder and harder. Mozilla is thinking about deprecating HTTP altogether. And so in the future, when you will visit an HTTP website, you will see something that tells you that it's not secure. And I cannot also talk about all of this without mentioning Let's Encrypt, which is a new, as of today, a root certificate, but it has been operating since last year, December of last year, I think. And has, at the time of that screenshot, which was a few months ago, signed certificates, issued certificates for more than 7 million domains. So they issue certificates for free, and it's very easy. You just have to install that client on your server, and it will do all the hard work for you. So yeah, easy to spy on people back then, and now hard. The next story is the story of Logjam. Logjam was a paper released last year and has a bunch of authors, which is pretty rare, but many authors. And they had a lot of things to say. And one of the things they wanted to say was that if you have a website, you usually use a HTTP server to provide you websites. And Apache is one of them. And you can use that. There is a mod in Apache that allows you to use SSL. Or TLS. And if you use that to protect your connection for your users, and you use diffeomn to do a key uncheck in this TLS thing, usually you will use diffeomn ephemeral, because all implementations, actually I don't know any implementation that use plain diffeomn, and all implementations used ephemeral diffeomn. And ephemeral diffeomn is just using diffeomn with fresh keys for every different users. So if you're a server, if you're websites, and you have many users connecting to your websites, you will generate a different key to do a key exchange with every user. So the point here is that, the point of Logjam is that everyone would use the same parameters to generate those fresh keys. And you don't have to remember diffeomn. I'll re-explain after how it works and where are those hard-coded parameters important. But those hard-coded parameters that everyone was using were weak, and that was the problem. Another point that the paper made was that even 1024, so diffeomn 1024, was thought to be unsecure against the NSA or state-sized adversaries. And so we liked 1024, and now we're trying to move away from 1024, in particular with papers like Logjam that tells us that it's not as secure as we thought. But the point here, or my opinion here, is that it's too much work. If you're the NSA and you want to break those 1024 bits integer that are in diffeomn 1024, you have to do a lot of pre-computation, and it's actually not that easy. And then if you change that number in diffeomn, then you have to redo all the computation. And to prove that the NSA is very lazy and that they don't really want to do computations on numbers too much, let me talk about the US export rules. So if you're familiar with that, that was a set of rules of laws that we had. They still exist today, but they're way more relaxed. And basically back then, if you had a product and you wanted to sell it to foreign countries, export it abroad, you had to weaken your cryptography. For SSL, that means that you had to use these weak cipher suits that we called export cipher suits. And for example, in diffillment, you would use these 512-bit primes, which is a very small number, so diffillment 512. And for symmetric cryptography, you would use 40-bit keys for DES, for example. And so nowadays, we don't really have to do that, besides a list of blacklisted countries. But it's still biting us in the ass. If you look at all the last attacks on TLS, all the major attacks like Freak and Logjam, they're all pretty much downgrade attacks. So the implementations still have those weak algorithms in them, and you're using SSL but with secure parameters, and someone in the middle puts you back into these weak cipher suits. And so the NSA really liked at that time that they had to crack those 40-bit keys on DES, for example, and they really didn't want to do more than that. For example, Lotus Notes. Anyone used that software before? A few people, a few old people. So Lotus Notes made a deal with the US government. The US government allowed them to use 64-bit crypto for encrypting stuff with DES. If and only if they would give 24 bits of those keys to the NSA. And they would encrypt 24 bits of these keys that they would use to the NSS public key. And for the story, that key was called Big Brother. But basically, they were using that public key so that only the NSA could decrypt this information and use it. And that kind of backdoor actually has a name. It's called a kleptographic backdoor. So you use some asymmetric crypto to send some information to the right person. And cryptography works well as long as your crypto system is a black box. If you don't know what's happening underneath the program, then you cannot really see that backdoor. But if your system is a white box system, or if you can reverse engineer it, you're in trouble. It's pretty obvious, those kind of backdoors, and it doesn't work very well because we're getting more and more, we're using more and more open source libraries, right? So you cannot really hide those kleptographic backdoors in there. So we've seen that the weak crypto thing that the US government tried doesn't really work anymore, especially if you look at the list of supercomputers. China is the best right now. So the US might not be the only one being able to use those backdoors. Cryptographic backdoors, they don't work so much either because they're too obvious, and we're using more and more open source. So the NSA came up with a different scheme to try and spice things up. They invented this algorithm called duality, and if you were in the previous talk at the Crypto Village, you heard a bit about that. And duality is a PRNG. It's a random number generator. Yeah. Someone ask a question or? Oh. Duality is a PRNG. So you use it to generate random numbers. And this PRNG was standardized in the NIST document, in 2007. It was a 137 pages document, and duality was 1 out of 4 PRNGs being standardized. And the same year, we discovered that, 2 guys from Microsoft discovered that there might be a backdoor inside this PRNG. We got the proof of that a few years after when Snowden, the Snowden documents got leaked. And we discovered that the NSA was running a program called Bull Run, which aims to backdoor products to spy on people. And for the story, the UK has the same kind of program called Edge Hill. And we discovered as well that the NSA paid RSA $10 million so that they would implement this duality backdoor PRNG into their BSafe products. Juniper released a security bulletin last year in December, around Christmas. And they say that two vulnerabilities were found, but they didn't say where or what kind of vulnerabilities. But it was around Christmas, so every researcher was home, bored, and in 2 days it was reversed and we knew where the vulnerabilities were. And one was boring. I'll talk about the other one. The other one is interesting because you could spot it just by using that strings tool, just by analyzing the strings of the binaries. And so if you looked, I don't know if you can see, but if you look at the patched binaries and the vulnerable binaries, you can see that only one hex string was changed. And that was actually a point on a curve, which was a curve used in dual EC. And we found out that what was changed here was the owner of the backdoor, or rather, by changing that point, the backdoor changed of hands, basically. The point I try to make here is that dual EC is obvious. If you look at the construction of dual EC, it uses curves and it uses a very well-known property of curves. And basically, if you know how the points that are used in dual EC are generated, then you have access to a backdoor. And if you look at it, it's obvious. So with crypto, it doesn't work, right? Because we're not the only superpower being able to compute those big numbers. Cryptography doesn't work, it's too obvious, and those new backdoor algorithms like dual EC, well, it's too obvious, and we saw that when they tried that. It was a nice try, but on the same year, we realized that there was a backdoor. So it didn't last a very long time. So something interesting happened January of this year. Socat, which is a tool like Netcat, but much more. You can and they released their security advisory of their own. And one thing was really strange in there. So apparently, they were using OpenSSL to secure the data, to encrypt data. And OpenSSL was using DFLMN, this ephemeral version of DFLMN, right? And to generate those fresh keys, they were using hard-coded parameters, so like every libraries, like Apache and etc. Of course, you could generate your own parameters, but nobody really does that. And those parameters, in those parameters, there is a number that is supposed to be a prime, and we'll see what number it is. But that prime was actually not really a prime. And they say basically that the existence of a trapdoor, blah, blah, blah. So they think there is a backdoor. I'm like, a backdoor in DFLMN? That's interesting. That's interesting because everyone trusts DFLMN. That's the first public key crypto algorithm invented in the 70s. We've used that in the past, and nowadays everyone trusts it. Most of the inventors of DFLMN are actually alive. So that's a good thing. If we can backdoor that, then it's better than dual EC, right? Logjam told us that people use the same hard-coded parameters when they use DFLMN, and so that's good. If we can backdoor them, we can backdoor a lot of implementations or a lot of people. And the other good thing is that Logjam scared us from these 1024 bits parameters, and now people are moving away from these and trying to migrate to 2048 bits DFLMN. And so that's like the perfect excuse to submit a patch and say, hey, look at my bigger number, it's more secure, accept it. And then your backdoor is in place. Yeah, so what I said. All right, so now I'll recap DFLMN. Imagine that Alice and Bob wants to encrypt some data between them. First, they will usually do a key exchange so that they have this shared secret that they can use in AES, for example. So to do a key exchange with DFLMN, Alice will generate a number A. And then she will use two other numbers, G and N. And those are the hard-coded parameters that in TLS the server sends to the client, and the client has to accept them. And so when I was talking about Apache and everyone was using the same parameters, I was talking about this G and this N. And so basically, Alice takes this G, the generator, raise it to the power A, her private key, takes that number mod n, and that's her public key, and she sends that to Bob. And in the context of TLS, that would be Alice would be the server, and Bob would have to accept those parameters, and Bob would be the client. So here, Bob's do the same thing. He generates a number B, and that's his private key. Raise that public generator to the power B, mod n, and he sends that to Alice, his public key. So far, so good. And now Alice and Bob have enough information to compute the shared secrets. I'll just do that for Bob. But Bob can take Alice's public key, raise that to the power of his private key, mod n, and that's the shared secret. G raised to the power AB. So now that we've recapped diffie-Hellman, let me explain a bit of group theory. And I'm not sure of the level of everyone here. If you already know that, then that's a good recap before we see the attack. If you don't know that, then focus, and it's not going to be too hard. So I said that to use diffie-Hellman, you have to use parameters, right? And here the hard-coded parameters are G and N. And G is called the generator for a good reason. It's because it generates all the possible public keys in a group. So if you take the generator and you raise it to the different powers, you actually generate all the public keys, all the possible public keys in the group. Okay? And in our example of Alice generating a private key A and having a public key, for example, if Alice generates a private key 4, here G to the 4 mod n would be her public key. But we don't have an infinite number of public keys. We have actually a bound on the number of public keys, which is phi of n, which is a function of n. And we also call that Euler's torsion function, but it doesn't really matter here. And basically this function of n tells us how many public keys we have in a group. How many possible public keys we have in a group. And so if you raise G to the power phi of n, this function, you go back to the first element. And then if you continue raising this number, you go back to G square, and basically you reiterate through all the possible public keys one more time until you reach the n, and it's a loop. So I talked about that phi of n, which is the number of possible public keys in your group. That phi of n is actually very easy to compute if your modulus is a prime. So it should be a prime in diffie-Hellman, but we saw that in SOCAT it wasn't a prime. Okay? But if it is a prime, you just subtract 1 to that number, and it gives you the number of possible public keys. Very easy. Now imagine something else. Imagine that the modulus n is the multiplication of 2 primes, P and Q. So you might recognize RSA, right? Then it's a bit more complicated, and if you don't know P and Q, then you don't really know how to compute this number of possible public keys. And that's actually how RSA works, right? So in RSA, nobody knows P and Q, and so nobody can compute the number of possible public keys, and nobody can reverse the RSA problem. So that's one important information. Let's go to the second and last important information to understand the attacks. So imagine that you have your generator G. It generates all the possible public keys, right? Until the last public key. But now imagine that you want to create another group, and for that other group you take G square. And you say that G square is your new generator. So you take G square, you raise it to the power 2, then you raise it to the power 3, etc. And what you do is that you actually skip elements, right? There are some elements you're not going to have. And that is actually called a subgroup. And this is a very simplified explanation, but it doesn't happen all the time. But sometimes you pick a random public key and you use it as a generator, and it will generate a smaller group, a subgroup. And we have a method to obtain all the possible subgroups in a diffie-Hellman group. And imagine the modulus is a prime, P, in a diffie-Hellman. So I said that to compute the number of possible public keys, you just subtract 1 to that number. So P minus 1 is the number of possible public keys. And now if you factor that number into P1 times P2, etc., it tells you what possible subgroups you have. So here you have a subgroup of size P1, maybe. You have another subgroup of size P2, etc. Okay, that's enough group theory, and now let's see how we want to attack diffie-Hellman. So imagine that we have a public key, Alice's public key here, and we want to find what? We want to find A, right? We want to find Alice's private key. And that's actually called the discrete logarithm problem, by the way. And one way of finding that private key out of that public key is to take the generator G and raise it to all the different powers and check if it's equal to Alice's public key. That's a very naive way of doing it. It's called the trial multiplication, and it's of course not efficient at all. Other better ways of doing it, if you look at all the past records of the computing private keys out of public keys in large parameters, index calculus are the best kind of attacks we know, like a spatial number field sieve or the general number field sieve. The best attack was done this year in June 2016, and in a modulus of size 768 bits. So it's far from what we want to use. Nowadays we want to use diffie-Hellman 2048, so it doesn't work that much. We have better algorithms than that. We have algorithm that works well if the number of possible public keys your generator is generating is small. So imagine you choose another generator and it doesn't generate a lot of public keys, then you can use these kind of attacks. Shanks, baby step, giant step, polar row, and kangaroo. And here we'll use polar row because it doesn't take a lot of memory and we have enough information to use it. Clever attacks exist. If you look at active attacks, you have the small subgroup attacks. And I don't really like this one because you have to do many TLS handshake with a server to steal his key. And usually the server will generate new keys every time. So because he uses ephemeral diffie-Hellman, and so it doesn't work that well. Rather, we can use Polyg-Hellman, which is a passive attack. You just have to look at one key exchange between Alice and Bob, or a client and a server, and you can compute someone's private key, and so you can compute the shared secret. Let me explain in details how Polyg-Hellman works, but that's what we're going to use. So remember, we have this public key, and we want to find that private key. And so we observed Alice's public key during this key exchange, right? And we could theoretically attack either Bob's or Alice's public key, and then we would get the shared secrets, but we could also attack both and see which one come up first, but here it doesn't matter. So we have Alice's public key, and what we do is that we raise it to the power of something, and I won't go too much into the details. And once you raise that public key power something, it will place that public key in a smaller subgroup. So remember when I was talking about subgroups, I said that we have groups of smaller sizes. And when we place that public key in a group of smaller size, we can do these new attacks like polar row, because there aren't so many possible public keys. But what we get out of this attack is only a partial private key. We only obtain one information on the private key. But once we do that enough in enough subgroups, we obtain enough partial private keys, and we can stitch them together to form the real private key. And we usually stitch them together using the Chinese remainder theorem, which we call CRT. But again, won't go too much into the details here. So let's try to use Polyg-Hellman to place a backdoor in a group, in a diffie-Hellman group. So imagine that we have control over the modulus, that number P, and it's a prime, right? And we want to create many subgroups so that we can do the attack. So we create P prime such that P minus 1, which is the number of possible public keys, can be factored into small subgroups, small factors. And here we're trying to find X, the private key, from a public key Y. And so what we do is that we place that public key in all the different subgroups with our technique, we obtain a lot of partial private keys, and then we stitch them together with the Chinese remainder theorem. It's a bit complicated. The diagram doesn't really make any sense if you look at it too fast. But the point is that you can do Poly-Hellman here because you have many subgroups, and the many subgroups are the factors of this number of possible public keys. The bad thing here is that if your subgroups are small enough that you can do the Poly-Hellman attack, then they're small enough that anyone can factor p-1 and find those subgroups. And that means that anyone can use the backdoor. And it's not a no one but us backdoor. So what we want to do here is to hide all the factors of the number of possible public keys. And if you remember, I said that if that modulus p is not a prime, then we can hide the number of possible public keys, right? Exactly like RSA. And if you hide that number of possible public keys, then no one can access the factors of that number, which are the small subgroups. And so only you can use the backdoor to compute Poly-Hellman on those subgroups. And here, same thing, the diagram is a bit dense, but basically we hide, the first line is the most important, we hide all the subgroups inside the factorization of a non-prime number. So this is basically how the no one but us backdoor works. And I try to use Socat to implement it because, well, Socat is the perfect tool to test those things. And this is basically the code that Socat use. It's a copy and paste from some page on the internet. Everybody use the same code. And I just replace the modulus with my modulus. In a real situation, I would try to replace it with a larger modulus to tell the people that my number is bigger, so it's more secure. And they don't see that. And since nobody knows it has to be a prime, then it would most likely pass. I have a demo. It's a very quick demo, but still a demo. On the left side, you have the man in the middle. On the right side, you have a client and a server using Socat to chat. And basically, the man in the middle will detect the backdoor parameters and then will compute the private key out of the client or the server's public key. And then we'll have the shared secret to decrypt everything on the wire. So yeah, it's very fast. So they both connect, backdoor detected here. I derive all the keys, and here when they say something, you can, I don't know if you can see that, but you can see everything in the clear. So I could have tampered with the message as well, but here I'm just observing the messages passively. But it's a very efficient backdoor, and the only thing that blocks is that if they ever check if it's a prime. But if your patch is passed, then it's a win. The code is on GitHub if you want to look at it, play with it. And I'll have one last slide on how to detect and protect against that kind of backdoors. I'll wait for pictures. All right. So how do you detect and protect against these kind of backdoors? Well, if you check if the server is sending you a modulus that is prime, then you prevent this kind of no one but us backdoors, but you don't really prevent the other kind of backdoors that everybody can use. So to be sure, you have to detect if those primes are safe primes. And basically what safe primes are, there are specific kind of primes that minimize the number of subgroups, but maximize the size of your subgroup, so that you cannot use these kind of attacks. Actually, no browsers check for that. So if you browse the web, you will actually never detect that kind of backdoors. I actually did browse the web myself. Well, parse the internet to detect that kind of websites that would use composite modulus. I found like a dozen of them, but not really targets, except one which was a French government testing page. So I don't know what they're playing with. But The problem of defilament in browsers is more complicated than that. And if you look at Google Chrome, they're completely deprecating in the future versions. They're deprecating defilament because of the way it's used in TLS. It's not nice enough for us because we have to accept the server's parameters. And instead of defilament, they want to use elliptic curve defilament. So if you know elliptic curve, to do a key exchange in elliptic curves, we don't randomly generate parameters, but we use parameters from a predefined set of curves. So the same kind of attacks don't work. They can work, but if you control both the client and the server. So this is the end. Open question: how many VPN libraries, closed source, the open source products do you think have this kind of backdoors? And what about elliptic curve defilament? It's open research, an open problem, and there might be things to be found in there. Follow me on Twitter, and if you have any questions, now is the right time. Yes?
The tracking for the safe primes, that's, I mean, depends on what scenario, but it's not really practical because there are some cases that don't use safe primes, but still use secure parameters. For example, new TLS is generating other primes that don't,
Right, so you don't have, it's not because you don't have safe primes that you don't have secure parameters. And if you check for safe primes and you refuse websites that don't send you safe primes, you might not be able to browse the internet because not many websites use that. Yeah. Any other questions? All right. Again?
would you find it the same idea to say that the OpenSL API should reject parameters that are not prime? I mean, that would be relatively easy because checking for the prime like a browser, that's a performance issue.
Exactly.
If the software loads the parameters at startup, maybe I mean that doesn't really matter because that takes.
So the server should itself check if it's using a prime?
Yeah, like an OpenSSL API, because as overhead issue, if OpenSSL would have just rejected these parameters and the software wouldn't run, then this patch would have
Okay.
wouldn't have been applied because the software would be broken.
So if the server checks if he's using a prime, then that would be actually a very good fix. But
Basically the API of Open.
yeah, but then you can always remove that check if you really want to implement your backdoor. But at least it should prevent people from doing things that they don't know and creating a backdoor by mistake. But for intentional backdoors, it might be not as good. All right, thank you.
Next up, we have a lightning talk called Differential Privacy and Census Data with Wendy Edwards. Wendy is a software developer interested in the intersection of cybersecurity and data science. Today, she's going to be talking to us about how the Census Bureau used differential privacy to protect our data from being re-identified in combination with other big data sets in order to ensure privacy, while also ensuring that, as the Constitution requires, every American could
Hello, my name is Craig. I am a software engineer / research scientist on Google's quantum computing team, and I'm here to talk to you about how expensive it is to factor with a quantum computer. Now, before we get into it, I should
Hi, I'm Wendy Edwards. I'm Wayward710 on Twitter, and I'm here to talk about differential privacy and census data. So what is the census? The idea of the census is not really anything new. The first US Census took place in the year 1790. So from its website, the mission of the US Census is to provide quality.
Welcome back. Next up, we've got Playing God, how ambiguities in state and federal breach notification laws give lawyers too much discretion in deciding whether or not to disclose potential data breaches, with Jordan Sessler and Anthony Hendricks. As a lawyer who has to teach other students about data breach notification laws and the patchwork thereof across the 50 states in our great United States of America, I'm very excited for this talk, and I know you'll enjoy it. Thanks for coming.
Hi, I'm Wendy Edwards. I'm Wayward710 on Twitter, and I'm here to talk about differential privacy and census data. So what is the census? The idea of the census is not really anything new. The first US Census took place in the year 1790. So from its website, the mission of the US Census is to provide quality data about US people and economy. So what's it used for? Redistricting, government planning, allocation of funds. In fact, there are fairly significant financial implications to the census, such as why many of you may have heard your local government encouraging you to fill out your census form and become.
Welcome to Playing God. Today we're going to be talking about what sort of security incidents count as a data breach and need to be reported as a data breach, and just how much discretion there is, particularly for lawyers, in deciding what is a data breach. As a result, we're going to be talking about some of the ethical and privacy implications, and sort of ways that we could solve this problem or reduce that level of discretion in the future. As you heard in the introduction, my name's Jordan Sessler. I'm an attorney with Crowe & Dunleavy's Cybersecurity and Data Privacy Practice Group. I'm joined today by Anthony Hendricks, who's a colleague of mine, a mentor of mine, and long an active voice in this sphere. I want to pause quickly to say that while we're lawyers, we're not your lawyers. And while this PowerPoint presentation talks about the law, it is not legal advice. Every situation is different, and if you have a legal question, you should talk to a lawyer. It could be us, it could be someone else, but it should not be this PowerPoint presentation. Now, to start us off for real, I always like to start with a 30,000-foot view of what we're talking about, why we're talking about it, and why we think it's important, why Anthony and I are spending the time to talk to you today. Now, I think everyone watching is pretty familiar with the security incident. Whenever you have data or whenever you're trying to keep something private, and that privacy may be compromised. But data breaches are actually a term of art created by statute, where the law says that a certain type of security incident requires reporting. And so as a result, it's a subset of this larger field of what we would say is a security incident. And we see this a lot in how different people refer to different things. So in the past year, we've seen a lot of commentators differentiate between privacy events on the one hand and data breaches on the other, with the idea that sometimes you might have a security incident that doesn't rise to the level of a data breach. That would be a privacy event. And sometimes you might have a data breach. Usually, based off of the law, which we'll talk about in a minute, the difference here is usually about whether or not potential access by a third party allowed that third party to take the data or use the data, and whether or not that third party was going to use that data for a bad purpose, such as identity theft. And so in general, you'll see this line between most security incidents and data breaches delineated just by whether a third party took data and whether a third party intended to use it improperly. What we're going to talk about today, I think, is sort of three questions that are raised by that framework. One, how bright is this dividing line between a privacy event and a data breach? And two, as cybercrime evolves over time and use of data evolves over time, is this a distinction without difference? So particularly, today we're seeing a lot of ransomware attacks, and the goal of that cybercrime is different than 10 years ago, when the goal might have been to take data and use it to steal consumer identities. And finally, do consumers have a right to know when their data has been accessed and shared with a third party involuntarily, even if there's no evidence of identity theft or misuse, right? Is this now a privacy concern where consumers deserve to know what has happened to their data? And so in order to explain the situation and discuss some of these issues, we're going to start by walking you through the current notification laws that exist for data breaches, some of the implications of those laws, how these laws essentially ask lawyers to play God in what counts as a data breach and what doesn't, and then some potential solutions. And so because we're lawyers, we're going to start with a legal lesson, and I'm going to turn it over to Anthony to talk about how the law deals with data breaches.
Sure. So one of the first questions I always get from clients is, do I have to report this? And so the question becomes, what is a data breach? You've probably seen those headlines in the newspapers where millions of records from a company have been exposed online. But we're starting to see some incidences where a company says, sure, there might be all of these records exposed, but it wasn't actually a breach. For example, this year, LinkedIn recently stated that the information found online and being sold on the dark web about its users was actually not a data breach, but instead their information was scraped from the internet, that it was publicly available information, and it's not considered a breach, and so they have no obligation to report to their users. And so now it adds a little bit of confusion for us to understand what exactly is a breach. And so it's a type of security incident that requires reporting under the law. And so each state has their various different breach notification laws and breach reporting requirements, along with a number of different federal laws and regulations that have to do with data breaches. And so all of these definitions breaches are narrower than the definition of a security incident, which we'll be using and which Jordan talked to you a little bit about earlier. And all of these definitions kind of leave some wiggle room and some discretion for attorneys. So there are three approaches that states have taken when we talk about what is a data breach. And so we have this idea of acquisition, which is the reasonable belief that data was acquired or reasonably could have been acquired by a third party. And so this is the California definition. And this is probably the approach that most people think of when you say data breach. Someone came in and took your stuff. So we also have this idea of misuse. And so misuse is the unauthorized acquisition of data that compromises the security, confidentiality, or integrity of the data. And so someone came in and they took your data and it impacted the security, confidentiality, or integrity. And then we have this third approach, and this actually comes from my home state, Oklahoma, which is the reasonable belief that unauthorized acquisition of data has caused or will cause identity theft or fraud. And so this final definition kind of causes some issues because a lot of times clients will say, well, we don't have any evidence that it's going to cause identity theft or fraud, and they may have just taken it just to take it. And so you can start to see where some of these definitions can cause some problems. So next idea I want to talk about is what is a reasonable belief of unauthorized acquisition. So data was accessible when it was not supposed to be there, and there's some reason to believe that an unauthorized third party acquired it. And so during investigations, and when you talk to clients, and they hear these definitions, and you go through and you kind of explain their reporting obligations, they start to ask questions of, well, I don't see any proof. There's no proof that this information was acquired and used by a third party. And it may be some difficulty because sometimes access logs that may provide this information were deleted by the attacker. Sometimes companies aren't able to gather all the information needed for a thorough investigation. And so there may be some holes for proof. And then another thing is that when we look at these definitions for data breaches, they look at the lack of encryption. And so if the information is encrypted, you usually get a pass on having to report the incident. But if it's unencrypted information, then there's a presumption in a lot of states, including California and in Oklahoma, that this information should be reported. So I want to talk to you another part of aspect of this is where there's a reasonable belief that misuse will occur. And so this is kind of a risk or harm analysis, and this one is where things get a little trickier. So its notification is not required if after a good faith investigation, misuse of personal identifiable information has not occurred and it is not likely to occur. And so that places a greater emphasis on the investigation. What does the investigation find? And sometimes investigations can find all types of information, and it's abundantly clear what happened and what's going on. But in other instances, it not so much. And so finally, I want to talk about what is a reasonable belief that theft occurred. And this again was the Oklahoma standard. It's subjective. It's a reason to suspect identity theft or fraud. And so there's not a real clear definition. And so it leaves a lot of wiggle room and a lot of analysis and a lot of discretion. And so it causes a lot of conflict between lawyers and clients when it's a subjective standard, because there is a lot of consequences in reporting a breach. And so Jordan added this definition in here, this piece of regulation from the Veterans Affairs. And so I think that kind of gives us just a little bit of guidance. The risk analysis shall include a finding with supporting rationale concerning whether the circumstances create a reasonable risk that sensitive personal information potentially may have been used for illegal means. And so even here, there's a lot of wiggle room because our lawyers are good at arguing, and so we can argue one way or another to support our client's position on breaches. So I kind of want to just hand this over to Jordan to kind of give us just a summary of kind of what we've learned, and then go into the next steps of other factors that should be weighed.
Yeah, thanks, Anthony. I think one of the last points you made there about lawyers being able to argue things multiple ways is pretty revealing, right? We've looked a little bit at what makes a security incident a reportable data breach, and we sort of see that you would need to have a reasonable belief that sensitive information was accessible. You'd have to have a reasonable belief that it was accessed and acquired by a third party, and then you would have to have some sort of reasonable belief that it would actually be misused or used for identity theft or some sort of other fraud. And so what you're seeing there is multiple levels of reasonable belief. And you might ask yourself, like, are there better definitions for reasonable belief than we just put on the board over the last few slides? And the answer is sometimes yes, but mostly not. And this is not necessarily problematic. There are plenty of places in the law where we simply, as lawyers, ask, or judges ask, or juries ask, what would a reasonable person do here, right? And so you might be able to say, based off of the specific circumstances of a particular breach, yeah, there was a reasonable outcome, or there was a reasonable risk, or there wasn't, or there was not. But what is a little bit strange about this in the context of technology and of data breaches is that we're just not getting the clarification that we would get in other parts of the law. So usually in other parts of the law, there may be a statute that sets out a general standard, and then an agency will provide guidance or letters or regulations that clarifies what that means, or courts will interpret that law, and you'll get judicial decisions in case law that explain what's going on. And we really just don't get that very much in this sphere, which means that we are often allowing individual lawyers or companies to decide when a reasonable belief exists and when it doesn't. I like to just sort of use as an example here Title VII of the Civil Rights Act, which prohibited discrimination in the workplace. And for about 50 years, Title VII was in place, but people did not know whether it included and protected against sexual preference discrimination for the LGBTQ community. But there was guidance that was provided by state courts and federal courts. Even if it was sometimes inconsistent, federal agencies did advise sometimes that it protected against it and sometimes that it didn't, usually based off of political administration. Democratic administration said it did, Republican administration said it didn't, but at least during the duration of that administration, people had a sense of what the government believed. And then eventually last year, after 50 years, there was a case, Bostock v. Clayton County, in which Gorsuch wrote for the majority of the court saying that yes, definitively, Title VII protects against sexual preference discrimination. Here, in the data breach sphere, we've not gotten really any guidance like that. And there's a few reasons for this. In addition to being sort of wishy-washy on what counts as a data breach, many of these laws have limited reporting obligations to agencies. So they require that individuals who are affected by a data breach get notification, but they don't always require that governmental agencies or law enforcement get that notification. And that really deprives law enforcement and agencies of the opportunity to monitor what's going on and then provide guidance, either through enforcement actions or advisories that can help clarify what a reasonable belief means. Further, there's limited enforceability of these laws. So some of these laws create private rights of action, some don't. Even where there's a private right of action, unless there's a statutory damages provision that says if there's a data breach, you're entitled to this much money no matter what, like the CCPA does, in most situations, in order to sue in court, you have to have standing, which means you have to show an injury, causation, and redressability. And essentially that means that in a data breach case, you have to be able to show that a data breach occurred, that you suffered identity theft as a result, and that you have actual damages from your identity theft. And no one wants to wait for years and allow their identity to be stolen in order to litigate what a data breach means and if they should have gotten notice of it, because no one wants their identity stolen. And so the result of this is that there just are not that many data breach cases coming up to courts in which courts clarify when notification was needed. Usually by the time they're coming up to courts, we see them in these big class actions where the real issue is just what damages everyone should get. So again, we're just not getting clarification on what reasonable belief means. And the result of that is that someone has to decide that. And as Anthony said, this usually falls to individual lawyers or companies. And it means that almost every data breach, which has slightly different facts, can come out a slightly different way. And I think Anthony and I have both seen situations where clients had, frankly, just a sense that data could have been accessed. And as a result, they thought, you know, if it could have been accessed, it could have been acquired, it could have been misused, and therefore we should report it. And under the law, that's fine. It maybe goes above and beyond. And there's other instances where clients have seen proof of access, but no real proof that whoever accessed it meant to do something bad with it and decided not to report. Again, under the law, that's probably fine. And this is sort of the consequence of having a blurred line dividing a privacy event from a data breach, just because we're not getting the guidance we need as lawyers. So instead of someone deciding and everyone following, everyone is deciding, and as a result, we sort of have this mixed result following on. And so there are obviously implications of this, and I want to turn it over to Anthony to speak about them.
Sure, thank you, Jordan. There are a number of implications with the fact that we have different definitions of what a data breach is. Some of these implications are just as simple as in one state they define personal identifiable information to include uh, biometric data, like Colorado. But in Oklahoma, we don't include that. So if there's an incident that involves a company and things like fingerprints are released, are exposed, you have a reporting obligation for some states, and in other states, you simply don't have that requirement. But when we start looking at the definition of what a data breach is, it can cause all types of issues. Like what exactly constitutes a reasonable belief that data has been accessed or acquired by a third party? So let's look at a current or a more recent example. In 2017, a researcher found that some of Accenture's servers were left exposed and open to the public. The researcher said that there was a lot of data exposed, that their key to get into more information was also publicly available and accessed, uh, while the company took a different position, saying that it was only a small percentage of the data, that there was no evidence that customer information was exposed, that customer information was even available, and as such, there was no independent reporting obligation. And because the company didn't have a reasonable belief that data had been accessed or acquired by a third party. So what exactly constitutes a reasonable belief that misuse or fraud will result from unauthorized access or acquisition? If we look at the LinkedIn data scraping incident that I talked about a little bit earlier, the information that was exposed included people's names, where they worked, their email address, all of this type of information that was publicly available, but LinkedIn probably doesn't have a reasonable belief that this was misused for fraud, because this information was publicly available. But we all know, if you know where someone works, if you have their email address, if you have their information, and maybe some just basic facts about them, it's a lot easier for you to do a phishing attack against that person. So without clear guidance, every breach is an opportunity for us to guess. If courts and regulators are telling companies when to report breaches, if they're not telling companies when to report breaches, it's often left to lawyers, which we try to do a good job of doing analysis. We try to work with clients to kind of explain the risk versus the benefits, but it's still left where it's a guessing game. And so, what are the consequences of uneven reporting? We talked about how there were some, just how we don't have clear definitions about potential access to sensitive information. It sometimes leads to incidents where companies report or where they don't report. And so we have underreporting that can hurt people. And sometimes there is a benefit to a non-exhaustive investigation, because if you don't have, if you're not able to find additional information, then you're actually in a position where you don't have to do any reporting. We can look at another example. Everyone's probably heard about the 2014 Target data breach, where credit card information was exposed, but it was actually two breaches that Target reported. The first one about credit card information, but as they continued their investigation, they went and they found that a number of users' phone numbers, names, and email addresses were also actually exposed. They probably wouldn't have had to report this if they hadn't continued their investigation and uncovered this information. And so I think it's important to know that most businesses err on the side of caution, and they try to report to prevent liability and build public trust. And they always try to do the right thing because of the number of consequences. But at the same time, without there being some clear guidance on what you're supposed to do, there's an opportunity for companies to not take those extra steps. So let's look at some consequences. And I talked about some of them for a moment, but I kind of want to just drill down. So insufficient reporting deprives consumers of the opportunity to know and watch out for theft, seek credit monitoring, and all of those things that you would do if you're a victim of a data breach. And so you can only do that if a company reports and lets you know what's going on, lets you know what type of information is taken, because different types of information create different types of risk for people. And so we want to make sure that we're informing consumers. But it also raises serious privacy and data security issues and concerns. If you see a company that is consistently being breached, consistently having to send out notices, then it kind of triggers something in the head of consumers that say, maybe this company isn't taking my security, my privacy importantly. They're not really concerned about that. And so these notices are also just indicators for consumers to move on to a different company, because they find out one company just isn't respecting their privacy enough for their life. Uneven reporting makes it difficult for law enforcement to track and prevent cyber crimes. We've seen this with the ransomware epidemic. Law enforcement really needs to have this information. They need to know what's going on. They need to know what types of trends are so that they can report to industry groups. You'll often see reports and alerts from the FBI where they're saying that we're seeing this trend and companies should look out. And the only way that they're able to see those types of trends is by seeing reporting of these incidents. And then uneven or underreporting also makes it difficult to know how data became exposed or assess liability. Sometimes there may be overlapping breaches and only one of them may be disclosed. And so you're only able to know part of the reason why this incident occurred, so that you can't address it and become more secure. I kind of want to just now hand it back to Jordan to talk about this idea of playing God.
Yeah, thanks, Anthony. And I actually think what you just said leads to this relatively well, because you talked a little bit about the economic pressures that exist. If a company is reporting data breaches frequently, a consumer may assume that that company is not preserving their privacy correctly. But it may be that that company is just more more broadly defining what a data breach is, and that company is actually acting to provide notice to consumers in just a broader set of security incidents. And so for lawyers, this can sort of put them in a tough position, right? It can be bad publicity for your client to report a data breach. It can be very expensive for your client to report a data breach. I think the average cost is about $8 million, and this includes having to pay for attorneys, having to report, having to send out notifications, having to do a forensics investigation, having to provide credit monitoring and usually some type of insurance. And again, that's not including just the bad press that comes with it. And so no one wants to report a data breach. And lawyers have a fiduciary obligation to zealously advocate for their client and put their client's interests first. Now, lawyers also have a duty to follow the law, and they also have a duty of candor in some situations. Um, but if the law is squishy, a lawyer is going to try to mold the law in the best interest of their clients. And this could lead to a situation where a company is having a series of security incidents that simply are not defined as a data breach and are not reported, whereas another company may be having very similar incidents, considering a data breach and reporting it. And the company that is sort of, again, more broadly reporting that data breach ends up bearing an economic burden and a public relations burden and a business burden. And so that can be very difficult. And so again, this puts lawyers in a position where they may be disinclined to report a data breach, or certainly corporate decision makers may be disinclined. And frankly, it isn't always because of outside pressures. Some of it is built into the system. Lawyers are often not technically proficient. I know I'm not. I rely on my relationships with people who know how to code and know what's going on and work in InfoSec. And so if I'm getting sort of incomplete information from someone who works in InfoSec, or I'm not aware of the intricacies of what went on and its implications, I'm not able to do my job as well. And that can deprive me as a lawyer of knowing what a reasonable belief is. Is it 50+% chance that data was accessed, or is it less than 50+%? That sort of takes a forensic knowledge, it takes a coding knowledge, it takes technical proficiency, and many lawyers simply don't have that. And many lawyers, especially those who are at a company that is not routinely dealing with data security issues, simply just don't have the relationships with tech leads that they might need to understand these issues. And so that can make it very difficult just in real life to assess what a reasonable belief is of acquisition or misuse. And then when you combine that uncertainty with the economic pressures you might feel to not report, that can really skew what ends up getting reported. And so again, you might have one lawyer advising something very liberally, one handling it very conservatively, and that can lead to wildly different outcomes. And that just sort of raises this question, right? Should individual lawyers be making this decision? Or should this decision be made at a societal level, right? Because there are real life privacy implications for whether or not you, as a consumer, get to know when your data has been compromised or not. And I think this maybe ties into a bigger question, which is, aside from these uneven outcomes, because the line between, let's say, a privacy event and a data breach is blurred, is it ever okay for security incidents to go unreported, right? Like, is this concept of a data breach being a subset of a security incident just fundamentally flawed or outdated, right? In recent years, we've seen a lot of state privacy laws get considered and in some cases get passed. And the basic idea of these laws is that you have a right to know what's happening to your data. Companies are really just controlling or handling this data on behalf of consumers. And we've seen companies be required to disclose to consumers when they're voluntarily sharing their data. Well, a security incident could involuntarily share someone's data. But under current breach reporting laws, that may not have to be disclosed to a consumer unless there's a reasonable belief that it's misused. And this would seem to be a very inconsistent result, and sort of, I think, speaks to the fact that our breach notification laws, which were passed relatively quickly in many cases to address a real issue, which was data breaches, and really well intended, may not be keeping up with just how much data there is, how many security incidents there are, and how cyber criminals have evolved, right? And so I think that this is sort of ties to user expectations of privacy, and it may be that a potential solution to the blurred line that we're talking about between privacy events and data breaches is to simply say all security incidents may need to be reported because consumers have a right to know what's happening to their data, even if nothing bad is happening to it. And under the current sphere, we as corporate attorneys, which we are, might look at that and say, well, couldn't that be very, very expensive to companies? And the answer is that we can change. We'll talk about potential solutions in a moment. We can change the incentive structure to sort of break down the barriers to reporting so that instead of a data breach being something that costs hundreds of millions of dollars or at least millions of dollars, it can be something that is a regularly reported security incident that agencies know about, that law enforcement can track and try to prevent, and that users can sort of routinely monitor in the same way they might monitor who has their data or who is deleting their data, because we just assume that consumers have a right to privacy. And so this is where I say that we should never be prisoners of the moment. Just because we've been working within a certain framework doesn't mean we can't dream of something new, particularly as lawyers or policymakers. Programmers dream of something new every day. And part of the reason why we're dealing with these difficult questions is because the privacy sphere has evolved so impressively from the technical side. And we're just trying to think about how, as lawyers, our decisions cannot be sort of doing injustice to the great work that's being done. And so I think with that, it's worth talking about solutions a little bit. Anthony always likes to say that we shouldn't identify problems without offering solutions. And I think that there are a variety of options here. States could get more involved in providing additional guidance as to what constitutes a data breach. State agencies could provide additional guidance where there's sector-specific federal regulations like HIPAA for medical providers or Dramlich-Bliley for financial institutions. Federal agencies can try to provide more guidance just so that lawyers aren't hypothesizing as to what a reasonable belief is. We could also pass a federal privacy law or security incident reporting law. This is something that many people have talked about for at least a decade, and that law could provide more well-defined language. It could have a broader definition. It could have a different timeline. It could require law enforcement reporting. But most importantly, it could also set aside a federal agency to implement that law and interpret what its words mean and give updated guidance on what a reasonable belief is, as that may change over time with cyber criminals or technology. And finally, I think one big solution that we hit on a few minutes ago is we can minimize back-end liability for businesses so that they're not scared to report because it'll cost them money, and they're not worried about having to provide credit monitoring when a given consumer may have 6 other forms of credit monitoring from 6 other data breaches. And so we can sort of either provide universal credit monitoring or have government subsidies or tax credits available for reporting and sort of helping mitigate data breaches. And I think that will really help incentivize businesses to report sooner and report more frequently. And that, of course, will not just benefit sort of privacy interests and not maybe save costs all around because you won't have multiple sets of credit monitoring for different data breaches, but it will also benefit law enforcement because law enforcement will know promptly about a potential cyber attack. They'll be able to investigate it, and they'll be able to hopefully help warn about it and prevent it. And so obviously there's many other potential solutions. I think we may cover a few in the Q&A. I will let Anthony jump in a second, but my view of potential solutions and the reason why we're talking to you today is that they all start with better communication. One of the reasons why we see these ambiguities in laws and why they're not being clarified by courts or agencies is just because the tech, business, lawyer, policymaker relationship is not as good as it could be. And I think we see this every time Congress has a hearing on these issues, and you realize that most of your policymakers just don't understand technology, and they have no idea what some of these terms of art mean. And so by talking to one another, we can help solve these issues at a macro level, but we can also help solve them at a micro level. By having better lawyer, executive, tech relationships within a company, we can all better understand the risk of data accessibility and acquisition and misuse. And that can mean that we're not sort of lawyers, especially playing God with what a reasonable belief of misuse means. We can be informed by people who deal with these issues every day. And likewise, this is an opportunity not just to better communicate, but to speak up. If you care about privacy and it troubles you that involuntary information sharing may not be reported to the same degree that the CCPA might require voluntary information sharing, let your voice be heard. And you might be surprised with how quickly it can change the conversation. And so with that, I'll let Anthony sort of have the closing word here and just say thanks to everyone for watching.
Yeah, thank you, Jordan. You did a great job kind of walking us through the solutions. There's just one thing I want to add is that oftentimes when we're talking about minimizing back-end liability for businesses, people think of those big, huge corporations, but most data breaches impact our smaller and mid-sized companies. And those are the ones that really would benefit from having all of those wonderful things that Jordan kind of outlined regarding tax credits and subsidies, and government-backed credit monitoring. For those small and mid-sized companies, for those nonprofits, for those school districts, all of those groups are the ones that would really, really benefit from that. And so when we talk about data breaches and helping businesses out, we need to be very clear about who are the victims of data breaches. And it's usually those smaller to mid-sized companies, those school districts that we've heard a lot about. And so those are the ones that really need our help.
As somebody who has to think about this as well as a recovering lawyer, I'm really appreciative that you could join us and get an overview of this. I guess, I'm waiting. If you have questions, guys, drop them into the Discord CPV Talk Q&A text channel in the Discord. Meanwhile, I've got a few that I could start off asking you. Are there any perverse incentives for a company to keep its head in the sand and not keep investigating in order to not find out something that maybe they'd rather not know?
Jordan, go right ahead.
Sure. I mean, I think one of the reasons why we gave this talk is that, yes, there are. But you have to qualify that, which is to say that no company wants to be accused of burying their head in the sand. And if a lawsuit is brought, that could be a very bad thing. But as I think we mentioned a little bit, there are barriers to law enforcement or an agency holding a company accountable, and there are significant barriers to an individual holding a company accountable. So the short answer is, yes, there are incentives to bury your head in the sand, and yes, you can probably get away with that. I think one of the bigger issues is that the law doesn't prevent you from doing so, right? So to some degree, as lawyers, we're sort of being thrust into the void where we're being asked to put our client's interest first against the law, which often means that you can do a little bit of head burying, or you can have some discretion in what you report. But then societally and from a privacy perspective, we should be reporting this all the time so that law enforcement knows, so that individual knows. And that's kind of, to some degree, as much as lawyers love power, and I'm a lawyer, I love power. You're a recovering lawyer, you probably love power. Thank you for hosting. There's a question as to whether or not we should have this power, right? And I think lawyers are often better at interpreting rules and helping people comply with them than making those rules up on the fly. And I think under the current system, we're allowed to do that. And so there is that potential to do some head burying. And that's one of the reasons why we're talking here today, is we thought it was an important topic.
Well, and how does that affect the way that you counsel different clients? Because, it's definitely been the case where I've had clients where one of them will say, but this other competitor in our space does this other thing, and we want to do that thing. Why won't you let us do that thing? Why are you advising us otherwise? And it seems like from what you're describing, there's a lot of wiggle room. There's always some discretion. This is why we're lawyers who have to use judgment instead of, basically just being, executing things, ministerially. How do you reconcile that? Is it just a question of different clients being positioned differently, or, does one more risk averse approach maybe work better for one client and one more risk forward work better for another?
Sure. I always try to tell clients that we only want to put on one Band-Aid. And so what that means is we want to take our hit only one time. And so if they do things that they may see their competitors do, it may not end up happening for them the same way that it did for their competitors. And then they have lawsuits that follow up, that they have government investigations that follow suit. And so we don't want all of those things. And so as I'm counseling them, I'm pushing them in the direction of doing it one time so that we won't have all these other issues. And sure, it's a give and take. It's during the conversation, but I always want to kind of present all the types of consequences of their actions so that people can make informed decisions. But my position is always to tell them that we only want to wear one Band-Aid. We don't want to solve this one problem and then have like 5 other issues, and we're walking around with a lot of bandages because we didn't, take the right course in the beginning.
That's great. Jordan, anything to add to that?
No, I think Anthony hit it on the head. This is such a tough conversation, right? Because us speaking here is sort of this public policy role. We're in the InfoSec community, but then we go and speak to clients, we put on the lawyer hat. And so I feel almost compelled a little bit to say, like, yes, we have these horror stories that we can talk about. And yes, we have situations where a client does hold up a 4-page article or a 10-page article or something that a competitor did and say, can't we do this too? But for every one of those cases, we probably do have 5 or 6 where a client comes in and says, I don't care, I just want to report. I don't want any band-aids, I want to do it right, I just want to do the right thing. And so it's, as with all things, you have some people who are trying to get away with it, but many people who are trying to do things right. And the issue here is that the law just isn't providing guidance as to what the right thing to do is in most situations. And so that's sort of my defense of many companies, particularly those smaller companies that Anthony mentioned at the end of the talk.
And it seems like the fact that we have this mandatory reporting isn't even just beneficial for the people who are the customers of the affected companies. It's also beneficial for each other in that you can go through, at least in states like California, where I live, where the AG posts copies of all of the notices for sufficiently large numbers of affected people in a breach. You can go through those and kind of figure out what's happening. Is this a resource that you've drawn on to see, what current trends there are or find any common weaknesses that could have been prevented?
Absolutely. We use kind of this publicly available information for training of clients. So we'll sit down with them and say, here's what's going on in the world. Here's the things that we're seeing. Here are some trends. Here are some things you should be aware of. And so that's a really, really great resource. Letting them know what other companies are facing, helps them place priorities, helps them kind of understand weaknesses, and then kind of just serves as another example of, see, this incident happen where they had to report a breach and there were millions of impacted consumers. So this should be a lesson to you. You don't want to do that. And so I kind of just paint it that way to them.
Great, thanks. You were talking about how to minimize liability on the back end, and I'm curious to hear what your thoughts are on the state of the cyber risk insurance industry and whether you think that's sufficiently serving clients as is, or are there any different changes that need to be made to it right now?
This could be a very long answer, but I think it's an amazing question. So thanks for asking, right? I think one thing is, as you mentioned, there are great databases out there. California is not always reflective of the rest of the country. And this sort of squishiness in what can get reported means that we don't always have knowledge of what sort of attacks are going on, what data breaches are occurring, whose information has been affected, just because not everything is required to be reported or is reported. And obviously, I think a reason for that is that clients don't want to have to go through that process. They don't want to bear the risk. You're right that many clients have cyber insurance. And at least until this year with the ransomware epidemic, cyber insurance has been pretty liberal about paying out on a lot of claims. And it's always been pretty easy to get cyber insurance. There's some evidence that that is changing and insurers are under increasing stress. And that's something we see every time there's a crisis, right? You see insurers that are disproportionately affected by a crisis and they just can't keep up with the rising costs. I think we may be going through a period like that right now with ransomware and just cybercrime in general. But there are also a lot of businesses, especially outside of California, that just don't have cyber insurance or don't have the policies in place to do some of this. And there are still many costs to a data breach that go beyond what you would see in a cyber policy. And so I think that there are still ways to mitigate costs. And to some degree, that can mitigate costs, not just to affected businesses, but to everyone involved, right? So when you have the same person's data being disclosed in 7 different data breaches, and you have 7 different companies paying for credit monitoring and insurance on their individual identities of the affected consumers, well, that's 7 companies or 7 cyber insurers paying for the same ultimate outcome for that same individual. And so you might be able to reduce that down to 1. And so if you sort of had a more centralized approach, it might minimize some of the redundancy that you're seeing and just bring down costs overall. And so I think that not only would help incentivize reporting, but help save everyone a little bit of money and take some strain off of the cyber insurance industry.
Fantastic. Great. Well, I see that we are at time. Thank you both so much for sharing your expertise with us. And it looks like you go there in person. Have fun and stay safe.
Definitely.
All right. Take care. Bye. interested in the intersection of cybersecurity and data science. Today, she's going to be talking to us about how the Census Bureau used differential privacy to protect our data from being re-identified in combination with other big data sets in order to ensure privacy, while also ensuring that, as the Constitution requires, every American could stand up and be counted in the 2020 census. Take it away, Wendy.
Hi, I'm Wendy Edwards. I'm Wayward710 on Twitter, and I'm here to talk about differential privacy in census data. So what is the census? The idea of the census is not really anything new. The first US Census took place in the year 1790. So from its website, the mission of the US Census is to provide quality data about US people and economy. So what's it used for? Redistricting, government planning, allocation of funds. In fact, there are fairly significant financial implications to the census, such as why many of you may have heard your local government encouraging you to fill out your census form and be counted. So the census uses aggregated data. Is aggregated data anonymous? Not always. Like, for example, last month, a shady Catholic website called The Pillar purchased anonymized location data from Grindr and used it to out a gay Catholic priest. And of course, Grindr has its own privacy problems. It got hit for a multi-million-dollar fine earlier this year in Norway for sharing users' data without consent. The Pillar people correlated the data, supposedly anonymized location data from Grindr, with known things about the priest. For example, like they knew his cell phone number, they knew where he lived, and they were able to extract quite a lot of information about him. Then there was a fairly well-known news story, maybe in the early 2000s, where Target was trying to identify potentially pregnant women because they have the potential to spend a whole lot of money. And so they started sending pregnancy-related mailings to people, and they among those sent pregnancy-related mailings to a teenage girl whose father did not yet know she was pregnant. So that made quite a lot of news stories. And just so I think there are a whole lot of businesses that collect a lot of data about people. Like there's basically your ad networks, also known as supply side platforms, can collect a lot of data on people's social media usage, which is often used for advertising, but there's just a whole lot of data out there. And then there are also just online sites that just sell data about people, like for example, like your Intelius and People Finder and stuff like that. So how do attacks and data privacy work? There are three kinds. There's differencing, reconstruction, and linkaging. So differencing, that's where you start with some knowledge about the individual. It lets you make multiple queries about data that includes that information. Like for example, with the census data, maybe you know the gender, address, and ethnicity. And what if there's only one person in a data set with those characteristics? Reconstruction talks about using these tactics to try to reconstruct an entire database with fairly accurate information about a number of individuals in there. And this would be hard to do by hand, but for example, with big data, and particularly machine learning, that makes it a lot more possible. And so linkage attacks are generally you're taking data that's supposed to be de-identifying and linking with them, connecting them with data that is not de-identified. Like to give an example, somebody used an MD5 hash to identify New York City cab drivers. An attacker was able to crack the hash and they linked the data back to known people cab drivers, which was kind of defeated the idea of the de-identifying data. So how does differential privacy and census data work? So the promise is with differential privacy is you will not be affected adversely or otherwise by allowing your data to be used in any study or analysis, no matter what other studies, data sets, or information sources are available. So that's interesting. The value judgment is maintaining the subject's privacy is going to be valued over data mining. So one of the things about this is that you can't gain knowledge from post-processing, which just means like you repeatedly make queries about somebody you know to try to extract the data that's connected to that person. You can't do that with post-processing. One way they do this is that they add noise. They essentially add small random numbers to block level counts. And here's a pretty good illustration of it. So you've got data sets here that differ by only one record. And so if you've got these data sets, differential privacy means that if you're sending queries to these records, you would get the same answer and you wouldn't be able to figure out about the things about the single record that where the data sets differed, which would probably have been the attacker's target. And here's another illustration from Microsoft about how a differential privacy system works. So essentially the differential privacy acts kind of as an intermediary between the analyst and the data. Like the analyst sends the query to the privacy guard and the database sends the response back to the privacy guard. And it analyzes the implications and introduces noise as necessary to protect the privacy of the subjects. So what does this mean for census data? So some things will be accurate, some things will still be accurate, like for example, your housing units and the type of each group quarters are going to be accurate within census block, which is the finest unit of census geography. The total population will be accurate at the state level, and that's very important because your representation in Congress is dependent on your state's population. So probably some of you read about states gaining and losing representatives due to the past census, due to the 2020 census, and that's why. And one thing that's very interesting about this is that gerrymandering may be harder because typically when you look at how people who are gerrymandering usually build their districts, they often start with kind of the smallest particles and the smallest blocks and try to build it up. And with the differential privacy, that's going to have the highest amount of noise. With the more normal, less gerrymandering approach to building districts. When they start with larger districts, differential privacy is not likely to cause as much of a problem. So I think it'll be very interesting to see what the districts look like with the differential privacy. And there's a lot of excellent material out there about differential privacy, and I just listed a few that were good references or that I'd used in my talk. And so thank you very much for coming. And I think this is when we open up for questions.
Okay, here we go again. We're doing it. We're doing it live. Hopefully we have audio, we've got video, I've got rhythm, I've got music, I've got my friend Kendra. Who could ask for anything more?
Speaking of getting songs stuck in your head.
Yeah, exactly. All right. I'm very pleased to once again introduce my friend Kendra Albert, a brilliant attorney, to talk about the recent Supreme Court decision on the Computer Fraud and Abuse Act. Talk is titled, "So What? The CFAA After Van Buren." And Kendra, I think you should be able to share your slides and I'll let you go to town.
Awesome. Thank you, Rihanna. The introduction got more and more congratulatory each time, but can you just let me know, are the slides working okay?
I can see them.
Fantastic. All right. Well, thank you so much for having me. Super excited to chat about my favorite topic, the Computer Fraud and Abuse Act. So let me talk a little bit about who I am and why I'm theoretically at least partially qualified to tell you about it before I sort of dive right in. So about me, I am an attorney in the traditional fashion of my people. I will say I am a lawyer. I'm not your lawyer. And this conversation does not create attorney-client privilege relationship between the two of us or between me and anybody else. I'm a clinical instructor at the Harvard Law School Cyber Law Clinic, and I represent individual security researchers, including previously our friends over at one of the other villages, Voting Village. And relevant to this talk, I'm the co-author with Sanu Park of A Researcher's Guide to Some Legal Risks of Security Research, which I realized while preparing this that we really should update post Van Buren. So this is something I've thought a lot about, and I'm really excited to sort of share some of the stuff I know and some of the questions I have with all of y'all. So if you're not a CFAA nerd like me or Rihanna, let me do a teeny bit of background on the Computer Fraud and Abuse Act. So it's the federal anti-hacking statute, right? The federal law that makes it a crime to hack into things. Probably everyone here already knew that. But it's commonly characterized as an anti-computer trespass statute, or at least by a sort of whole vein of scholarship, most well known by Oren Kerr. And much debate over what that means, whether we should be looking at traditional property law, so like the law of land, to think about how trespass works. But generally, we think of it as I think it is a fair thing to think about in that way. And in case anybody here doesn't already know, it creates civil and criminal liability. So that's the kind where they can put you in jail and the kind where a company can sue you for lots of money, flip-flopped, for accessing a protected computer and obtaining information if, among other things, I'm summarizing, if the access is without authorization or exceeds authorized access. Now, that doesn't make this a super straightforward, clear explanation of what is or isn't covered by the CFAA. So courts have spent a long time trying to figure out exactly what constitutes authorization. And there's a lot of competing theories, or at least there were pre-Van Buren, and there will be after. But often it's sort of boiled down to this core idea that with something being without authorization, if you lacked authorization to access the computer, it meant you were sort of an outsider. So the outside nefarious hacker, that idea without authorization. We all know that that's I'm not invoking that without the full knowledge of the context there. Exceeding authorized access was often characterized as something insiders do. So the archetypal example here is if you have access to a laptop for your job, and when you got that laptop, you were required to sign a document by your employer saying you would only use it for work-related purposes. And then you go and do your online shopping that is very much not work-related on it, then you might be exceeding authorized access as an insider. And that's been one of the actual core questions of Computer Fraud and Abuse Act law for a long time. How does the Computer Fraud and Abuse Act interact not with technical restrictions, but with sort of policy-based access controls? And this comes up in the context of employees, like I just mentioned, but also in the context of terms of use for computer services. So if you were using a website and you violated their terms of use, pre-Van Buren, you could be looking at potential Computer Fraud and Abuse Act liability. Another sort of related question that we see sort of percolating up given the scope of the Computer Fraud and Abuse Act, is can publicly accessible websites deem a specific company or person's access without their authorization? So basically, can I say, everyone can come to my website, except Rihanna, you're not allowed to, and you sort of give that pronouncement the force of law under the Computer Fraud and Abuse Act. So these were hard questions, and the statute is not super clearly or well written, so it didn't have clear answers for us. What that meant is that prior to Van Buren, prior to the Supreme Court taking on this case, there was a circuit split. So there were sort of two different styles of interpretation. This is a gross oversimplification. All of my lawyer friends who practice CFAA law, please close your ears, just, for the sake of argument, right? A set of broader interpretations, basically that those kinds of use restrictions that were in terms of use or potentially an employment contract might count, and a set of narrower restrictions. Use restrictions generally didn't count. And what that meant is that the law in Boston was different than the law in Buffalo, and the law in Buffalo was definitely different than the law in Portland, Oregon. Depending on which circuit, so that's the set of courts below the Supreme Court that you were in, the law could be entirely different. And the reality is, even though I am not currently a California resident or firmly a West Coast believer, the Ninth Circuit had much more developed case law than many of the other circuits on this subject. So you probably got much more guidance if you were in the Ninth Circuit about exactly what was or wasn't covered by the CFAA. Some of it quite useful to sort of determining your legal risk if you were thinking about certain kinds of access without authorization or exceeding authorized access. So that brings us to Van Buren. That circuit split is the reason that the Supreme Court took up this case. And this is Mr. Van Buren himself. He's a cop. And he actually took money to make a series of searches that violated department policy in a police database. So he basically, his dash computer on his patrol car, somebody paid him to look up a bunch of stuff in it. It turns out that was an FBI sting. Sorry, Nathan. And he gets convicted of violation of the CFAA in addition to some other stuff, and gets 18 months in prison. This gets appealed to the 11th Circuit, so I'm pretty sure it was in Florida. Lots of things happen in Florida. And then to the Supreme Court. And basically, what the case Van Buren turns on is the exact textual context of what exceeds authorized access means. So I'm gonna now go full on into lawyer textualist mode. So all of the lawyers who hid their eyes when I vastly characterized all of the Computer Fraud and Abuse Act prior to Van Buren in two categories, that you can start paying attention again. So the text of the statute, again, not super well written or clearly written, but Congress in its infinite wisdom did define exceeds authorized access for us. That's the bottom bit here, right? The term exceeds authorized access means to access a computer with authorization and to use such access to obtain or alter information in the computer that the accessor is not entitled to obtain or alter. Well, thanks, Congress. That really helps me figure out what this means. So what we in Van Buren is a very detailed parsing of the bit that I have bolded here, the not entitled to obtain, trying to sort of figure out what Congress meant when it passed that statute, and how this helps us understand what exceeds authorized access. Oh no, I just got the message my internet connection was unstable. So apologies if I just broke up and you missed some of my scintillating reading of the Computer Fraud and Abuse Act. I'm just gonna keep going. All right, so what does the Supreme Court say? Well, the reason that "so" is in quotes in the title is because there are literally 2 pages of this opinion that are about what the word "so" means. But the majority decision here in Van Buren from Justice Barrett focuses on the textual analysis of defining that term exceeds authorized access, and finds, notably, that the government's definition, the definition that was sort of a broader characterization of the Computer Fraud and Abuse Act, did not appropriately account for the word "so." Yes, seriously, that's what it finds. And sort of while she's talking about this textual reading and why she's interpreted it that way, we also get some information about how she thinks the CFA should be interpreted more broadly. And that's what I have quoted here. She talks about a gates up or down inquiry. And this language has come to sort of be pretty important for thinking about how we talk about the CFAA now. In fact, when I announced I was giving this talk, 1 billion people made jokes about gates up and gates down on Twitter. But which sounds a lot like the things that organizations like the Electronic Frontier Foundation were arguing for, which is a focus on Computer Fraud and Abuse Act claims requiring this basically sort of access, bypassing a technological barrier. So it isn't just about whether you broke a policy, it's about whether you sort of actually got around something. However, although there's lots of language in this opinion that really suggests that that's what's going on, we also have this amazing footnote, and by amazing, I mean terrible, footnote 8, which says they're just not deciding whether it only covers code-based limitations or whether it also looks at limits contained in contracts and policies, right? So what I would love to tell you is we have a firm answer from the Supreme Court here that says code-based restrictions only. It's about whether you've actually circumvented some sort of code-based access control. But we actually don't have that. The Supreme Court sort of refused to put down a to lay out clearly one way or another what was going on. And that disappointed a lot of advocates. But there is a lot of language in Van Buren to be excited about. And no shade on Justice Barrett, plenty of shade on Justice Barrett. A lot of it, actually, the best language in this opinion comes from Justice Kagan, who Justice Barrett is quoting when she says that the policy arguments for a narrower reading of the Computer Fraud and Abuse Act are icing on a cake already frosted. I found this beautiful hacker cake for this presentation to just really drive home this point. Nothing quite says hacker like the laptop with the giant Dell logo. So the majority decision does discuss the policy implications of a broad reading of the Computer Fraud and Abuse Act, which is what a lot of both the amici and folks in sort of cryptography and privacy communities focus on. Barrett at one point says, if exceeds authorized access clause criminalize every violation of a computer use policy, then millions of otherwise law-abiding citizens are criminals. I would love to, and I don't think we'll have time today or during Q&A, but to unpack why I think that sort of framing of what criminal is just like this very deep, interesting misunderstanding of like the sociological meaning of crime, but neither here nor there. I would say ask me in the bar afterwards, but ask me in the Discord afterwards. The icing on the cake already frosted section, the policy section, also cites lots of amicus briefs from researchers, reporters, technology companies, talking about how bad the CFAA's broad reach, especially the criminalization of potential terms of service violations, was for just everybody involved. So that's great. But I have just walked through this decision for 3 minutes, and you would be excused if you're not entirely sure what happened. So I've prepared this very helpful chart to indicate exactly what we know post Van Buren about the lay of the land. Okay, all jokes aside, we know it's much more difficult to argue that contract-based restrictions, employment contracts, terms of service create CFAA liability, but it's not ruled out entirely. I would suspect personally that you're more likely to get contract-based restrictions in if there's some sort of technological hook that a court can hang their hat on in terms of making a claim there. So if what you're thinking of is like kind of access controls tied to particular roles, that may be much easier, even if there's some sort of weird policy component, than a straight up like terms of service. The other thing that's clear, and I'm not going to quote too much of the language at you here, is that the Supreme Court imagines computer systems as like a series of files with specific locations and access parameters. It's clear that like Justice Barrett or Justice Barrett's clerks kind of like got to the point of like understanding that like the folder is in the specific place and that's on the hard drive. But it's not exactly clear how this sort of squares with the reality of access to modern computing, where access to a particular location is not actually always how we think about what one can or can't do with a computer, let alone things like how that squares with sort of the cloud or just cloud services more generally. So here I invoke the archetypal and all-important Shruggy, which is really the correct answer to any legal question. We may get more clarity on some of this stuff soon, though. So we're waiting on the decision in HiQ v. LinkedIn, which went went up to the Supreme Court, and Supreme Court sent it back down to the Ninth Circuit in California to say, hey, like, y'all deal with this. We don't want to. So HiQ v. LinkedIn, for folks who don't know, HiQ Labs was a company that ran analytics on public LinkedIn data, and then they sued LinkedIn after LinkedIn blocked their IPs and sent a cease and desist letter. So we may get some answers in this case to some of the questions that kind of have not been answered, weren't answered by Van Buren. So HiQ versus LinkedIn is a without authorization case, not an exceeds authorized access case. So what LinkedIn is arguing is, hey, Van Buren really doesn't tell you much about how to decide this. I think personally that the Ninth Circuit is unlikely to buy that the Supreme Court decision that just came down on this statute doesn't really tell you much about how this should be decided, but we'll see what happens. I will say that we will probably resolve one of the other key questions that's especially key, I think, for folks in the DEF CON community, which is what level of magic powers do cease and desists have? One of the theories present in the LinkedIn case is that the LinkedIn, by sending a cease and desist to HiQ, actually revoked HiQ's authorization, and their access was now without authorization. So even if there wasn't CFAA liability beforehand, there is now. That's a kind of scary proposition because it's not exactly clear. Like, cease and desists aren't a magical legal instrument. They don't really, like, being on notice doesn't necessarily change things in most circumstances. And so it would be odd if in the CFAA case, they suddenly gained this particular significance. The other thing we might know after HiQ v. LinkedIn is how to think about IP blocking. So it's difficult to fit something like IP blocking or even something like rate limiting, God forbid, into the kind of gates up, gates down model, in part because, as HiQ argued in their brief before the Ninth Circuit, you may not even know that your IPs are getting blocked. If things just stop working, you may just switch to a different internet provider, IP address, computer, not because you have some malicious intention of circumventing a technological barrier, but because you're just trying to make things work. So does that mean that you're now acting without authorization if someone blocks your IPs and they don't tell you? Well, maybe we'll find out, and maybe we won't. So I want to just summarize, because I've sort of talked about a bunch of different things, with some of the stuff that we know about post-HiQ v. LinkedIn, which is maybe optimistic of me, post-Van Buren, and some of the stuff that we don't. So what we do know is that policies without technological access controls, without a sort of technological barrier or thing that you're around, are very unlikely to create CFAA liabilities for instance. So it is unlikely that if you are authorized to access a system, accessing it for a reason that you're not supposed to is going to create CFAA liability. But as we said, SCOTUS didn't rule out the non-technological barriers in creating CFAA liability. The other thing that we do know, and I'm sorry if my internet's unstable, this has not happened before, they said, as one always does when things go wrong during a presentation, is that Van Buren didn't create a wide-ranging exemption for security research or eliminate liability for hackers. The reality is that many things that security researchers do were not in the set of questions up on in front of the Supreme Court on Van Buren. If you're, abusing privilege escalation to get access to something you wouldn't otherwise have access to, Van Buren is not going to help you. So what don't we know, right? What's still to be decided? Can you revoke access to something public for one particular person or company and use the CFAA to enforce that? That's the one part of the HiQ problem. What constitutes a gates down situation? What level of protection or gate is required? And this comes to the sort of idea that courts are very reluctant to sort of decide what kinds of technologies are enough versus what aren't. And so we may see that gates down means very little practically from a technological point of view. And then, we talked about the IP block. Finally, how are courts going to draw the line between access and use restrictions in edge cases? So, saying only access the system for purposes, certain purposes may be relatively easy, but the reality is that it's actually quite a bit more difficult to sometimes distinguish certain types of access and use restrictions, something Justice Barrett actually acknowledges in the opinion. She says you're not allowed to get around the restrictions on use restrictions by making them access restrictions, but it's unclear what that's going to mean in practice. So you would be excused if you went through all of this and you're still not quite sure what this means for you, a security researcher, or just generally what this means. So I'm going to close by just offering some places to get free legal help. So the Electronic Frontier Foundation is always a good option. You can email info@EFF. They also maintain a cooperating attorneys list. So even if EFF can't help you, they can often find someone who can. And you can also always contact my employer, the Harvard Law School Cyber Law Clinic. We offer free legal services, and you can fill out our intake form. It's easy to Google, but I included the link here. So I think that's it for me. I hope that some of this made it across the airwaves to hopefully, I don't want to like go so far as to say eager listeners, but listeners. And I think I'm going to stop sharing and move over to Q&A.
Fantastic. Well, I, of course, found that fascinating because I really like talking about the CFAA. So, you mentioned that there's still a lot of this uncertainty. Like, it's really kind of par for the course for the Supreme Court to snatch defeat from the jaws of victory by, just adding some element of uncertainty where they could have just given a solid answer. And really, we have a Congress that has not shown a lot of willingness to do stuff. And so we're kind of dependent upon 9 people in Washington to do it for us. But, if there were to be reform to the CFAA in order to better protect security researchers, what do you think needs to be done in order to clarify that so that we keep the bad guys' behavior criminalized, but we make the world safer for good faith security research? What would that look like to you?
Oh man, I feel like I totally am getting trolled. So I have complex feelings about this. I can totally understand the instinct to push towards some sort of good faith exemption or safe harbor, right? I also think that and I'm going to argue, I am arguing this in an essay that I am finishing now, that the reality is that the level of uncertainty under the Computer Fraud and Abuse Act is not actually that much higher than the level of uncertainty under other either federal criminal laws or state criminal laws for other groups of people. So what I want to encourage security folks to do is, rather than seeing the Computer Fraud and Abuse Act as this exceptional law that criminalizes all of this behavior that innocent people do, innocent security researchers do, I think we should understand this as part of a broader schema of American criminalization of everyday behavior and prosecutorial discretion to decide the good guys from the bad guys. So that makes me a little reluctant to go the direction of like, oh, let's get the good faith exemption for computer security research, even though I understand, and honestly, it'd be good for my clients, because I think that I see this as an opportunity to be in solidarity with other groups that are criminalized and to sort of push for a more robust and thoughtful understanding of what criminalizing a behavior really means, and how it sort of relates to this notion of sort of a more moralistic set of notions. I also, I'm going to stop there because that was more than a spicy enough take.
Oh, I think it's a great start. Do you think then that there is some hope to be had from the fact that the Supreme Court now has, for better or for worse, a number of younger justices, and I think it's kind of accepted that the justices will rule in favor if they can put themselves in the defendant's shoes? Do you think we're going to see more of that if they take up high Q? And do you see that happening for other technological type cases?
I would be really shocked if they end up taking high Q. I mean, I think it's possible. I don't never rule anything out. I think, frankly, one CFA bite at the CFAA apple from the Supreme Court for 5 years is probably pretty realistic. However, what I will say about sort of the age stuff is I do think that's true, right? I do think the younger Supreme Court justices tend to sort of have sometimes a better understanding of how stuff works. I can make fun of Justice Barrett for folder X and folder Y, and that's not totally undeserved, because there are certainly many computing systems where that would be a vast oversimplification or just incorrect. But let's be real and say that that is miles better than we could have done in terms of understanding of computers. So I think it is likely that we get sort of more technologically thoughtful or savvy decisions from younger justices, also because, you know, they may be more willing to listen to their clerks who may have things to tell them about. Clerks are, for folks who aren't lawyers, clerks are people often straight or very recently out of law school who work for the justices. But I also think that, like, we've historically seen, I don't want to call it bipartisan because that's not quite right. No particularly strong partisan Democrat-Republican divide on sort of some computer security issues. It could kind of go a whole bunch of different directions. And it will be interesting to see how that cuts as, you know, as like after the current furor over like where everyone's annoyed about big tech ends, although there's plenty to be annoyed about. That's not what I'm suggesting. And to see sort of what happens from there. So it'll be interesting to see what other dividing lines we find in addition to age.
Fascinating. Well, thanks so much. This has been such, well, for me, again, you know, like, well, hopefully this was intelligible to all of the non-law nerds out there, but this has been so enjoyable. And thank you so much for joining us today. And have a great rest of your DEF CON various, you know, whether you're remote or just chilling at home.
Thank
all
you.
Right. Thank you, guys. And we'll move on to the next talk.
And let me introduce the next speaker at the same time. So Kate Rose, talking about combat surveillance and sartorial hacking. So big round of applause. Thank you.
Cool. I think we're getting started a little bit early here. Thank you so much for everybody for coming. I am Kate, and I welcome you to Adversarial Fashion, Sartorial Hacking to Combat Surveillance. In my full-time job, I actually work to help organizations that do social good work to get the kind of technology and security resources that they need day to day. In my part-time life, I actually spend time designing and selling novelty fabrics that usually have things on them that are for kids, like manatees or, you know, kittens playing around quantum teleportation diagrams, and of course pillows that look like cuts of meat. So weird prints, definitely no stranger. Today's talk, as a result, is going to be a sample of the surveillance systems that utilize computer vision technology, some art projects that other artists have come up with in order to counter or interfere with or engage with these systems. And then you are going to get a full end-to-end tutorial on how you can do this yourself and design them on any kind of fabric or other application. We call these surface designs to put on just about anything that you want. So buckle in, we're gonna get going. I want you to mostly take away from this that it's actually never been easier for all of these amazing designs that we read about and see online and even hear in talks here at DEF CON to actually come out of the computer and into the real world. And so we can put them in people's hands a lot easier than we think we can. So we have our problem set, which is that surveillance technology is everywhere. It is prolific. You've probably been in a couple of other talks that tell you how voluminous it is. Often that technology is implemented by folks who are themselves not AI experts. They are using stuff that's been quickly churned out. It's implemented in strange ways and in places that you wouldn't really think is a great idea. I think the big thing that I often have a huge issue with is that they generate these massive, kept forever, like highly sensitive PII-laden databases that are themselves sensitive to attack. So we can see an example here of how there was a border agency that was taking like photos of license plates and even of people at the border, all breached. So we're going to go over a little example of kind of how these systems work, just as a little background. I'm going to start with one that I think folks are very familiar with from this space, which is
Facial recognition, so how does that work? You have an input image, it's usually a large field and there's a human being in it. It's broken down into quadrants and decided which quadrant or little section of the photo has something that is likely to be a person in it. It detects and puts a bounding box around it. So the idea is that it's going to crop in and then start running it through that fabulous deep neural network. This is an amazing sort of diagram from OpenFace, which is one of the libraries that uses this technology. And then it runs it through these sort of other measurements. So we're looking at clustering, similarity detection, classification against a training set, or sometimes in case it's against an identification set. So you can identify who that is right there. Thanks, Sylvester. Unfortunately, there are some unintended consequences with the way that that particular type of methodology of how it goes through the technology works. There is a system in some cities in China that's implemented where if you are a jaywalker, it uses facial recognition to try and identify and then shame you on giant billboards and then issue tickets occasionally. Unfortunately, there was a very famous businesswoman who herself was caught jaywalking, but it turns out that she's actually on the side of a bunch of buses. So it actually then puts up her government ID, misspelled surname, all these kinds of things that I don't think you would really want blasted across a billboard. So now we're going to automate license plate readers, which is kind of like the guts of this talk. It works a lot in the same way. So instead of being, in this case, it is in addition to being on streets, it is also primarily on cop cars. So those have a couple of major components. The plate capture cameras, which are sitting on the top, and then you have a processor, because this is a lot of information that's coming in all the time. We'll get into how much. And then there is a front end. So there's like an application that the police officers in the car can actually work with, as well as store any of the data and then parse it later. So this is actually a sample. You can find all these, by the way, at the EFF website, but this is actually a slide from the Anaheim Police Department training on how to use the resulting data and then go back through it. So you can see this blue line is actually a path that a cop car took. And when it was looking for a particular plate, and it can tell you like the number of plates scanned, whether the target, which is like the hot plate, or the one that is under investigation that we're looking at, you'd see this like little tiny note right there where it's a little pin. That's how close you can get in terms of like figuring out kind of in what range that plate was spotted. So the big problem with this kind of technology is that unfortunately, it is always on, and it is basically everywhere, tracking absolutely everyone. They can collect thousands of plates per minute. From the EFF website, they say one vendor brags that its data set includes 6.5 billion scans and grows at a rate at 120 million data points every month. In aggregate over time, the data can reveal a vehicle's historical travel. Those of you who were in Senator Wyden's talk the other day on cell phone companies and how they kind of keep all of this stuff forever, and that it's just so voluminous and it gives this like intense tracking of like point by point of your day, often your license plate can do the same thing. So just as dangerous to keep around forever with kind of no limitations whatsoever on its use. Unfortunately, there is another unintended similar consequence. I live near Los Angeles. There are lots of malls that are actually in the LA area that have this technology that when you walk into the mall, you get your little ticket, and then when you come back to your car after you're done shopping, you put it into the machine, and it tells you where you're parked. Wow, that's really convenient. Except that it's doing that because there is a license plate reader trained on absolutely every single spot, and they marked your license plate when you came in. You have no way of knowing this, but that data was then also packaged and sold to one of the vendors for ICE. So you don't have any way to know that where you're driving in places, and you're just like using a convenience technology that involves your license plate, who is actually running packaging and then reselling that and using it to often terrorize your neighbors. So there are two major methods for confounding the technology. I think there's probably more, but I like bucketing them into these two. You can either block the collection of information, or you can overload it with additional information. So one, we are trying to prevent those scanners from actually reading in the correct kind of diagram of your face or your body or something different. And in another one, we're trying to replicate that detection over and over and over again. We'll actually go through these two examples. So we're actually going to focus a little bit more afterwards on obscuring exploring with additional data. This is a Calvin and Hobbes strip. I'm going to just read it because it kind of gets to the point. Calvin says, "I'm filling out a reader survey for Chewing Magazine. See, they asked how much money I spent on gum each week, so I wrote $500. For my age, I put 43. And when they asked me what my favorite flavor is, I wrote garlic and curry." And Hobbes says, "This magazine should have some amusing ads soon." And he says, "I love messing with data." So artists have traditionally, over the last couple of decades and more recently, used both methods to especially mess with digital surveillance technology. So drones, when they are seeking out targets, they often look for a heat register of a person. So there's a fashion designer who has actually built anti-drone camouflage apparel that is meant to block that heat signature using a reflective fabric. This one is a really cool example. A technologist and artist, Adam Harvey, worked with a bunch of makeup artists and came up with this thing called CV Dazzle, or computer vision dazzle. It's named after when people would, or I think back in World War II, I believe, they would put on the boats this sort of like wild black and white pattern that at a distance would kind of be hard to visually interpret. So taking inspiration from that, there's things that you can do to a face that actually, when you draw that little bounding box around it, it makes it really hard to run it through that neural network and effectively compare and match to different faces. So this is one of the face charts that they came up with. And then I also really love sitting on the idea too of the fact that the point of this project was also to develop resources for other people to use. So they have these sort of styling tips that you can find on the website. And then they also used face charts, which are diagrams that makeup artists actually use to share styles, convey concepts, and teach one another. So that him and a bunch of these makeup artist friends, they developed an entire library of resources for you to use. He also then developed these stickers, which you can see on this gentleman, which can then just be kind of placed on your face instead of having to worry about having a full makeup kit, which I think is an important accessibility note. So this one is pretty cool too. There are a few scientists in Belgium that have been working with those image recognition models that not only try to tell where your face is, but also, is this entire object a person? This little sticker or tile that you can see on this other person is meant to sort of break up the form of the body. It makes the image confusing. So if I have something that looks like, when I'm making those little quadrants or those little squares as the computer vision technology, that doesn't really look like a person. It's just kind of a floating torso and some legs. But as you can imagine, the tile is kind of challenging because it only really works in one direction. This one I think is super funny. So instead of worrying about your face being recognized, an artist named Leo Savaggio decided that you can just use his face. Go ahead. The printing files are online. You can just go ahead and take them, stick it on, and it does work. It absolutely does read as this gentleman. It's pretty cool. It's called You Are Me Surveillance is the project. So that's been touring. And then back to Adam Harvey. Man, he's working overtime. He developed this textile pattern called hyperface. So a lot of times when we're looking at those facial recognition images, it's looking for some of these like density or suggestion of dimension. So you have like these little spots that might be little like eye depressions, face and nose. The shadowing can be very important, often more so than like the little stick figure smiley. And you can see here that trying to basically replicate that in different sizes as many times as we can is we're trying to distract and get those bounding boxes around each of those parts of the image. Okay, so now we're sort of like from hyperface turning the corner into additional use of that overload of information. An artist named Simone Nikhil decided to basically use shirts that replicate people whose faces are very, very often found in data sets because they're celebrities. So in Facebook, it kind of overloads the auto tagging function. And now, my stuff. So this is a t-shirt that was developed to basically trigger automated license plate readers. We have basically OpenALPR and then a couple of other commercial plate readers were used to make this. Here it is on an actual human. You could see that it reads in as a variety of different plates, and then you have it also on the back. This particular API also tries to give you some information on what it thinks the vehicle orientation is and the color, which is kind of interesting. So apparently it's an SUV crossover. So you can see also I have this dress on right now. It is actually the text of the Fourth Amendment, and it works pretty well. So we're going to try to get into, thank you. I hope this is visible, but this is a live video feed on one of the commercial applications called Easy ALPR. You can see those bounding boxes lighting up. Excellent. All right. So yeah, you can see also the captured number here is kind of interesting. The number of plates that it seems. There is the dress I have on right now, lighting up like a Christmas tree. It really loves it. So some things just really seem to kind of scratch the itch for certain APIs, and we'll talk a little bit about why. Oh, and just a quick time check. I think we got the half sign, but I believe this is a 50-minute talk. Okay, just checking. Thank you. All right, cool. I was about to say, I'm very frightened. I have a lot of slides left. So you can see it works on video feed. Very excited about that. And we're going to talk a little bit about why I used commercial apps, and awesome how you can design your own. Some of you might be saying, that looks super cool. I love it. Others might be saying, I think I could do better than that. And you know what? The rest of this talk is for both of you, because now you're going to learn how you can do that, because art is for everyone. So you can pick your recognition system, anyone you like. You can try ALPRs as well. You can go for facial recognition. You can go for those whole people. And then you're going to look up those libraries and APIs. At the end of the talk, you're going to have a link to a bunch of these resources where you can try them. I'm also going to very much encourage you to use commercial applications. And the reasons for that are a couple. They can be found everywhere. You can just pop open Snapchat or Apple's facial recognition in the photo function, Easy ALPR. There are so many, and it's an easy way to check your work. And it kind of is a binary output though, so you're either going to get it'll respond to you or it won't. You can't really look under the hood and see those confidence scores or other markers. Apps usually also collect other tracking data, so your mileage may vary. Please read the terms and conditions and make sure you're cool with all the stuff it's going to ingest while you use it. So I actually think this is really important for a couple of reasons, but mostly because of the way we're going to work together to design this experiment. So in the real world with government surveillance systems, I can't look under the hood. I usually am not going to get access to even the training data sets that they used. I can't peel apart the neural network layer by layer and see the logic that it's using. I'm going to get as few outputs and success indicators as I will for commercial technology. So an ideal design experiment should be structured to be robust against those black box systems. And commercial applications can actually give us some of the similar effect that we're going to have. Something that I also found out even just in the course of this time at DEF CON is that if they are very similar, it is for a very good reason. And that's because often commercially sold applications that are used by state agencies have training data sets that are typically not statistically significant really from public data sets that are going to be online and used by some of these open systems. So I'm going to have you start then with your high confidence images. So in the case of OpenALPR, there is a benchmark folder inside the repo. You can usually go dig through and find them. Or you can kind of collect your own. I suppose it's a little bit more painful, but platerecognizer.com also has a bunch of folders of them. Start with those high confidence images, and we're going to talk about what that means. So when I read a photo into the API, it's going to spit out all that interesting information back at me, including a confidence score that it is this particular plate, what the area of in the photo that it is, and then it's going to give me back all that information about I think it's an SUV crossover, or maybe it's a Jeep Wrangler. I don't know. So now you're going to test your tolerances. You have this awesome folder of very high confidence images. You're going to make gentle modifications to the source images to test the tolerance of those systems. I'm basically holding up a bunch of cards to the API, and I'm asking it, what do you see? So shift the orientation, change the sizing, add and subtract parts of the image. You can cut them in halves, rotate them, slice and dice them, change the colors and the contrast. Try also moving them kind of sideways so that we viewed at an angle. Some of these systems actually try to clip and then rearrange them if they're at an angle. Some don't. You're going to want to find out. And I would say if you have this, do it in whatever way is fastest for you. There are some libraries that will let you do this in Python. I actually personally have been using other kind of image modification products for, I think, like 10 years. So I'm just physically faster at doing it that way. But either way, my preference is to just basically build up this giant stack of images, and I've kept careful track of like how I've modified each one and like whether I'm trying all one state or different states, and then I just batch test them. You can do this right from the command line. So just to touch briefly on what Pillow is, it's not the world's like most feature rich, but it does have some things that I do recommend playing with, and one of them is the dithering function. All it does is take an image and kind of guess at turning it into a black and white only image. And that is very, very effective for kind of getting some of that feedback that you want in a decent amount of time. So let's take a look at kind of what I did. So here we have the license plate game. And this image is actually one that you'll start to see come up quite a bit just because it sort of ended up being this like stock photo for samples of different states' plates. So I run it through the API, and honestly, they all look pretty good. They work really well. I'm pretty confident at what they look like. And I don't know what the problem is with that last one down there. It's just not cooperating, Wyoming. So now I've desaturated the image, and you can see where a couple have dropped out. They're kind of not as confident as they used to be. And I'm going to now kind of run it through what I thought was that sort of dithering function. And you can see a couple more drop off as well. Also, the images are kind of noisy. There's obviously like a lot that you're not going to get out of just like straight up converting an image to only black and white. So my process after that was sort of just to like keep carving out chunks of that noise, the thing that like makes it look messy and not designy, and see how often it still works. So this is an example of me testing my tolerances here. So I have this Nebraska plate. I piled up a bunch of images and I did weird different things to them. I decided to change the font. Can I use the license plate font I found online? Can I cut up the letters? Can I rearrange them? Can I change the spacing? Can I get rid of like any suggestion of an outline around the box? What's going to work and what won't? So you can kind of look at these, guess in your head which ones are going to work. That wasn't what I expected, I'll be honest. So it can be very, very challenging, especially I'm going to have you note the top one where the spacing is different from the bottom one. Hint, both of those aren't officially the way Nebraska is supposed to actually arrange its plates. So you might get some feedback that surprises you. But as a result, you're going to come up with these, after holding up your cards to your image and having all these different questions that you ask, you're going to get a really awesome set of answers. So I like to call these Q attributes. You start to get a gut sense of like what matters to this recognition system versus what does not. And often what features have disproportionate, impact on whether it's confident. So you can see the little screws here. Those like sort of design attributes that are like typical to a state plate. So they're like live free or die in New Hampshire. Even if I carve out a bunch of it, it kind of expects to see something up there. And then the distance between the letters, that's also going to vary based on which state you're looking at. And some other stuff. So there's like on some state plates, you have like registration stickers and other little suggestions of images. I actually carved out a much more complicated image that was in between those letters and replaced it with this little dash. Still worked. So I advise trying that as well. I think these are actually really important because what we're doing here also is developing these rules of thumb that you don't actually have to be, you have to be a coder to replicate them and use them wisely. I think we want to be able to communicate to people in other disciplines like what matters and what doesn't. I love working also with like people across lots of different spectrums of talent, both in tech and art. And I think just developing a better vocabulary for us to talk to each other is a really, really big part of this exercise. So plot enough of your images and you get a distribution of what seems to work. So here was mine. This is just what I found helpful. You might get, I think there's probably gonna be a couple more axes if you're using like a facial recognition system, but you have either that your font and your design elements are hyper accurate. It looks a lot like a plate, like it lives in a little rectangle that the image expects to see, or it doesn't, or the design elements are not accurate. Obviously, the ones that work really well are both accurate in both dimensions, and it's basically a photo of a plate, and I think that's super boring. So here we have some other things that actually still seem to work. So there was that state plate print I showed you where the font and design elements are more accurate, and it works pretty well, even though there's like no little rectangles for things to live in. It doesn't look a lot like a plate. And then this Fourth Amendment print that I'm wearing right now, these all look a lot like a plate, but the font isn't accurate at all, actually. And it is missing a couple of other design elements that it would expect to see. Still works. The awesome thing about figuring this out with whatever system you're using is those are awesome spaces to make art. You can really have a lot of fun, and that's where you learn that you have wiggle room to introduce design elements that you still think are kind of cool looking or that people would want to wear. So I wanted to touch on this because I get this question a lot, which is why don't you just make your own plates that work really well? So let's look at the EU license plate standards. To my friends from Europe, I can't wait to see what you do with this tutorial because you are going to have a much easier time. There's amazing diagrams online of what it's supposed to look like by law. It defines very specific things like space between the characters, the width of the stroke, which font. It even has like a sort of order of operations of what the different letters and numbers mean. Versus the United States. So here's a list of just one state, Idaho, and it's coded by county, and they're all different, and it's only changes if the previous one, all of them have been used. So that's one state. I made a little meme for this, which is from Ron Swanson from Parks and Rec, where he says, "Not to worry, I have a permit." And he just hands a piece of paper and just says, "I can do what I want." So, America. All right, so these are some of the things I ran into that did slow me down. They were challenging, so just expect them, and I think you'll have a good time. You have to balance whether or not it looks like a plate, especially. I mean, getting rid of that rectangle, it just doesn't like it. So you're gonna have to struggle against that a little bit. Other desired design attributes, obviously, I don't wanna have it always look like just a pile of plates. It's worth the effort, but I think you're just going to spend a little more time on it. Some states' fonts and spacing don't work in other state plate formats, and you might find yourself suddenly trying to mix and match a little too much, and then suddenly everything stops working on one side of the image, and you're like, dang it. Sometimes the API will also, as we saw in my example of the ones that are all modified in different ways, allow another state plate's lettering format to fake out what it expects to see for that state. As a result, I've gotten ones where it's clearly a plate that says Missouri on it, but the API loves to tell me it's from Florida. I can't make it change. I can't figure out why. So deciding, I'm going to also spend a little time on this one, which is deciding where to ethically source your plates, faces, or any other images that you're going to use. So I did my best to find what I guess I would call out-of-use images. So things that are functionally public, they're kind of like a stock image or something that's been reused a lot, or it's on Wikipedia, or it's just functionally something that it's so public that you adding that to the set isn't really going to change much. Or they're functionally out of use. So you can go to junkyards and buy old ones. You could find them hanging on a wall of a restaurant or on eBay or on craft decor. So they're things that people are not driving around. I also get the question a lot, which is, why don't you try to figure out whether or not they do belong to somebody? Because that costs a lot of money. Unfortunately, it is one of those things where you're not supposed to be able to pull that information just from any plate on the street. If you do have enough money, anything is available to you. I do not have enough money. So I just have to do what is within my power as an artist and a good person and somebody who's trying very hard to be a good example, to do what I can without either being a millionaire or otherwise having access to perfect information. So please try your best. Also, that is to say, if you want to put your own plate all over a t-shirt, that's your decision. Might be then spotted around some other parts of town, and you might find that beneficial. But I'm not the boss of you. So here's another amazing sample solution. Look at all these wonderful people's faces. Wouldn't they be fun to use on some kind of facial recognition project? Guess what? You can, because none of these people exist. They are from thispersondoesnotexist.com. Awesome, sort of generative adversarial network. I'm going to flip back for a second. That just makes people. And they don't look like, or they're nobody. They might look like somebody. So just, model that out as best you can. So now I have my images that work. I figured out I have this great pile. I want to put them on fabric. They look awesome. Anybody can design a pattern. I really truly believe everybody in this room would be capable. Like, you may not think of yourself as like an art person or a fashion person, but I'm so glad that you are in here because you are absolutely have all the skills at your disposal. So we have a front to back. This is like the rest of this talk is going to be like, how do I deal with all of the stuff that I have and then making it to the point where it's useful? Because I've read a ton of papers on amazing adversarial patterns and pictures and all these things that work. It's really hard to find out how to access them. And I think everybody in this room can also be part of that change on how we put those in people's hands. So basics, the half brick is the thing that you're going to see most often. If you have a bunch of like things that work, just putting them together in a line, then moving it down one and shifting it over about halfway, gives you a pretty aesthetic pattern. Works pretty well. The diamond repeat is actually the basis of most seamless pattern making. You might actually want to like make note of this, not just for fabric, but I think any surface design. If you're thinking about in your head, oh, I'd love to put this on a car wrap or a mural or something interesting, you're going to have to know this. So I've changed the contrast a little bit so you can kind of better see what I'm doing here. So you have these tiles that repeat. It's because each individual one, like I made this cool design. Let's imagine it's like a cluster of plates or something. I'm going to divide it into quadrants and then move the one from that side down to like, so if it's the top left, you're going to move it down to the bottom right and complete that with every single quadrant. And that is how you get, it's really hard to tell actually, but I have a plate cluster and a circuit cluster. And all I did was I chopped it into quadrants and then I moved them down each corner and then I filled in the middles and then I got a beautiful seamless print that looks pretty nifty. So you could say, that sounds really hard and like it involves math. It does, I'm sorry. So here I'm gonna try to give you some examples of things that don't need math. So here is again our Glamoflage facial type of t-shirt. What they had done, the artist, is to just create these like horizontal blocks, and then they're a little bit different, the three of them, and they stack them staggered one on top of the other. This is really, really helpful because if you just go big enough, you could just slap a t-shirt right on it. It's really okay. You don't have to worry about whether it repeats or whether the edges fit together. So the contrast in the images that you're using for your facial recognition patterns are very, very important. And then if you're like, oh, but I really like these colors and I want to make them work for my design. I think one of the things that's going to be really important to you then is to learn just a tiny little bit about color theory. I promise that this won't take very long. But tint, shades, and tones. So things that are mixed with white, mixed with black, and mixed with gray. Those are going to affect your contrast of your final image. So pay attention. Things that look good together tend to be all the same tint, tone, shade, levels. You're also going to find that when you're running this through image like editing software, you're going to want to like convert that to black and white once in a while and make sure you check. The actual technology is sometimes sensitive to that. So that's why the top looks great and the bottom, not so great. You can actually then, if you're like, this sounds super hard, you can extract different colors. Like you have this DEF CON art from last year. Those are part of color families, so things that are all next to each other on the color wheel. We have a really cool EFF t-shirt from last year, which uses triads, which are two things next to each other and one opposite. Also tends to look very cool. And borrowing is okay. I think like getting over the hump of like, I'm not good enough at this to make something that people would want to wear, just grab an image that looks aesthetic or a piece of clothing in your closet you already like, and you can run it through some of these. I have the link list at the end of like Adobe Color or Cooler or degrave.com you can use to then extract samples. Monochromatic is also super cool. We're all hackers and we all like wearing black. Easy enough. So let's put it all together. My example here. We have our fake faces. I'm going to do some complexity reduction. Pretty simple, not going to spend a ton of time on it. And then do our derived color combination from some other prior art. So I now have this facial recognition triggering jacket. All I did was just replace some of the colors and kind of strip out a little bit of the noise. And yes, it works. It doesn't have to be so hard. So here we have the Apple's facial recognition on the image, on the jacket. It does actually do what it's supposed to. You could continue reducing noise and improving simplicity until it stops working. And then you're going to get that information back on how you can make a pretty snappy pattern. So from pattern to production, this part's super important because I think we all have lots of great ideas, but getting it actually out there is a really big hurdle and has been previously. Fabric is not pixel perfect. I really love the whole like turtle, AI thinks turtle is a gun project where it 3D printed a turtle that the pixels had been moved around such that it interfered with the model to the point where it thought it was a weapon. But full adversarial models tend to need to be pixel perfect, and they only work in one direction. Soft goods have a lot of constraints that way. Set your expectations to wearable clothing with reasonably durable imagery. So what is reasonably durable? You have to think about a wraparound pattern. Like this one goes all the way around. Does it work with the curvature of a body? So I am a plus size person. I had to size up to make sure that things were not warped when they were either too small or fitting in a strange way. As a result, can you pick fabric or materials that are going to help you out in that endeavor? Should your garments be loose or structured? This is a picture of a raincoat. Might that actually be stiffer and be more reliable when I'm kind of at different angles or sitting down or standing up? You're going to want to test and test over and over again. I'm going to get into some of the ways that you can actually develop prototypes, but I think each individual step is important. Flat digital prototype, test it. If you're using a system that lets you do digital mock-up like this one, go ahead and run it through. I know it's not a photo on a real person, but it's helpful. And then you get your print prototype made, test it again. They are often really good creator discounts at a lot of these sites, and so you can order some samples for quite cheap. So big thing here is that the digital printing process on fabric is made using a heat bonding dye injection process. It tries its best to get in between the fibers, and it's not always very successful. So you're going to want to make sure you work with the texture of your fabric, not against it. Work in very high files. I've seen so many things go awry because people like literally need more JPEG. So you can actually also order fabric samples. They're like $2, and they send you this giant box, and it has like hex codes actually printed on them. So they really try to help you out here. So it's easier and cheaper than ever to make them yourself. Drop shipping is basically the process by which you have a design that's available online, and it is only each one. You don't have to hold inventory. You don't have to buy 25 shirts and keep them in your closet and hope somebody buys every single one of them. They are made to order. It is very low risk. You can print on demand. You can print samples very rapidly. I have vendors that I've worked with that I've really liked. Printful, they have a really awesome way that you can piece the pattern. It shows you where it's going to be the cut and sew service, so you can make sure that like things match up and that it looks the way that you expect. There's Contrato, which is actually this dress right here. A little bit more expensive, but very nice quality. Spoonflower, where they can make fabric by the yard in like 30 different ways. They can do wallpaper, which is pretty cool. They can do gift wrap in case you like giving weird nerdy gifts to people. And then Wildamash, which actually like looms sweaters. I have a little mock-up sample here. I think I saw somebody in the audience who had this shirt on. Yeah. So love the art. So I decided, you should look at it as a sweater. Imagine. So it brings the price of this prototype process way down. Before it used to be that you would have to like be an academic at like an institute, and you have to get a budget to like make sure that you could actually afford to, print these things out. 15, 20 $20. It really isn't that bad. So I think it's also really important to bring the final garment cost down, because people will take a chance on that concept clothing if they can afford it. And honestly, a lot of these are also like increasingly they are like made in the United States. There's a really great Printful shop that's a provider for all over printing in Los Angeles. So it actually also might not take as long to get here as you think it will. So manufacturing your own. As you wander into the world of dropship, please, I just felt obligated to put the slide in here. Please don't get scammed. Please read the reviews. There are lots of creators online who have told you like which printers are good and which are bad. It's reducing your risk. I don't think you're gonna make mad stacks. I think you're gonna like basically break even on a creative idea that you think the world needs to see. I think that's really, really important, and it's never been easier to do that. So you're gonna be balancing your manufacture quality, distance, shipping time to your happy customers, and the wholesale price. This is really important. I was so inspired. So there's a indigenous artist named Mona Cliff who has been working on putting QR codes into traditional beading. It's still like everything still works if you use stenciling. You can use silk screen, beading, knitting, murals, like so many traditional handmade methods. It does not have to be digital. Still works in these recognition systems, still can be read by machines. So the objective here, just to kind of like sum that all up, is we're lowering the barrier to entry on caring about surveillance. Everybody wears clothes, ostensibly. Understanding how the technology works is hard. Buying clothes and wearing them is easy. Something you can engage with in a tactile way makes it fun, and you can learn about it, like, and put a little card in when you sell it and teach people about why they should care about this thing. This is actually an anti-paparazzi scarf. When you try to hit it with a flash, it blows out the photo. Very cool. And if we want people to care about surveillance, I really feel like we're going to have to keep doing this in lots of areas. You literally have to give people something they can hold in their hands and help them like understand and use it. And they could try it themselves on their own phone and really begin to understand like how this stuff that everybody in this room and we all carry very deeply and hope that they actually want to push back on these systems. They should really get a sense of how to test them themselves, be little citizen scientists, and then start seeing that everywhere. And I think clothes can be a great way to do that. So just to give a little sprinkling of course, because this is the crypto village of other things that you could possibly think about if like triggering recognition systems is not your game. There are historical analog applications for Fabric. This is actually a letter addition square that was used to add 5-letter groups to a cipher. So it's like if you can actually learn in the next room about how these work. But spies would have them either in the linings of their jacket, or they would tie their hair up with them, or put them in their knitting bags so that you could pull them out and they were quiet. They're printed on silk. They're reasonably very durable. And then they would say like, okay, I've used this letter transfer block, this particular cipher, and they would put pinpricks in them or embroidery in them to denote that they had been used. So pretty cool. So there are also people who are working on trying to embed them in other ways. So we have like some pretty cool, just like, you know, letter in substitution, like a substitution cipher put into fabrics and woven in. They can be done big or small. Pretty cool. And I wanted to put in those slides because I'd like us to get thinking at the end of this talk sort of about how do we weave anti-surveillance design into the world? I think one of the big things that would have helped me a lot, and how you, I think, encourage lots of other people to take attempts at this thing, is to empower collaboration. You don't have to do all the work yourself. Maybe you watch this whole talk and decide, I'm not very good at art. And this all sounds very confusing, and I'm not a fashionista. But do you know somebody else who is, who could maybe unleash a lot of creativity? Could you make them a tool that lets them not have to use code to test these systems and engage with them? I think that's honestly the biggest thing that a lot of people could probably do. Throughout the process of doing this and continuing into some of the future designing, having the ability to like launch a simple tester app on things like, Android or on mobile devices in particular is like a really awesome, fast way to check your work. So I think also we want to think about bigger, not just people. I think surfaces, surface design can be anywhere. I would absolutely love to have a mural up somewhere, either in like Metro Los Angeles or any major city where cop cars go by all the time, and just put up some of these plate designs and see how much garbage that we can basically inject into those databases as they pass by. Anything that you can do to make the data set less useful. They have to pay to store it. They have to pay to analyze it. I think every little bit of being non-compliant is super helpful. So think about like murals, billboards, clothing lines, posters for events like a hacker conference. So I really don't want to leave you without reminding you that this looks easy, but image recognition technology and computer vision technology keeps getting better. Even in like the cycles of automation are so short now that I can barely keep track. Some of the anti-surveillance patterns that were created by other artists as I was doing research for this talk already no longer work. Happens. But that's the point, right? So hacking surveillance systems should maybe, I'm going to posit, not be about trying to outrun the arms race. How do we normalize mimicry aesthetics? How do we make it easier to do this on shorter and shorter cycles from our side of the equation? So remember, it's about developing a design methodology that you can repeat every time these things catch up. For continuous testing and iteration, it's not a one and done process. I think if you remember from the movie The Fifth Element, I really love this guy. Bruce Willis looks out in the hallway and he sees what he thinks is an empty hallway. And it turns out it's just the guy wearing a picture on his head. It works. I don't know. So don't limit yourself. So I have all the slides up at adversarialfashion.com. You can see resource links. The slides will actually be up right after this talk. You'll also have resource links to everything that I used, you can use. Please treat this as a tutorial. Show me what you make. And then I have the available designs so you can see how they were composited onto different types of dresses. And I just love being able to say Fourth Amendment crop top. Like, that's a really cool phrase. And then I really, really can't can't finish this talk without thanking EFF senior investigative researcher Dave Moss. Honestly, the concept couldn't have happened without him. He just mentioned in passing that like the specificity on these systems are low. They read billboards and fences and all kinds of junk. So that unlocked a lot of creativity. So maybe information you share could do the same for somebody else. So I definitely invite you to go to EFF.org, check out their section on ALPRs. There's some pending legislation in particular that might be coming to your state, or if you're in California, has already been introduced previously to take action on license plate privacy. And that is the end of my talk. Thank you so much, everyone. I really appreciate it. So we do have some time for some questions.
If you have a question, please come line up by me.
Oh, my Twitter is Kate Rose B like the insect. All right. No questions is okay as well. We got some few. Okay, just check it.
I have a question. Great talk. Thank you.
Thanks.
Do you have any advice or concerns about the fact that a lot of these algorithms for surveillance are also used for safety critical systems and automation?
They also use what? Sorry.
They're also used for safety critical systems and automation, like self-driving vehicles.
Oh, that's really, really interesting. I think one of the things that, so just to repeat a little bit of the question, that some of these are like safety driven systems as well. So I don't necessarily always want to be fooling things that are, that we depend on to keep us healthy and safe. I think honestly you should then think about this as a way to report back to those companies that you found a mistake. I think there's actually been some really cool research in particular of showing how like salt lines on the road. There's like another talk that was given on how to like red team AI without being a chump. I like that title. And they had talked about the fact that if you salt the road in particular ways, that messes up lane detection for certain kinds of cars. I think if you identify something like that and you think that there are safety dependent systems that are messed with by these, you should absolutely write to the company, tell them what you found, treat it like any other kind of exploit. I actually think one of the things that it kind of stinks about using license plates for so many different things is that like, yeah, it's pretty much something that anybody could do with any plate they want. And I don't think as a result, they should be used for highly sensitive things like incriminating you for evidence or, even ticketing you in a lot of cases. So that would be my response. But otherwise, great question. Thank you.
Yeah, awesome talk. Really liked it.
Thanks.
Did you find anything about like testing a particular design across multiple models and finding that something worked really, really well in one model but like really failed with another model that you had, and like what did you learn from that? Yeah, great question. So across the different open versus commercial systems that I was working on, so there's like easy ALPR, plate recognizer, and then open ALPR. I found that the biggest variance was specificity. So some of them that I think are meant to be used as like a person who is maybe a layperson using their mobile device. They are more sensitive. They will basically take in a lot of information of anything. They overvalue that like rectangular function a little bit more than anything else versus something that's kind of like reading things in as a flat image as the primary function of the API versus a video feed tended to affect it. So I think I have what I think are key takeaways, but I think with a larger training set, somebody else might come up with a different conclusion. But yes, they definitely vary. I think often folks, and they frequently rewrite and make their own sort of like recognition algorithm that overvalues one thing over another, maybe based on customer feedback. I would love to get my hands on one that's used by state agencies. Apparently you can get them on eBay. So if anybody wants to pitch in with me, we can answer that part of the question too.
So it seems like if your address became really popular, the software providers could just start filtering out all the text of the Fourth Amendment, and then they'd never get false positives anymore.
Yeah.
So is the tooling in place that you could make it so that every address has different text on it?
So it's very cool that you bring this up, but It's possible, yes. It's one of the things that actually becomes really cool and interesting about the proposition is that because I have lowered the risk point, which would normally be if I'm normally a clothing designer and I have to like loom things or print them myself, remaking those like without digital printing, like remaking screens for a silk screen or remaking loom like your loom orders with a wholesaler, that would be really hard. Now actually it's very easy. So if I find that it's screened out or they just don't like my clothing anymore, I can go on there, dig in my pile of plates that I have that still really work, or go find new ones. And honestly, like the don't overestimate the amount of time that this takes. Once you have a method, I think I can update a new design in like 20 minutes. So I can outrun them for a while. I think with like your collective help as well, if we're all coming at them from different angles, it makes it a little harder. So thank you. Great question.
One of the things I was thinking about immediately when you were talking about like all the modifications is possibly automating that, so you could just throw something at a machine, at a model, and then like it would do a bunch of different, color modifications, so you could quickly find something that was aesthetically pleasing that might look cool. Do you think that's reasonable or possible, or like how much of it was like you as a human had to figure out like this would be a reasonable transformation?
I think it's super automatable, honestly. So some of even the technology that you were looking at that extracts palettes from different things kind of operates on functions that I imagine would be also similarly helpful. So like having dials that kind of move it up and down. I am not the world's like most prolific web developer, or else like a tool would be amazing. But if people wanted to collaborate on that, I'd be super open to it. All the methods of things I was doing are, if I use them in Adobe, it's just because my hands are faster than like literally figuring out how to code that image modification tool. But it's very possible. I would imagine that slider bars, samples of palettes, any of these things could easily be built together. There's a lot of like really cool pattern making tools that I often use online that you just drop a bunch of icons in, drag them around, and it makes the repeat tile for you. So it is, some of it to some extent actually is already out there. But yeah, I think it would be pretty easy over time to work on that. I know that I'm increasingly also really interested in like generative adversarial networks as one tool to address that. And I think that's kind of the area I'd like to explore next.
All right. Something like that screens you as an activist. So instead of being processed by a robot, end up being in the manual processing, and your face will be very carefully recognized. Wouldn't that happen?
I'm sorry, I didn't quite catch the question.
So that it would, well, that's a threat, right? So is there, well, how probable would it be that you are, since you are broadcasting, well, distance, then you would be screened manually?
I'm not sure I caught the question. I'm really, really sorry. The microphone was going in and out. I apologize for making you repeat yourself.
Yeah, so what I'm saying, wearing these manifests that you are, well, resistance. Therefore, the automated system can flag you for manual processing. So
yeah, that's true. I think, like, honestly, that is just like one of the risk points that you have to incur when you're kind of working on this sort of stuff, is that you can have items that end up flagged where they need to be reviewed by a person. I think the volume kind of works in our favor in this case. I think, the fact that plates are ingested so rapidly and these databases are gigantic and messy and implemented by people who are, generally speaking, they're not that thoughtful. I really don't mean to not flatter anybody, but at the end of the day, it's a tool to get a different job done. And I think the actual investment in making sure that it's accurate is quite low. So. Awesome. Well, thank you so much, everybody. This is a really wonderful, thoughtful set of questions, and I really liked sharing with you.
I'm very thrilled to present to you all our very last talk of the day by Margaret Farrow, Piercing Together Your Personal Privacy Profile. Margaret's interdisciplinary background is a wonderful example of what I love about our community of going down fun rabbit holes, combining and utilizing knowledge in ways that we all can benefit from and apply to our own daily lives.
In a minute. In his New York Times Dealbook column, Andrew Ross Sorkin said, "Every day, professional investors and research analysts work the phones to ferret out information about companies that can't be found by simply reading news releases. Because they're compiling this information from many different places, this doesn't count as a tip." So what does count as insider trading? And welcome to Wonderland. My name is Margaret Farrow, and this afternoon I will be sharing a talk with you on piecing together your personal privacy profile. By the end of this talk, you should hopefully be ready to create your own personal privacy profile based on the information that is currently available about you online or in other places. First, I'm going to introduce the concept of mosaic theory. This concept comes from finance, but I think that it's very useful in understanding your own personal privacy. Then, we'll talk about how to map mosaic theory concepts to your own personal information. After that, we'll go into the more practical portion of the talk and begin with how to audit your current public information. then how to arrange that public information into your own personal privacy mosaic. These two sections are really the core of the talk, where you'll learn about how you can do this at home after we finish today. Finally, I'll introduce an example matrix based on a Wonderland version of my own personal privacy model. This matrix will give you an example of what it might look like for an actual person to complete this process. Before we go too much further, though, I have this entire wall of text of disclaimers for you. I am not a lawyer, a financial advisor, the SEC, or in any way entitled to decide what is or is not legal or insider trading. I am especially not your lawyer or financial advisor. This whole talk is provided without warranty or guarantee. This is not legal advice, and this is not financial advice. I'm going to talk about how legal and financial concepts work in a general sense based on a layperson's understanding, so we can all have a shared basis from which to discuss their applicability to your own personal privacy. Do not make financial or legal decisions based on any information in this talk. Talk to actual experts if you feel inspired to make financial or legal decisions after watching this talk. Do not rely on my information here. I am not an expert on insider trading regulations, but I will discuss them as a useful lens through which to view personal privacy. As thanks for listening to an entire slide of wall of text disclaimers, here is my cat tax. So who am I? Why am I sharing this with you? I am currently the security lead at a small startup, and I have a strong technical communications background, including many years of experience as a technical writer. I also hold security certifications, including the GSEC, the GCIH, and the GCIA, which are the GX Security Essentials Certification, the GX Certified Incident Handler Certification, and the GX Certified Intrusion Analyst Certification. I've also spoken at conferences like Write the Docs Day Australia, O'Reilly's OzCon, TourCon, Abstractions 2, and many more. My primary interests as a speaker and as a learner are the interdisciplinary connections between fields in technology. And today I'm going to share some of the intersections of financial concepts and personal privacy with you. First off, I'm going to introduce the concepts of mosaic theory. I first learned about mosaic theory from Matt Levine's March 2018 column, Deductive Reasoning or Insider Trading, It's a Tough Call, which was in his Money Stuff newsletter and referenced the mosaic theory. That was the first time I'd encountered the term, but I dove down a learning rabbit hole from there because this felt really applicable to me in terms of information flows and how we think about the distribution of information. So first off, I understand that many of you are crypto or privacy professionals or interested in crypto and privacy, and you might not have much of a background in insider trading. So we're going to start with this definition from the United States government's investor.gov website. They define insider trading, or specifically illegal insider trading, generally as buying or selling a security in breach of a fiduciary duty or other relationship of trust and confidence on the basis of material non-public information about the security. Insider trading violations may also include tipping that information, securities trading by the person tipped, so using the information that you have received that you shouldn't have had, and securities trading by those who misappropriate such information, including hackers. Specifically, we're going to focus in on the portion of this referring to material non-public information, because that is the core of what counts as illegal insider trading versus skilled financial analysis, which we're going to come back to in a minute. In his New York Times Dealbook column, Andrew Ross Sorkin said, "Every day, professional investors and research analysts work the phones to ferret out information about companies that can't be found by simply reading news releases. Because they're compiling this information from many different places, this doesn't count as a tip." So what does count as insider trading? For these purposes, insider trading is what we will count as bad, and is contrasted with skilled financial analysis, which is considered good. For something to be insider trading, there will be material information directly from a reputable source. That information will come prepackaged together, and the information is useful alone. So when we hear about analysts calling a bunch of different places to get information, they're not getting something that they can act alone on from any one place, or that might count as a tip. On the skilled financial analysis side, we have immaterial information from multiple sources. So that information from any one place is not significant on its own, but when combined with material from other places can become more useful. In skilled financial analysis, you combine that information to create useful packages. So you are doing the work of acquiring information from more than one place and combining it together. Those individual pieces of information are not as useful as the whole mosaic that you construct by gathering information from many different sources. I have a couple examples for you here that come from SEC rulings because they are the ones who get to decide what counts. The SEC is the United States Securities and Exchange Commission, which is what determines for my location and the main location where DEF CON is, what counts as illegal insider trading or what doesn't. This first example was found to be insider trading, which was bad. The SEC charged a San Francisco Bay Area finance employee and their friend with insider trading. In this case, God, who was the finance employee, worked for a Northern California-based banks group to assist private equity firms in financing company acquisitions. So they were working for a bank, helping to figure out whether a company would pay for an acquisition of another company in a certain way, which, as you may guess, often has significant ramifications on the stock price. God tipped his friend of several years, Nathan Guido, on 3 occasions about upcoming acquisitions that he had learned about at work. So this was a reliable source because they worked for the bank and had acquired the information through the course of their work, which means that they probably weren't supposed to be sharing it elsewhere, and it was shared with a friend. According to the SEC's orders from the settlement of this case, Guido bought stock based on those tips and sold it after the acquisitions were announced for a profit. Both settled with the SEC and criminal charges are pending. In this case, the information was all from one source, the information was useful on its own, and that source was reliable enough that the information was to be trusted. Here's another example of alleged insider trading. This one still hasn't been decided, so it may turn out to be okay, but it also sounds bad. In this case, the SEC charged 3 people with insider trading for trading in Long Island Iced Tea Company before the announcement that it would pivot to become the Long Blockchain Company. That pivot caused the company's stock to soar. An employee who had encouraged the pivot within the company told their friend and broker of the plans against their NDA or non-disclosure agreement, which said that they would not share company information with people outside the company. They also shared a draft press release as part of that information, which the friend allegedly used to make trading decisions. There was a really great quote in this press release from the SEC, specifically from Richard R. Best. Richard R. Best is the director of the SEC's New York regional office, and he said the SEC remains committed to preventing all types of fraudulent conduct in connection with purported crypto companies, including profiting from trading on material non-public information. Here is that phrase again, material non-public information, as the thing that differentiates illegal insider trading from legal skilled financial analysis. Crypto or non-crypto companies, this really reinforces the profiting from trading on material non-public information is illegal thread that we've got going on right now with this talk overall. To the other side, there is this example that I like to use for skilled financial analysis, which counts as good. In the case Elkind versus Liggett and Myers, it was held that immaterial information was tipped to analysts, immaterial information, not material information. And those analysts were able to combine it with public financial disclosures and other materials to form a basis for trading. This case also did involve some insider trading charges resulting from a subsequent leak, but it was not all insider trading because the tipping of immaterial information resulted in acquittals on several counts. While this case isn't as recent as the others that I've referenced, it's a really good comparative example if you want to dig deeper into what is and is not insider trading, because both insider trading and skilled financial analysis were addressed in this case. It's also a popular case for analysis and teaching materials, so there's a lot out there to find, whereas the more recent examples that I use for what is insider trading might not have as much that's been written about them yet. In review, insider trading, bad and also illegal. Skilled financial analysis, however, is considered good, actually. There was also another case that I came across while preparing for this talk and that some of you may have seen, involving a person who marketed that they were selling insider trading tips in those words. And shock and surprise, they are now being charged with insider trading. The defense might very well end up being that this was not insider trading and only sparkling fraud because the tips were invalid. But like, don't go around telling the internet about crimes that you're claiming to do, even if you're not doing the crimes, unless you want to be charged with those crimes. This is kind of an edge case where it's an insider trading charge, not on the basis that there was evidence of material non-public information necessarily, but because the person said that they were doing the crime. Now that we all understand what mosaic theory is, we're going to talk about mapping mosaic theory to your own personal information. You presumably are not a financial entity in the sense that someone has a vested interest in trading on your personal information. At least I hope not. And so the examples that we've given so far may not be as directly relevant to your life. However, you also have information. Insider trading level information is what we usually think of as PII. It's valuable on its own with no additional analysis needed. What counts as material and non-public information about you is going to depend on your own personal threat and risk models. If you work at a public university or as an executive at a nonprofit, your salary, for example, might be public and easily correlatable to your name. So that would hopefully not be one of the things that you particularly care about not disclosing. If you work at a private for-profit company, though, your salary might be sensitive information that you want to avoid having on the internet and to disclose only to certain people at your own discretion, in which case it would count as material non-public information about you. There is also immaterial or public information, which may be found on Google and property records, etc., and is the main focus of the usual OSINT or open source intelligence or OPSEC operational security stuff that you might encounter, especially at hacker conferences like this one. Do note that this is immaterial or public and can include things like previously breached data about you that you would consider material, but which has already been disclosed publicly, because you can't really undisclose it at that point. All you can do is make it less valuable, like no longer using a password that has been breached. Some examples of material non-public information about you may be your bank balance, your passwords, possibly your salary, possibly a legal name, maybe a home address. I say maybe for these last three because there are really common situations in which these would be publicly available information. But for some people, it's very important based on their threat model that those be kept private. In terms of immaterial or public information about you, you probably have some social media profiles. There might be news articles that have been written about you, talks that you've given. Any of your previously breached data, even if it's not immaterial, is public. And so it would fall under immaterial or public information. Maybe your company's website mentions you, and that would be public information. And there also might be school or competition related information, especially if you are towards the younger end. It has become very common in recent years, especially within the US, for schools to put things like their newspaper online. If you participate in extracurricular activities like a quiz bowl or a science or math Olympiad sort of activity, then those scores and rankings, as well as your participation in certain events, are probably posted online after the fact, as well as any sports that you participate in may have been shared by your school or by the athletic consortium without your knowledge or necessarily consent. Here's an example of material information which is bad to release about a person having been released. A phishing campaign targeted individuals of interest to Iran. And I chose this example because in this case, we know a little bit about the threat models of the affected users. We know that these people were being targeted by a state-affiliated actor from the headline. And we also know that they presumably did not want that state to have the contents of their email inboxes. But the users who were successfully phished have had those emails disclosed to the attacker. And it's possible that some of the users who were not successfully phished also had their emails disclosed if they had been corresponding with a user who did click. This is especially important to think about because even if you are absolutely perfect in your own risk assessment and the corresponding risk management, there is some risk to every interaction you can have. This doesn't mean that you should give up altogether on making some information about you less convenient to access, or that you should give up altogether on having social relationships with other people and therefore sharing some information about yourself. But also don't assume that things that you have not personally released couldn't be public. A really important part of creating your own personal privacy mosaic is going to be incorporating the things that other people have released about you alongside the information you have released about yourself. There's also a lot of immaterial information. This may include your current employer, your job title, pictures you've taken at restaurants, the dates of your vacations or concert attendance, again, depending on your personal threat model. And this is usually considered good to release by many people. Is this actually good to release? Well, everybody's favorite answer, it depends. Releasing this or any information has both risks and benefits, and you should consider both the risks and the benefits of releasing information when you're deciding what types of information you are willing to post or share with others. Next, we're going to talk about auditing your public information. The very first step of auditing your public information is to consider where there is information about you. Think about first where you release information about yourself. For many people, this will include personal social media like Twitter or Facebook. It will also include professional social media, like maybe the same or a different Twitter account, maybe a LinkedIn profile, things like that. This may include a work or a personal blog that you contribute to, or if you ever do guest blogs, it might be someone else's blog that you have released information about yourself through. It may be Slacks or Discords, especially right now while we're doing a lot of hiring and conference attendance and job fairs and things like that through these venues, since some people are still sheltering in place. It may be events like meetups where you have casual conversations with strangers. It could be things like stickers or patches. If you have an EFF sticker on your laptop, that's going to tell people something about you. And that doesn't mean you shouldn't have an EFF sticker on your laptop, but consider that that is information that you are releasing. And finally, affinity fashion. There are things like small charms in certain shapes or patterns that certain chronic illness groups use as a sign of solidarity with others who have that condition. There might be things like pride flags that you choose to include or not include in photos on social media profiles, etc. And those are another way that you are releasing information about yourself, though it may be of higher or lower quality depending on the prevalence of allies to those groups also using the same symbol. You should also consider where others release information about you. This is going to include their social media or blogs, possibly news articles that someone else has written about you as a person or about your work or about a trend that you are taking part in. This is going to include Slacks or Discords where someone is talking about you or where someone is talking to you, and might include some of your personal information as context for something that they are saying. This is also going to include referring you to jobs or talking you up. Your friends, while they are trying to help you, might accidentally give away information that you didn't intend to give away if they don't know that you personally value that information not being shared, because your friends are likely viewing your information through their own threat model rather than your own, unless your threat and risk models are something that you and your friends talk about frequently. If they are, that's great. Keep doing it. It's going to work out better for everyone. But if not, or if your friends have sufficiently similar risk models that you're willing to accept theirs as a proxy for your own, then you might want to consider that they may be releasing information that you haven't released or that you wouldn't release about yourself. This is also going to include data breaches or data sales that you may or may not be aware of. If you are aware that your data has been included in a breach or that your data has been sold, such as because you made a CCPA or GDPR or similar law-based request for your information that has been sold by a company, then you can more easily include these things in your privacy mosaic. But if you don't know about those things, you should also consider that they are probably still happening to your information and that there may be gaps in your assessment as a result. Once you've had these two lists of the places that you release information about yourself and the places that others release information about you, consider whether that's all. Is there information that you normally consider anonymous, but that could be easily de-anonymized due to other information in proximity to it? For example, if you share information that is chronic illness related in a Discord, where you don't use your real name, but you also share information about restaurants that you've been to recently, someone may be able to match those two things together, either intentionally or just accidentally, like, oh yeah, this person's near me, in a friendly way, that will cause them to then know something about you that you didn't tell them directly. Also, consider your threat model. What is the information about yourself that you actually care about protecting? For most people, this isn't everything. Consider both what you risk by revealing information as well as what you gain by revealing that information. I have a few examples next of my personal threat model that might be good examples or metrics for you to weigh your own decisions against if you haven't thought through this yet. First off, there are the names Margaret or Maggie Farrow, which I use frequently. These are a little bit harder to burn than other aliases because they're names that I've had and used for a very long time in a very wide variety of places. And also, heavy use of a consistent name makes me easier to track, which is a risk of using these consistently. It also, because I use these names when I speak publicly, ties many of my talks back to me in the workplace so that my colleagues will know that I was the person who gave this talk and would easily be able to find my talks if they were to look me up for other reasons. But the benefits include that it also makes me easier for my friends to find, that it lets me leverage those same talks professionally, and it's lower effort than developing separate portfolios under multiple names. If I were, for example, to use 3 different names when I'm giving talks and have a portfolio of talks given under name A, a portfolio of talks given under name B, and a portfolio of talks given under name C, and then to make more granular decisions about which of those I intend to let a given group know about. Here is one that is a little bit trickier. I very frequently share my birthday, but not my date of birth, because by sharing my birthday, people tell me happy birthday, which I love. I know it's kind of a silly thing, but this is a serious benefit for me. I'm also less likely to be assigned projects due on my birthday if everyone knows when my birthday is in the workplace, and I might get cake or cards, which are also really nice. Sharing my birthday does make it easier to get my date of birth, which can be used in fraud. But for me personally, the small amount easier that it'll be for someone to commit fraud in my name relative to if they had to get the whole thing from a breach is worth it for those guaranteed benefits of people telling me happy birthday. The full date of birth or the age is a little bit different for me. I don't share those as publicly because of the prevalence of age discrimination in my field on both the young and the older ends. I still think that somebody could get it. And in fact, I know that somebody could get it because this is information that I know has been included in past data breaches. But the value to me of revealing it in the places where I put my birthday is negligible. And the increased risk that more well-meaning people would subconsciously use it against me at various points is not really worth that. You might reveal part of some information or know that that information about you can be obtained or revealed, such as through a breach, like the ones affecting many health insurers the last few years, Equifax, or a government organization. You might know that there is something you accidentally revealed or intentionally revealed before your threat model changed, or something that somebody else maliciously or accidentally revealed about you. But that doesn't mean that you need to commit to continuing to reveal that, or that you need to reveal that everywhere you reveal other information. What you really want to consider is how difficult it would be for the thing that you're worried might happen with this information to occur, and whether you can do anything to mitigate that risk. Revealing part of some information, like your birthday without the year, doesn't obligate you to reveal the rest of that information or related information, and it also shouldn't feel like you may as well disclose the remaining information. I know that somebody who really wanted to know my age or date of birth could trivially get it. It's absolutely out there. But by not putting it in highly visible places like my Twitter account, most well-meaning people I interact with will not encounter that information. And I think for my personal risk model, the odds of someone well-meaning finding this information out accidentally and then unintentionally holding it against me at various points in my life is a bigger risk than the risk of a malicious actor trying to find this so that they can commit fraud or just broadcast how old I am, I guess. You should also consider that your threat model may evolve over time and really should evolve over time. There are 2 main reasons that your threat model should change. One is that the risk of bad things decreases, while the other thing is that the benefits or the chance of benefits increase from revealing a certain piece of information. The risk of bad things may decrease when something happens like moving from living alone with a door to the street into a group living situation with multiple locks between you and the outside, where you might no longer feel as uncomfortable revealing something like your neighborhood or the city that you live in. You also might find out that information you were concerned about your employer learning has already been revealed to them, such as through a data breach or through someone unintentionally or maliciously disclosing that information. If, for example, you didn't want your employer to know about certain medical information or your sexual orientation, but then you find out that they already know this and nothing bad has happened, then there's less reason to be afraid that they will find this out if you mention it yourself. Of course, that is not a permanent change, and there are still future employers to be concerned with. So again, don't feel like you may as well disclose this, but it's worth reevaluating if something like that is to occur. On the happier end, the benefits or the chance of benefits will increase when there are things like the potential for access to networks or other resources. This could be support groups, this could be scholarships. You also might hit thresholds where what was a liability is seen as admirable. For example, if you are worried about someone finding out your age because you're in the workplace and you're in your 50s, which is kind of a peak range for age discrimination to occur, then when you hit 70, you might want everyone to know that, because everyone will be very impressed that you were still at the top of a technical field in your 70s. And so that becomes something to brag about a little bit more. Finally, you might see benefits resulting from career evolution over time, causing you to adjust your threat model. This could be something like moving into a management role. This could be something like changing careers altogether. And those are also a great time to reevaluate the risk that you previously knew that a certain piece of information being revealed would pose to you. Next, we are going to talk about constructing your personal privacy mosaic. And this first pass through is just going to be very abstract with examples of some types of information that everyone has. Then we'll go into the real example afterwards. As the very first step of this, I like to list the information that I care about protecting in that column A or on the y-axis. I really like to use a spreadsheet for this because you can do things like color coding and leaving comments. If you don't want to use a spreadsheet for this and prefer to have only a physical copy, you can do this physically. It's just going to be slightly more annoying later on. Here I've mentioned legal name, birthday, and date of birth as information that exists about everyone and that you may want to consider including in your own privacy matrix. Consider leaving a comment about why you care about that information for when you revisit this later in case the underlying reason changes too. Next, list all of the places your information is disclosed along the x-axis. You can approach this like brainstorming with no wrong answers. This is also what we talked about earlier on the 2-column slide, where you listed out first all the places that you reveal information about yourself, and then all the places that other people reveal information about you. You might want to use 2 different colors to indicate this so that you can easily see which media you control versus don't control, because that's going to be useful to you later. You also might decide that you don't want to color code anything right now, you just want to get it all onto the page. That is an equally valid approach. I've included a couple of examples of things that many people in our industry have. If you don't have these things, I'm sure you have other things. You'll also want to go for a very high degree of granularity in this first pass, because you can always break it up later. If you're doing this on paper, you will probably want to be specific about like my Yahoo email account or my Gmail #1 with the full address. But if you're in a spreadsheet, then you can always start with just the general category like email or Twitter, and then break it down later as it becomes relevant to those pieces of information so that you have the specifics only when you need them. When you're done with that, test your hypotheses. Check for the information along the Y and the sources along the X. Try those ways of getting your information and make a note if you get close but you don't quite get it. In this case, I'm saying that imaginary person had their Twitter with their legal name, they had their birthday on their Twitter, and they didn't have date of birth on Twitter. But I made a note that you could maybe get this by looking for happy birthday messages in case anybody gave an age, like a milestone is especially a time when this happens. Happy 40th, happy 25th, happy 50th birthday. Those are times when your age might be revealed, and because your year of birth isn't going to change over time, you can go back in time to find one of those milestones to see if it was maybe revealed at those times. Once you've finished with that, take a look and see if there's another way to get the last bit that's missing, those ones with the comments on them. You might be missing an information source. You can keep adding more information sources along the top edge at any point in time, either as you're going through this privacy matrix the first time, or over time when you create a new account, you might want to add it to make sure you're evaluating it the next time that you go back to this. This is your own matrix, and you can really make any changes that you want to it. So I do encourage customizing to make it what works for you. The final step of this is deciding on possible actions. I like to color code for this part. Here you can say that green is no action needed because those were not actually information that they cared about, or because they reevaluated to decide that those are not information that they care about. The blue is look a little harder, and there might be a red for something like reevaluate threat model. It's important to revisit at this point whether you still care about protecting that information now that you've found it. It may be that it is readily available kind of everywhere, and if there wasn't something bad that happened from it being readily available everywhere up to this point, then maybe you don't care as much anymore. But it also might be that it is readily available everywhere and you need to start cleaning up now. Also, consider whether somebody else could make this leap without the context that you have for your own life. You know a lot more about yourself than someone else who is looking for information about you is going to know. And in some cases, it's possible to get information about yourself through really context-based OSINT leaps, wherein you have information that allows you to jump from one fact to another fact that someone else is probably not going to have. If you're worried about a specific person or group getting information, you get to consider that person's context specifically. So for example, if you are a dancer and you know that people who dance at a certain spot tend to go to a certain restaurant afterwards, and you don't want your presence at that restaurant to be known, but you know that this person is not a dancer, is not friends with any dancers, and would probably not have dance-based information, then you might be less concerned with the information getting out and that person finding it, versus someone who was a dancer and who would have all of the context for, oh, if you were at that dance, then you will be at this restaurant at this time. Finally, consider whether there are things that you need to avoid disclosing to keep from making the information that you still want to keep private discernible. If it's information that you still care about protecting and it's not quite released, but it is getting close. If you want to be really thorough about your own personal information model and what information might be released, there is this super thorough, very technical book called The Science of Quantitative Information Flow by Alvim et al. I first heard about this from Maria Herrado in her excellent talk at this year's Diana Initiative called Ooh, You Are Leaking, A Formal Introduction to Information Leakage. And this has a whole bunch of proofs and kind of technical instructions for evaluating information leakage. If you want to go that deep, this is an excellent book. If you don't want to go that deep, most people probably don't have to. So don't worry too much about it unless it sounds like fun to you. Finally, the example matrix. This is based on my Wonderland privacy model, where Alice and Bob are visiting us, and we are showing them an example of a threat model that is not actually mine. This is how you would get information about me that I don't actually care about, and we are going to walk through a few specific paths without tempting the audience too much. First, start with your example matrix. You may decide that this is a physical matrix. You may decide that this is a digital matrix. Whatever it is, get your thing ready. Then, in case anybody's wondering, again, we are not tempting the audience, but I am going to show you how, if I did care about keeping this information secret, I would be at risk from somebody finding it. I like to put the information stuff on the y-axis specifically because even though these examples are all pretty short, you will often come up with something longer, like that I will be going to Hawaii in November 2021, which isn't true for me, unfortunately, but would be very unwieldy on the x-axis. And those information sources tend to be shorter names. And so they work a little bit better if you put them in the row on the top. You can also think of these as like the independent and dependent variables on a graph. The independent variables are what information about you is shared because some of it is in your control, but a lot of it isn't. And then the dependent variables are based on that information. Is this fact public? For this example, we are going to look at Joan Jett concert attendance, a previous employer, and my hometown. On this slide, we have a list of places that you could be able to find the information. If it's your first time doing this exercise, you might want to color code the information sources by whether they're under your control or not. But if your matrix is easy enough for you to follow without that, that's fine too. You won't need it either way until the evaluation step, but it can also tell you how fast to go through this part, because hopefully you at least kind of remember the things that you listed. Here we're looking at Twitter, LinkedIn, and it says Google News results. We're going to come back to that in a minute. So here, for the Joan Jett concert attendance, this is a great example where you might not realize what you've said, but if I was able to figure it out and I didn't rely on any information that was specific to me having it, somebody else could probably also figure it out. In this case, I posted a tweet on July 20th that said, I somehow made myself a calendar invite that said only Joan Jett tickets available with no information about when or where she's playing, noticed within an hour of the tickets going on sale, and managed to figure out what I meant in time to sit here and reload the page for it. This implies both that I was trying to get these Joan Jett tickets and that I cared quite a bit about them. In the comments, you can also clarify that the ticket sale was happening at that time when I posted this. And you could tell exactly which show I was going to by Googling for where Joan Jett tickets launched at this time on this date. Normally, I wouldn't tweet something like this because it would give away my physical location at a certain time. But I'm at least 50% flaky right now because of ongoing risk reassessment related to the pandemic. And so I figured a 50% chance that I was going to be in a place at a time was safe enough for me personally to tweet, given the risks that I face. If you looked it up, you would also learn that this was the concert at Stern Grove in San Francisco. And if you've ever been to Stern Grove, it's very hard to find a specific person there, even by prior agreement. So this is also a lower risk piece of information to release than if I was going somewhere small. You might notice that one of the sources has now changed in this slide because I realized partway through that the tab I had open was actually DuckDuckGo's general search results, not Google News. This is going to happen, especially if you're doing the full matrix, which is going to have generally like dozens and dozens of different information sources about yourself and can get a little bit overwhelming in some cases. You can update those information sources as needed, fix errors, add new ones, remove old ones where it turns out that there actually wasn't anything that wasn't shared elsewhere. Even if there's information that's not shared elsewhere, I find it personally valuable to continue to include that, because if I decide that I want that information to be shared nowhere and I've removed places that it was all duplicated, then I will still have missed a couple spots. It's also nice to start with a couple of sources where you know you have a lot of information and then add more complex bits as you expand your analysis. When I can combine information from multiple places to reconstitute it, I'll put a little note like with other source to indicate that this can come together. You can also decompose a single piece of information, like I could possibly break row 2 into 2 different rows to talk about Joan Jett tickets and concert attendance to see if you can get those 2 facts and combine them, even if you couldn't get the whole thing all together. Here, I did find the full information that I needed about Joan Jett concert attendance on Twitter in combination with public Google pages that were not actually about me. I was also able to find a previous employer on Twitter. It's right in my bio. And my hometown was not directly listed on Twitter, but I feel like you could pretty easily guess it from the kinds of things that I was retweeting, some of the photos that I've posted, as well as some of the regionalisms in my speech, which also shows up in Twitter. LinkedIn did not have the Joan Jett concert attendance, but does have the previous employer, and my hometown is specifically stated. The DuckDuckGo results did not have any information about that particular concert, but did again have the previous employer and the hometown specifically stated. The next step would be to decide on the actions that you want to take. In this case, because I don't actually care about any of this information being public, I don't really have actions to take. But let's pretend for this Wonderland example that I went into this not wanting people to know my hometown or that I had Joan Jett tickets. If I were really doing this, I would have not included the thing that I didn't care about to begin with, but this is Wonderland. Now evaluate whether you still care. Looking at the places that this information is available, I might decide that it's really not worth trying to hide my hometown, because some of the information that gives it away, like my speaking voice, is really beneficial to me to keep public. I may still care about the Joan Jett tickets being found out though, because I'm really not getting a ton of benefit from leaving up that tweet about my ability to decipher a cryptic calendar reminder. Now we'll think about whether somebody else could figure this out. Because we no longer care about the hometown and we never cared about the previous employer, we're going to look at just the Joan Jett tickets. I'm a pretty good Googler, but based on how easily I found which concert it must be and how none of the information that went into that sort of search was a secret or specific to me, somebody else could definitely also figure this out. Next, what can I do about it? If I really wanted people to not know where I would be during that concert, the first thing to do would be to delete that tweet. It's not a super interesting one and it doesn't have huge engagement numbers, so my risk model probably means that nobody will remember if I just get rid of that mention. If I knew that someone was deliberately monitoring or saving my tweets, then that would be a very different risk model. Similarly, if I were a super famous Twitter celebrity with 100,000 followers, deleting the tweet probably wouldn't be enough, and I might want to take additional actions, like skipping the concert if it was really important that somebody didn't know where I was at that time, or providing false information that would make people think that I would be somewhere else at that time instead. Hopefully, during this, you've thought through the potential privacy implications of combining information about yourself from different sources, and how you can analyze the information that already exists about you to know what's out there about yourself before somebody else does. In some cases, you might find that a particular site you use isn't providing as much value to you as it is increasing your risk, and to decide to delete your account or file data deletion requests like those available through GDPR, CCPA, etc. In other cases, you may find that a piece of information you thought was a secret has been on the front page of your Google search results for years and wasn't actually the threat that you thought it might be. By knowing where your information is, you can make informed decisions about what additional information you want to release about yourself. Thank you to the Crypto and Privacy Village for having me here, and to all of you for watching this talk. A live Q&A will follow shortly if you are watching the live stream of this, or you can reach me on Twitter at Maggie Farrow or on LinkedIn at Margaret Farrow at any time after this, and I will do my best to respond to questions. Thank you very much and enjoy the rest of the conference.
I just realized I was muted the entire time for just now. Thank you so much for joining us for this Q&A. That said, Margaret, I would love to have some questions answered from you today. So I guess personally, first of all, just my own personal question of like, I have blue hair, I have EFF stickers, like, what do you recommend for me and my matrix? Because it's kind of hard to hide.
Yeah. And I think those are great examples of pieces of information that you have chosen to share about yourself and that you're getting great value out of. Those are going to help you find people that you want to be friends with, find affinity groups, and that you have decided are worthwhile to you, more so than hiding that there is a hacker here.
Nice. All right. And from our Discord, we have a few questions. Let's start off with, do you think OPSEC is necessary even if I don't have anything to leverage? But what are the possible misuses of any of my public data? Are there any risks unless and until I piss someone off?
Those are all great questions, and I'm going to go like a little bit in order there. First off, do you think OPSEC is necessary even if I don't have anything to leverage? It really depends on what you mean by OPSEC. If what you mean by OPSEC is attempting to achieve total secrecy across all parts of your life, then no, that's not worthwhile. I do think it's important, however, to consider ways that your individual situation or your society might change around you to make information that you are revealing now potentially riskier to you later. For example, if you are of a minority religious group in a country where every couple of decades or so the attitudes towards that religious group change, then you might be more hesitant to reveal that in public settings, even if it's not necessarily a risk to you right now. Similarly, a lot of young people often reveal a whole bunch of data about themselves because they say things like, I'm not very interesting or no one should care. But then as they get older, they become very interesting. And some of that information is kind of immutable. Things like your date of birth, things like whether you have done certain things in the past don't ever change. And so it's worth considering potential future risks that could come from that based on plausible changes in your own personal future. If you are, for example, totally disinterested in politics, then the risk that would be posed by a certain piece of information, if you were to become the president of the United States, or if you're not eligible to be the president of the United States, then the risks that would be relevant if you became the president of the United States are not ones worth optimizing for. However, it is worth considering that a lot of parts of your situation may change over time. In terms of the possible misuses of your public data, one of the biggest ones is fraud and identity theft. That's something that literally everyone is at risk for. There are different ranges of possible misuses of other data points based on the data point, your specific demographics, and kind of a lot of other really granular details that I wouldn't want someone to share in that channel. But if you do have questions about specific types of data that you're releasing that you're unsure of, I would happily talk through that with anyone who wants to DM me on Twitter. The handle is in the slides, which I think will be posted in addition to the recording. LinkedIn, I'm sometimes a little slower to respond, but you can try there too. In terms of risks outside of upsetting someone, it really depends again on the social situation. I know there's a whole bunch of it depends here, and that's part of why I think it's valuable to build a personal privacy matrix for yourself, because no one on the internet can tell you that something needs to be kept a secret or needs to not be kept a secret, with very few exceptions like passwords. When you evaluate your data for yourself, you will be able to make those decisions and have a better feeling for how those decisions might shift over time for you.
I think a great follow-up that we got in the channel was any guidelines for determining which pieces of information or combinations of information present lower or higher risk.
Yeah, that's a great one. As you are approaching the initial design of your matrix, it's important to first think about whether there's anything that you feel apprehension about in general right now. If you are maybe queer but haven't come out yet, that's probably a persistent thing that you're feeling a little uncomfortable about. And so that's something that would be higher risk to you right now. If there are other sorts of things that you tend towards keeping a secret, think about why you want to keep them a secret and whether there's any benefit to releasing those pieces of information, despite the fact that there's a little bit of that tension there. This really is first and foremost an exercise about introspection and figuring out what really matters to you right now. In terms of broader roles, you can also look at things like recent news stories, especially for your state or country, or this is a really good exercise to do around the time that you're moving, because then you have a little more control than usual about who has your address related data, as well as a little bit more knowledge about which laws are about to change for you based on how far away you're moving. And taking into account kind of the social situation that you exist within and combining that with how you as an individual feel about those pieces of information can really help you strike a good balance in terms of which pieces of information you might want to dig a little bit deeper into.
I think that was a really solid answer, and thank you so much for answering that. So I think this kind of starts getting to a little bit more specific territory, and it gets more specific afterwards, but in the United States, if you are a property owner, your property address is actually public information. There were some questions about, like, are there any clues, hints, or ideas for how to like fix that. And someone also said, is it possible you could buy it through like a corporation, like an LLC or a single owner S corp, using an alias ever online? Like, what would you like recommend? Or is this something you would like defer? Like, I have no idea.
Yeah, I'm not personally a property owner, but I am aware of a number of different things that people do to try to preserve their property or preserve their privacy when purchasing properties, especially within the United States, because we do have that norm of releasing people's names in conjunction with what is usually their primary residence address. One of the biggest things is purchasing through a company or they mentioned an LLC or a single owner S corp within the channel, and that will prevent your name from being tied directly to it. In many cases, your name can then still be tied to the corporation. So you need to be very careful if you're trying to take that approach for this purpose. Another approach that I've heard of people taking is purchasing a house that is not the house they actually want to live in and renting a different house to live in at a similar price to the mortgage on the house that they own, so that they can reap the benefits of property ownership without actually releasing the address that they spend most of their time in. If you've already purchased the property, then there's a lot less you can do in terms of, you can't put the cat back in the bag. In certain circumstances that vary drastically depending on your very specific geographical location, you may be able to have the address information redacted and kind of retroactively removed from requests for records. But that is usually a very high bar, and you typically have to have already experienced credible threats by the time that you can get that sort of redaction done. So the options are really not great.
That is really solid. I personally don't think I'll ever own a house, but that's really cool to know. Awesome. We got a question on like, do you have any recommendations on sites to help find public information yourself? Also, you kind of touched on this quickly, but do you feel seeding misinformation is useful in hiding information?
I'm going to do those as kind of two separate things because I feel like they're often not super related. My first recommendation for sites to find public information about yourself is search engines. Check the Yandex results for your name, check the Google results for your name, check the Bing results for your name, and check the DuckDuckGo results for your name. They're all going to be different. Each search engine chooses which things to index differently, and the ones that you are less likely to use as an individual searching for information are more likely to have more sketchy pages that will have some of your information on them. If you are already using the dark web for other purposes and you feel comfortable navigating it, then there are certain dark web sites that a lot of people researching in this area like to use. You can also, in some cases, get like a dark web search or dark web monitoring service, it's often called, which is really just somebody going and searching for your information on the dark web regularly on behalf of often your bank or credit card, typically after they've been breached. Really starting from search engines is a very powerful way to figure out what types of sites have information about you if you're not aware of what your personal privacy landscape looks like yet. And then as you get used to what kinds of search results you'll see, you will know which sites you might want to go to directly to look for more information in future iterations of this exercise or similar exercises. Moving on to the second one, in terms of how useful seeding misinformation is for hiding information, it's really going to depend on your skill at that and how you approach it. If you seed a bunch of misinformation that says you're going to be 10 different places at the same time, then often some of those will be less plausible than others. There will be enough of them that it will be clear that some of them are not true. Whereas if you do something like, oops, changed my plans, I can't go to that concert anymore, then that's going to be something a lot more plausible seeming to someone who is trying to use that information.
Awesome. I don't know if there are any more questions. But thank you so much for your talk, Margaret. Do you have any final words you want to say for today?
Thank you, Avi, for all of your work in hosting this and keeping the OBS running. Thank you to everyone in the audience for joining us and for staying this late on a Friday night. I hope you all get to go enjoy some really cool contests now. I know I'm very excited for some contests coming up this evening. Thank you very much and have a great evening.
Awesome. All right, for everyone joining the Gold Bug Challenge, just keep working on that. We will have more stuff tomorrow on that. We'll be opening the village again tomorrow at 10 a.m. See y'all tomorrow. All right. Oh no, where's OBS? Oh no, sorry, hold on 1 second.